How's it going, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys everything you need to know to get started with Java, so sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Here's an outline of the topics covered in this video. If you would like to skip ahead to a certain section, feel free to click on any of the timestamps posted in the description. Also, at the end of this video, we're going to be discussing some tips and tricks, so be sure to watch until the very end. I'll give you 3 reasons why you need to learn Java. Besides being one of the top 3 most popular programming languages worldwide, Java is an extremely flexible language. It's used extensively by business enterprises, Android apps, games, and if you learn Java, you could land a job as a Java developer. According to Glassdoor, entry-level Java developers have an average starting salary of $70,000. That's nothing to sneeze at, so why not learn Java? Are you still here? Okay, cool. Let's begin with the basics. Computer languages are on a spectrum between being high-level and low-level. Computers only understand binary. It's referred to as machine code. It's a low-level format that a machine can understand. However, humans have difficulty reading binary since it's all ones and zeros. To create machine code, we write in a format called source code, which is understandable by humans, and compile to machine code. When we create Java source code, the file ends with a .java file extension. Think of compiling code as transforming source code to machine code. We do this because machines can't read source code and vice versa. Humans have trouble reading machine code, unless you're a robot or an android or something. However, when we compile our source code to machine code, it's machine-specific. If we write source code and compile on a Mac, we can only run that code on a Mac, and the same concept applies for PCs. Although, the Java language has a solution for this problem. With Java, we have an intermediary step where we can compile our source code to a format called bytecode. Bytecode is cross-platform and ends with a .class file extension. Here's an example of Java source code, and here's an example of that same source code after we compile it to bytecode. It's kind of funky, right? Since bytecode is cross-platform, you could write your code on a Mac and then send your bytecode file to your friend who can then run it on their PC using a JVM to translate the bytecode to machine code. But we are going to need the help of a JVM to translate bytecode to machine code. But where can we get a JVM? Well, it's included with a JDK. And what is a JDK? Well, JDK is an acronym for Java Development Kit. It contains developers' tools to help us code, as well as a JRE, a Java Runtime Environment, which contains a library, toolkits, and our JVM, which is another acronym for Java Virtual Machine, which translates bytecode for us to machine code. So all you need to worry about is downloading a JDK, and everything else will be included. And now that we know what a JDK is, it's time to download one. So open up the internet and go to any search engine and look this up. Java JDK download, go to the first link, Java SE downloads. SE stands for Standard Edition. Go to JDK download, scroll down and find the appropriate file for your operating system. Since I'm running Windows, I'm going to download this EXE version. Agree to whatever, and download. And when this finishes downloading, I'm going to open this. Open when done. On my computer, I currently have a JDK already installed, but I'm going to go ahead and reinstall it for the sake of this video. Click Next, Next, then wait a little bit, and close. I would also recommend an IDE. That's another acronym, and it stands for Integrated Development Environment. Think of it as software that helps us write other software. You could write code with a text editor such as Notepad and then compile the text file, but doing so is not really beginner-friendly. So an IDE provides an interface for us to write code, check for errors, compile, and run code. There's 2 IDEs that I would recommend. They are both Eclipse or IntelliJ IDEA. It doesn't matter which one you download because the code that we write is still the same. So let's download an IDE. Now it's time to install the IDE. I would recommend either the Eclipse IDE or IntelliJ IDEA. I'm more comfortable with Eclipse, so I'm going to stick with Eclipse. So go back to the interwebs and look up either Eclipse IDE or IntelliJ IDEA IDE. So I'm going to look up Eclipse, click the first link, click this orange download button, go to download packages, and select Eclipse IDE for Java developers, and select the correct download for your machine. I'm going to select the download for Windows, and click download. And then just wait a little bit again, like usual. For me, this is currently a zip file, so I need to select this file and extract all. With the newly extracted folder, navigate to this Eclipse application. So you can select this to launch Eclipse. For convenience, I'm going to create a desktop shortcut. So for me, I'm going to go to, where is it? Send to, create desktop shortcut, and then click to launch. You can select a workspace. I'm going to use the default and click launch. We are now within Eclipse and we can begin a new project. We are now ready to rock and roll. So let's begin by creating our first Java program. But in order to do so, we need to create a Java project. If you're brought to this welcome screen, you can close out of this because it's annoying. And in order to create a Java project, navigate to your Package Explorer and select Create a Java Project. If you're missing the Package Explorer, you can go to File, New, Java Project, and that will take you to the same place. We need a unique name for this Java project. I will call this My First Program. And I will want to configure the JRE, the Java Runtime Environment, and we downloaded that with the JDK, because the JRE is a component of the JDK. So I'm currently using 13. I'm going to change this to 15. That was the one that I more recently downloaded just now. So go to Configure JREs, and I'm going to click Add. Select Standard VM. VM is Virtual Machine. Click Next. Go to JRE Home. Go to Directory. And I'm going to make sure that I'm selecting the most recent JDK. For me, that is 15. Select Folder, Finish, Apply, Apply and Close, then Finish. If this window pops up, you can select Don't Create. That's to create a module. If you look to the left-hand side within the project folder, we now have a Java project called My First Program, but we will need to add what is called a class to this project. A class is a collection of related code. So in order to add a class to this project, I'm going to select this project folder, then go to File, New, Class, and we need a unique name for this class. I usually call this main, but you can name it whatever you want. And then we are going to check this public static void main checkbox, and then click Finish. With that out of the way, take a look back within your project folder, and you should now have a Java file that shares the same name as your class name. My class name is named main, therefore my Java file is also called main. So this has the .java file extension, and with what we discussed before, this is source code. It's in a format that humans can easily read and understand. And when we compile this source code to bytecode, we're going to create a new file that has the .class file extension. And with that bytecode file, we can run that and translate it using a JVM, a Java Virtual Machine. Here's our Java file, and we have our class, and mine is called main. So all the class is that it's a collection of related code. We won't be exploring in depth on the topic of classes until we reach the subject of object-oriented programming, which is about 20 videos into this playlist, so you have some time. So this is our class. Mine is called main. Anything within the outer set of curly braces belongs to the class and is contained within. And within our class, we have what is called a main method. Our program won't run without this method because when we run our code, we begin by calling the main method. So if we were to compile and run this code, you can do so by clicking the screenplay button. All output is displayed to the console window, and nothing appears to happen because we haven't written anything yet. So if we were to remove this main method and tried to do this again, we would encounter an error because our main method was not found in the class main. It's asking us to please define the main method. Now, looking back, when we created our class, we went to File, New, Class, and in order to generate the main method, we checked this checkbox here that states public static void main. So the main method generated for us when we created this class, but if we're missing it, we can easily just type it in. A textbook that I read in college said to think of the main method as a magical spell or incantation that we have to say in order to get this program to run. So we are currently missing a main method, but we can easily just type it in. So repeat after me. Public static void main, then we need some parentheses, string, straight braces, args, and then a set of curly braces, and that is it. We now have a main method. And our program runs and compiles just fine. So any code within the main method will execute starting at the top and then work its way down. So with the main method, any code you place at the top will be executed first. So let's print something to the console window. In order to display some text, all you have to do is type this: system with a capital S dot out dot print. Then you need a set of parentheses and then a semicolon at the end. So within the parentheses of this print method, we can type some text to display to the console window, but we need to make sure that our text is within a set of double quotes, and we can display some text. Let's say, I don't know, what's a food you like? I love pizza. So if I were to run and compile this, it's now going to print I love pizza to the console window. Let's say that we would like to display another line of text directly underneath the first. We can accomplish that by using another print statement. So for convenience, I'm going to copy this first line, paste it directly underneath, and display some other text, such as, it's really good. So when I compile and run this, pay attention. The output is one long line of text. The reason that this is all displaying as one long line of text is because after printing the first statement, our cursor does not move down to the next line. In order to do so, we could use a println statement, short for print line. It's as if we're hitting enter when we finish outputting our text. So let's try this again using a println statement. And now each line of text is on its own individual line. So that's what distinguishes a print and print line statement. A print line will add a new line character as if you're hitting enter when you finish outputting your text, whereas a print statement does not. So that's the difference between the two. An alternative to using a print line statement is that we could stick with the standard print statement and at the end of our text add what is referred to as an escape sequence for a new character. Now, an escape sequence is a character preceded with a backslash, and one of a few characters that follows directly afterwards. This is an escape sequence for a new line character. When we add this escape sequence for a new line, it's as if we're hitting enter wherever we place this escape sequence. So within our string of text for our first line, at the end, we're going to add \n, and this will have the same effect as a print line statement. It's going to display our text and then move the cursor down to the next line. As you can see, there is no additional change to the output within the console window. Now, what if we reverted our print statements back to print line statements and kept the additional escape sequence in for a new line character? Well, we're going to have an extra empty line of text because we're displaying our line of output plus an additional character for a new line, and then we're hitting enter at the end via the print line statement. So we're going to have an additional empty line between these two lines of text if we were to do that. So a few other escape sequences that you might be interested in include the following. A \t will add a tab. So let's precede our text with an escape sequence for a tab, which is \t. So this is if we're hitting tab before displaying our text. And we now have some empty space preceding our line of output. If you need to put something within quotes, let's try to do so normally. So our compiler is actually going to be confused because we cannot normally add a set of quotes because our text already needs to be surrounded with quotes. So if we need to literally display some quotes, some double quotes, we need to precede our double quotes with an escape sequence. So \, then quotes. So this will allow us to literally print some double quotes. So we're going to surround our first line of text with some double quotes now. And if you need to display a backslash, then you need to use double backslashes. Because if you use just one, your compiler thinks you're trying to use an escape sequence. And that's how to display a backslash. In summary, anything preceding with a backslash is the beginning of an escape sequence, and there's one of a multitude of characters that could follow afterwards. And depending on the character, this has special meaning for your compiler to do something specific. Now, anything that is following 2 forward slashes is the beginning of a single line comment. I could write, "This is a comment," and this line of text is going to be ignored by the compiler, so there's going to be no change to this program with the additional comment. Anything that is a comment is ignored by the compiler, so it's useful if you need to leave yourself a note or for somebody else that's looking over your code. If you need a multi-line comment, that is a forward slash followed by an asterisk. And anything up to an asterisk and another forward slash will be the bounds of this comment. So I could write, on a new line for each word, "This is a comment," and all of this will also be ignored by the compiler. So that's how to write a multi-line comment, a forward slash and an asterisk, and anything up to another asterisk and forward slash. So those are comments. All right, ladies and gentlemen, it's time for this section on tips and tricks. And for my first trick, I'm going to change the color scheme of my IDE. We're currently using the light theme, but I much prefer the dark theme. I'm going to be joining the dark side. So in order to change the color scheme of your IDE, go to, if you're using Eclipse, Window, Preferences, under the General tab, go to Appearance, Theme, and you can change the theme here. I will click Dark. I'm going to select Apply. OK, and then Apply and Close. So the dark theme is great if you want to feel like a pretend elite hacker. For my next trick, I'm going to change the font color as well as the background color of my console window. In order to do so, head back to Window, Preferences, under Run Debug, go to Console, and you can change the color schemes here. I'm going to change the text color to a bright green, click OK, as well as the background color to a slightly lighter shade of black. That should be good. When you're finished, click Apply, and then Apply and Close, and you may need to run this again to see the changes. So that's how to change the font color as well as the background color of your console window. So it's somewhat tedious to have to write a printline statement, correct? System.out.println. Normally that's a lot to type, so a shortcut would be to type sysout, then hold Control Space, and your IDE will auto-generate the rest of this printline statement for you. Let's move on to trick number 4. Let's say that we have hundreds of different print line statements and we need to change the text to print because we made a mistake. So there's a feature where we can replace some text in your program with another. So let's pretend we would like to replace print line with print. So go to Edit, find Replace, and we can replace some text with something else. Let's find each instance of print line and replace this with print. Then click Replace All. So that will take care of all that for you. Let's move on to some final tips. So with spaces, spaces don't make much of a difference within your code. For example, after this dot and my print portion of this print statement, I could add a bunch of spaces for no reason, and this would run and compile just fine. I'm not sure why you would do that, but that's just to reinforce the point that spaces don't make much of a difference. Unless you're using a space to split up some keywords, then you might run into an issue, or if you're adding space to a string, well then that's going to have a noticeable effect. So spaces, for the most part, don't really matter too much, depending on where they are. Here's a trick on zooming in or out. Hold Control- to zoom out, or Control+ to zoom in. Or you could go to Window, Editor, then zoom in or zoom out within this menu. Here's my last tip for you. Let's say you accidentally close out of your Package Explorer or your console window. You can easily bring those back by going to Window, Show View, and then they are all listed here. So I would like to bring back my Package Explorer as well as my console window. Alright guys and gals, you should be ready to get started with Java. Be sure to check out the full 100 video playlist as well. And if you could do me a small, tiny favor, I would greatly appreciate it if you could help me defeat the YouTube algorithm by smashing the like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey you. Yeah, I'm talking to you. If you learn something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about variables in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, let's talk about variables. Now a variable is a placeholder for a value, and it behaves as the value that it contains. Do you remember from either elementary school or middle school when we were working with algebra, we usually had to solve for some sort of variable like x or y, and x or y contained some sort of numeric value, and for all intents and purposes, this variable behaved exactly as this value. Well, with programming, we can perform something similar to that, but we are not limited to just numbers. We could also store words, whole sentences, and these things called Boolean values, which hold either true or false. But if we're going to store a value within a variable, we have to list the data type of what we're planning to store within that variable. Is it going to be a number, a word, a Boolean? So we need to discuss data types. There are 8 primitive data types and a special reference data type called a string. Anything that I have noted with a star is particularly important, so I would pay special attention to these. Our first data type is Boolean. This has a size of 1 bit, so it can only hold 2 values, that being true or false. If we're attempting to assign a Boolean value, we would type either equals true or equals false. Something similar would be, let's say we have a light switch program. Well, if the light switch is on, we could say that the light switch has a value of true. If it's off, it has a value of false. So this is binary. That's why it only uses 1 bit. It only needs 1 bit of memory to function. Next, we have byte. This isn't as important as a few others, but with 1 byte, we can hold an integer number between -128 to 127 because a byte only has 1 byte of memory. A short has 2 bytes of memory, so it can hold a larger number between -32,000 and some change to 32,000 and some change. So integers are important. These use 4 bytes of memory, and they can store a number to just under 2 billion to just over 2 billion because they use 4 bytes of memory. And a long, they use 8 bytes of memory, so they can hold a very large number. In fact, they can hold a number between just under -9 quintillion to just over +9 quintillion. Now a float, they can store a fractional number, specifically up to 6 to 7 digits. What makes floats different from these data types on the top here is that bytes, shorts, integers, and longs can only store a whole integer. They cannot store this decimal portion. So if you're working with a program or a variable that uses a fractional number, you'll need to use either a float or a double. And a double has more precision. It uses 8 bytes of memory, and it can store a fractional number up to 15 digits. So in comparison with a float, this has less precision than a double. And for an example, I just listed a few of the digits of pi. With this example, we can only store 6 to 7 digits of pi, but with a double, we can store up to 15. There is one strange convention with floats. If you're going to assign a value to a variable that's of the float data type, you need to follow the value with the letter F. With double variables, you actually do not need to do so. So that's one major difference when assigning values between these two. Now let's move on to characters, pronounced char for short. Think of Charizard. This uses 2 bytes of memory, and this will store a single character letter or ASCII value. An example would be the letter F, but a common convention with assigning values to a char variable is that you need to surround this value with a pair of single quotes. And our last data type is the string data type. The size really varies because these are reference data types. They store a sequence of characters, like a word or a sentence. You could store a single character within a string, but chars and strings behave differently because chars are primitive data types and strings are reference data types. So let's distinguish the difference between primitive and reference data types. Here's a super quick description between the differences of primitive and reference data types. Primitive data types, there are 8, and we just discussed them. They are Boolean, byte, short, integer, or longs, all those cool things that we just discussed. Reference data types, like strings, well, there's an unlimited amount because they are user-defined. Primitives store data. Reference data types store an address. Primitives can only hold one value. Reference data types could hold more than one value. Primitives use less memory compared to reference data types, which use more memory. And primitive data types are faster compared to reference data types, which are slower. Now you're probably thinking, cool story, bro, but how do we create a variable? Well, I'm glad you asked that question. So the first process with creating a variable is that we need to declare the data type of what value that this variable is going to store. So come up with a variable name like x, and we will precede this variable with the data type of the value that we're planning to store within this variable. And then with all statements, we follow this with a semicolon at the end. The next step is called assignment. We will take our variable and assign it equal to some sort of value of the data type that we declared this variable to be. But you could combine steps 1 and 2 together, and this process is called initialization. We would take the data type followed by the variable name and set it equal to some value, and then add a semicolon at the end to finish the statement. So you can either do this in 2 steps with declaration and assignment, or combine them both together, which is initialization. How about we create a few variables? Does that sound good to you guys? So let's begin with creating an integer variable. Let's say int x. This step is called declaration. We are declaring the data type of what value is going to be contained within this variable. The second step is called assignment. We can assign our variable a value. Let's say x equals 123, and this step is called assignment. Or we could combine both of these steps together, and this process is called initialization. Int x equals 123, and this would be initialization. So we can do stuff with this variable. It will behave as the value that it contains. We could print this to the console window, so within a print or print line statement, we could print the value of x. So make sure you do not write this within quotes. Right now, this will display the value that is contained within x, which is 123, because this variable behaves as the value that it contains. If you were to surround this with quotes, what we are doing now is printing a string literal. You can also print text as well as a variable together. Let's say we have a sentence, a string literal that states, my number is, and then if we want to do some string concatenation with a variable, we would add plus and then the variable name. Make sure this is not within quotes. So this will display the sentence, my number is, plus our variable. And in the console window, it states, my number is 123. So with integer variables, the largest number that you can store within an integer variable is just over 2 billion. Let's say we are working with an extremely large number, like the amount of student debt that I owe. Well, this number is too large to store within an integer variable. We would probably want to use the long data type. And one convention with assigning values to a long variable is that you need to follow this number with a capital L for some reason. So we can now work with extremely large numbers. So this might be useful if you're working with numbers like the speed of light or something. So we now have a long variable and we can display this value. A few of the other data types that we mentioned were bytes and shorts. They have a lesser number that they can store. So with bytes, you can only store up to, I believe, 127. So we could store like 100 within here, and this would be fine, but 130 would be a little too much though. So we don't tend to use bytes and shorts too much as a beginner because it's just way more convenient to work with integers. But you might use longs every once in a while too. But as beginners, we're mostly going to be sticking with integers. Now, a double can store a number with a fractional portion. With integers, we cannot store a decimal portion. So if this was 123.01, well, we cannot store this decimal portion. We can only do so with a float or a double. So with a float, you would type in float for the data type. Let's create a new variable like y. Float y equals 3.14. And a common convention for assigning numbers, well, values to float variables is that you have to follow this with f. So you can store a number with a decimal portion within a float or a double, and then we could display whatever this value is. So y is equal to 3.14, but people tend to use doubles more because they have more precision, and then you do not need this f at the end. So this will store up to 15 digits after the decimal portion. So we also have booleans. Let's say boolean z equals, this holds either true or false. And then we can display what value is within this boolean. So if we print our variable z, this will display false. Or we could hold true, and this will display true, but we can't display anything else besides those two. Like we cannot hold the word pizza because booleans only hold true or false. We have characters, char for short, char, and we don't necessarily need to come up with a variable that's only one letter. We could have a name or something that's descriptive for this. Let's say we have a variable called symbol. Char symbol equals, and then place a character within single quotes. Let's say we want the @ sign. So we now have a variable called symbol that contains the @ sign. So if I were to display this variable symbol to the console window, it will display the value that is contained within, which is the @ sign. And lastly, we have strings. So with strings, these start with a capital S because they are of the reference data type. Anything that's a reference data type begins with a capital letter. And let's say we want to store our name. So string is the data type. Let's say the variable name is name equals, and to store a string, it works similar to a string literal. We're going to use a set of double quotes and display or add a bunch of text like my name. And then I can now display my name to the console window, or I could do some string concatenation too and display the word hello plus my name. And within the console window, it's now going to display hello, bro. So that is everything you need to know to get started with variables in Java. If you would like a copy of all this code, I will post all of this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can swap two variables using Java. Let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. All right, well, here we got two variables. We got variable X, which contains water, and variable Y, which I'm gonna put Kool-Aid in. More specifically, black cherry Kool-Aid. So let's just put this in. Good enough. And let's mix it. Perfect. So we're going to create two variables, and these are going to be of the string data type. So we'll have string X equals the word water, and string Y equals the word Kool-Aid. And then let's display these with a simple print line statement. And within here, I'll just type in X colon space plus the variable X. And then let's do the same thing for Y. So we'll change X to Y, and let's display these. So X currently has water, and Y currently has Kool-Aid. So what happens if we set X to equal Y? Well, we get Kool-Aid for both X and Y. Okay, we're gonna assign variable Y to variable X. Shit. So yeah, it looks like we have Kool-Aid in both variable x and variable y. Let's try again. Maybe we can set y to equal x. No, we just got water everywhere. Let's try this again. We're going to assign variable x to variable y this time. Okay, that doesn't seem to work. Guys, my floor is getting really sticky. So it appears that we're going to have to store one of these values within another variable in order to switch these. So one thing that we can do is introduce another variable, and let's call this temp, and temp is empty. Let's create another string. So we'll create string temp, and we can either set this to null, or we can assign no value at all, where we simply just declare temp a variable. So what we're going to do is actually take x and store x, whatever value is in here, within temp. So we are going to type temp equals x. So now x can be filled with something, so we're going to fill it with variable y. So on our next line, we're going to set x to equal y. Then we're going to take our temp variable and store this within y. And lastly, y equals temp. Breaking news, ladies and gentlemen, we have switched the contents of x and y with the help of our variable temp. Now back to you, bro. Thank you for the live update, Anchor Bro. It appears on our end that we have also switched the contents of x and y as well. So in conclusion, if the programming language you're using doesn't have any direct function to switch two variables, you could do this manually, and you can create another variable such as temp. And temp is a temporary value to temporarily store one of these values. You can set temp to equal x, or you can do this with y, and then set x to equal y, and then y to equal temp. So your assignment for today is to post two variables in the comments down below and the code that you used to swap them. And that, ladies and gentlemen, is how you can swap two variables. Hey, how's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys how we can accept some user input in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Welcome back, ladies and gentlemen. I'm going to explain how we can use a scanner to accept some user input. The scanner class is found in the Java utility package of your library, and we need to import that before we can use the scanner. So outside of the class, at the top of our program, this is what we're going to type. Import java.util, and the name of the class we would like to import, which is scanner. Then a semicolon. Now we can use the scanner class to create a scanner object. So we're going to be performing a little bit of object-oriented programming. We'll be covering object-oriented programming in a later part of the series, so don't worry. So repeat after me. Scanner, then we need a name for the scanner. Let's call it scanner, all lowercase, equals new scanner. Then a set of parentheses and a semicolon. Within the parentheses, we're going to type system.in. And there we go. We have our scanner. So we can use the scanner to accept some user input. So let's let the user know that we would like them to type in something, maybe a name. Let's create a prompt that will ask somebody for their name. So within a print line statement, we'll type, "What is your name?" And next what we'll do is take our user input and assign it to a variable, perhaps a string variable called name. String name equals, and now we're going to use our scanner. So we type in the name of the scanner, dot, and to enter a line of text, we're going to use a certain method of the scanner. It is the next line method. And when we type in user input, we type it into the console window here at the bottom. So let's do something with this name. Maybe display this within a message. System.out.println, hello, plus whatever your name is. So let's compile and run this. What is your name? Now our program is currently paused until we type in some user input and then press the enter key. When you press enter, that's how you submit some user input into the console window. So I'm going to click within my console window and type in something. I'm going to type in bro, and to submit some user input, you press the enter key. And it states hello plus my name, which is what I entered, bro. Now there's different types of input that we can accept. This time, let's accept only an integer number. Perhaps we can ask somebody for their age. So let's write a prompt for that. System.out.println. How old are you? And this time we will declare an integer variable, maybe called age. Int age equals scanner dot next, and we are looking for int. So we can only accept a whole integer. You are plus age plus years old. Okay, let's try this again. What is your name? Bro, how old are you? Let's just say that I'm 18. Hit enter. Hello, bro. You are 18 years old. So what happens if we do not enter in a number? So let's try and break this. What is your name? Bro, how old are you? We're not going to enter a number this time. Let's type in the word pizza and see what happens. Well, we encountered an exception. We encountered an input mismatch exception because when our scanner is looking for an integer, we typed in a string. So we need to make sure that the input type, the data type, matches. In a future lesson, we'll be covering exception handling, where we can prevent this very thing from happening. But for now, since we're beginners, we'll just have to be sure to type in the correct data type of the input that our program is looking for. Now, there's one more thing that I want to show you guys. This is a common problem if you use next line after next int or anything else that's not next line. So let's ask somebody for their favorite food this time. So let's add that at the end. System.out.println. What is your favorite food? Then we'll create a string variable called food. String food equals scanner dot next line. And we will display this. System.out.println. You like plus food. All right, so here are the questions. What is your name? Bro, how old are you? 18. Now pay attention to this when I press enter. When we reached the question on what is your favorite food, well, our program skipped our user input and continued on with the rest of the code. So it states, hello bro, you are 18 years old, but we were not able to input anything for our favorite food. Here's the reason why. Here's what's going on. Let's pretend that this box is a representation of our scanner, and we're going to use the next line method of our scanner to read a line of text. So we type in our name and then press the enter key to submit. So this \n is an escape sequence for a new line. The next line method will read an entire line of text and stop when it reaches a new line character. So after we call the next line method, our scanner is going to be empty. However, if we were to call a different method that doesn't read a new line character, such as nextInt, so we type in our input such as the number 18 and then press the enter key, that will add a new line character. So our nextInt method is only going to read this numeric portion of our scanner, and then when we submit it, well, this new line character is still going to be within our scanner. And if we were to use our scanner again and call a different method like nextLine, well, our next line method thinks that we're at the end because there's this new line character within our scanner. So we would need some way to clear out that new line. One easy fix for this is that after you call the nextInt method, what we could do is call the next line method to clear our scanner. So I'm just going to copy this portion and paste it. We're not really going to do anything with that new line character. This will just clear the scanner for us. So now we should be able to answer all three questions. So type in your name. What is your name? It is bro. How old are you? Let's say I'm 18. What is your favorite food? And you can see that it paused this time, unlike the first time. And my favorite food is pizza. Press enter. Hello bro, you are 18 years old. You like pizza. Well then, that is one way in which you can use a scanner to accept some user input. Scanners are capable of much more. You can also use them to read the contents of a file and a few other things, but we'll learn about those in future videos. And if you need to use a scanner, be sure to include this import at the top. Import java.util.scanner, because the scanner class is found within the utility package, and then you'll need to create a scanner object just by following these steps. Scanner, you can call it scanner, equals new scanner. Well, guys and gals, that is how scanners work in Java. Before you go, I would greatly appreciate it if you could do a favor for me and like this video, leave a comment down below, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about expressions in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Now, an expression is a combination of operands and operators. An operand is the values, variables, numbers, or different quantities that you might see in a program. And operators, they are those arithmetic symbols that you might see, such as the plus sign for addition, subtraction, multiplication, division, and then modulus. So let's go over a few examples just so that we know how they work. Let's say I have an integer variable called friends, and I will set this equal to maybe 10. So we can change the value of the friends variable by using an arithmetic expression. So let's say that we make a new friend, so we're going to add 1 to my variable of friends. To increment my variable friends, I can just use the plus operator and then add a new operand to my variable friends. So if I would like to assign a new value to my friends variable, I'm going to type in the name of my variable equals friends plus 1 because we made a new friend. And then I will print the value of friends. So our friends variable now contains 11. So we could also subtract. Take a wild guess as to what's going to happen. We just lost a friend. Let's multiply. Let's multiply our friends by 2. And now we have 20 friends. And let's divide. We're going to divide our friends into 2. And we have 5 friends. Now the modulus gives you the remainder of division. So we have 10 friends. What if we had modulus 3? Well, that does not divide evenly. So we're going to have a remainder of 1 friend. It's kind of like in group projects where everybody has to get into a group of 3 and there's always somebody that's left over. Think of it that way. Although if our group of friends was divided into groups of 2, there would be no remainder because 10 divided by 2 equals 5 evenly and there is no remainder. So that's all what the modulus is. It gives you the remainder of any division that occurs. Now there is a shorthand to increment a variable by 1. So normally the long way of writing this out would be type in the name of the variable equals, because we're going to reassign a value, friends plus 1, right? Well, there's a shorthand way of incrementing this, and that is to use the increment operator, which is just plus plus and then a semicolon. So this will add 1 to a value, and now we have 11 friends. If you want to decrement, that would be minus minus. And now we have 9 friends. Hold up, wait a minute. Before you go, I gotta discuss integer division because I forgot to talk about it. So if we divide a number by an integer, if there is normally a remainder, well, our program is going to truncate the remainder. Here's an example. Let's say we have 10 friends and we're going to divide our friends by 3. So we're dividing by a whole integer, so our result should be 3.33 repeating, right? Wrong, it's 3. That's because with integer division, we truncate any decimal portion because we cannot store it. One easy fix for that is we can cast our result as a double value or a float as well. To cast a value as a different data type, to the left-hand side of our expression, we're going to list the new data type that we would like to convert this value to. So we would like to convert our integer as a double value because we would like to retain that decimal portion of our result. However, our data type, friends, is an integer, so it cannot store a double data type. So we should probably convert this to a double so that we can store this value. And now this program will successfully store this decimal portion of our expression. Well, that's really all you need to know to get started with expressions. If you would like a copy of all this, I will post this in the comments down below. And if I could ask for a favor of you guys, just to like this video, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can make a very basic GUI application in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, I'm going to teach you all how to create a very basic GUI program. GUI is an acronym for Graphical User Interface. It's a visual program that we can see and interact with, kind of like this. So we'll be using the jOptionPane class and be creating a few message dialog boxes. Before we begin, we'll need an import. So outside of your class, let's type this: import javax.swing.jOptionPane. So we will be working with the jOptionPane class. Now, what we would like to do is type in some user information into a sort of dialog box, and we'll store this as a string variable called name, kind of like what we did on the video on user input. String name, and in order to create an input dialog box, we're going to type the name of the class, jOptionPane, dot, and there's a few options. What we would like is show input dialog, and you can really just pick any of these, and we can type in a message. So with this message, let's state enter your name. And when we run this, this is what we have. We have this small GUI dialog box, and we can type in our name and submit it. But it currently doesn't do anything. So let's create another message dialog box that will display our name along with a message. So jOptionPane.show message dialog. For now, you can just type in null, comma, and then a message. Let's say hello plus name, and let's try it. So our first dialog box is the show input dialog message, and we can type in our name and submit a name. And our second box here is a message dialog box. This just displays some information, such as a string of text, and it says, hello bro. This time, let's ask for an age and store this value within an integer variable called age. Int age equals, and we can just copy all of this, jOptionPane.show input dialog, and the message will be enter your age. There is one issue though. When you use the show input dialog box, it's going to return a string, and we're attempting to assign the string into an integer variable. So what we would need to do is convert this to an integer, and there is actually a method to do that. So what I'm going to do is use the integer wrapper class and use the parseInt method, and within the parentheses we're going to take all of this and copy it within our parseInt method, and then add a semicolon at the end. So this will return a string based on what the user types in, and the parseInt method will convert it to an integer that we can store it within our integer variable of age, and then we can display this. So let's display this with another message dialog box. jOptionPane.show message dialog. Null will be the first argument, and our message will be you are plus age plus years old. And let's try it. Enter your name, bro, press OK, hello bro. Then when we click OK again, it's going to go to our next input dialog box. Enter your age, let's say that I'm 18, click OK, you are 18 years old. Now let's try this with a double data type. This time, let's create a variable called maybe height. This will be a double value, and the variable name will be height. So since we're working with double values, we're going to change integer to double with a capital D, dot parse double. And the message will be enter your height. And our message dialog will be you are height, and let's say this is in centimeters tall. So we have to be sure that we're getting the right data type, because when you use the input dialog box, it's going to return a string. So if you're attempting to assign that string to a certain data type, you have to convert it to that specific data type. So let's try this. Enter your name, bro, okay, hello bro, what is your age? Let's say I'm 18, press okay, you are 18 years old. Enter your height. I don't know what a good height is. 240 centimeters. And then click OK. You are 240.0 centimeters tall. In conclusion, ladies and gentlemen, what we have made is a very simple graphical user interface for fun. This is completely optional at this point, but we will be learning more about GUIs later in this playlist. So if you would like a copy of all this code, I will post all of this in the comments down below. And if you could do me a favor, down below, smash the like button, drop a comment, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys a few useful methods of the math class. And at the end of this video, we're going to create a program where we will find the hypotenuse of a triangle. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alrighty then, guys and gals, in this video I'm going to demonstrate a few useful methods of the math class. To begin, we'll need maybe two numbers. Let's say that these will be double variables, double x. Let's set this equal to 3.14 and double y. We will set this to, let's say, -10. Alright, the first useful method is the max method. This will find the larger of two numbers. So in order to use the max method, we're going to type math with a capital M, dot, and there's a few recommendations here. What we would like is the max method. That is right here. So there's a few to choose from. We can compare two integers, two long values, two floats, and two doubles. I'm going to compare the values of x and y. So I'm going to put these within the parentheses of my max method. And then we can either display the result or assign this to a new variable. Let's say double z equals math.max, and we'll compare x and y and assign the larger number to variable z. And we will display the result. System.out.println z. And the larger of these two numbers is, in fact, x, which is 3.14. And there is also a min method, which will find the lesser of two values, which is variable y, which is -10. Another useful method is the absolute function method. It's just ABS, like abs, six-pack abs. And we'll pass in y. And this will display the absolute value of y, which is 10. So the absolute value is basically a number without the negative sign. I'm not a mathematician, so I could be wrong in that definition. All right, we also have the square root function. That is sqrt. The square root of y. I don't know what the square root of -10 is, but we're about to find out. I don't know. I guess that didn't work. Let's change y to 10. 3.16, blah, 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 blah. All right, that is the square root function. We can also round. Let's round x. So x rounded is 3.0. On the other hand, seal, like ceiling, this will always round up. So 3.4 or 3.14 always rounded up is 4. And floor will always round down. So 3.14 always rounded down is 3.0. Here's a project that we can work on. Let's create a program that will find the hypotenuse of a triangle, and we will ask the user for side x and side y. So to begin, let's declare two variables, double x and double y. Actually, I take that back. Let's declare double z as well, because z will be the result, the hypotenuse. We'll also need a scanner to accept some user input. Scanner equals new scanner. Within the parentheses, we're going to type system.in. We'll need an import, so include this import at the top. Import java.util.scanner. We'll need a prompt for side x and side y. We can do that with a println statement. Enter side x. I can't type today. And we will store the result within variable x. X equals, we need some user input, scanner dot next double, because we would like a double value. Let's repeat the process for side y. Enter side y. We'll store the result within variable y. Now here's the tricky part. There is a mathematical formula to calculate the hypotenuse given two angles, well, two sides of a triangle. So this is what we're going to do. First, we'll multiply x times x plus y times y. Then we need to put this within the square root function of the math class. Math, make sure it's with a capital M, dot sqrt. And we are going to take all of this and place this within the square root function. And we will assign this to our variable of z. So z equals math.square root x times x plus y times y. And with a print line statement, we can display the hypotenuse is plus z. That should be good. Oh, then it's good practice to close your scanner. I always forget to do that, although it's not necessary. Scanner.close. All right, let's test this. Enter side x, that is 4. Enter side y, let's say 5. The hypotenuse is 6.4 and some change. All right, so that's just a simple program that you can make using a function of the math class. So if you would like a copy of this code, I will post this in the comments down below. But yeah, that's a few useful methods of the math class. Oh, and I forgot to tell you guys, like, comment, and subscribe. That is all. How's it going, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can generate some random values in Java. So sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back, ladies and gentlemen. In this video, we're going to be generating some random values, some random integers, doubles, and Boolean values. So if you're interested in game design at all, this video is a must for you. So in order to use random values, we should probably import the random class found within the library. So outside of the class, this is what we're going to type. We're going to import java.util.random, semicolon. And now we have access to the random class, and that provides us a few options. We need an instance of the random class for us to use. Within the main method, we're going to create an instance of the random class by typing random with a capital R. It's the same name as the class, random. We need a name for this instance. Let's call it random, all lowercase, kind of like what we did with that video on scanners. Random equals new random. That's kind of random. Then a set of parentheses, then a semicolon. We now have access to this random instance to generate some random values for us. But there's a disclaimer here. These are not true random numbers, but something called pseudo-random numbers, which are pretty darn close. So I just wanted to give you that disclaimer before we got started, so you don't call me a liar. Let's generate a random integer and store this within an integer variable like int x. Int x equals, and to generate a random integer, we're going to type the name of our random instance, random.nextInt. There's also a few others like next boolean, next double, next float. I'll get to those later. What we would like for now is nextInt. And then we will display the result with a print line statement. We will display the value of x. So the results are on a scale between, I would say, just under -2 billion to just over +2 billion. So you'll probably want to limit that. Let's pretend that we're going to roll a 6-sided dice. So to limit the scale or the size of the random number that we'll generate, we can pass in a value to our nextInt method. So within the parentheses of our nextInt method, we'll limit the size of the integer that's going to generate. If we would like a 6-sided dice, we're going to place 6 here. But there's one catch with this though. This will generate a random number between 0 and 5 because computers always start with 0. And let's see if I can roll a 0. Nope. There we go. All right, so one way to solve this is that if we want the numbers 1 through 6, we can just add 1. So now we'll get a random number between 1 and 6, just like that. This time, let's generate a random double value. For now, I'll turn this line into a comment, and let's create a new variable called double y. Double y equals random dot next, where is it? Double. And we will display the value of y. Next double is going to give us a random value between 0 and 1. So this probably has some uses for something. What that is, I'm not really sure, but hey, you know you can do this now. Let's also generate a random Boolean value. So Boolean z equals random dot next Boolean. And we will display the value of z. So this is going to give us either true or false. Well, everybody, that's how we can use the random class to generate some pseudo-random values for us. If you would like a copy of this code, I will post this in the comments down below. But yeah, that's a few uses of the random class. Also, be sure to leave a like, drop a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about if statements in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Alright, guys and gals, in this video we're going to talk about if statements. An if statement is a very basic form of decision making. When an if statement evaluates to be true, it will perform a block of code, and that is it. Here's an example. Let's say we have a variable called maybe age. Int age equals, let's set this to 18. We can perform a block of code if some condition that we state evaluates to true. So this is how to create an if statement. We type in the word if, a set of parentheses, and then a set of curly braces. So within the parentheses of the if statement, this is the condition. We can check to see if somebody is perhaps 18 or older. So what we can do is write a condition such as age is greater than or equal to 18. Within our program, when we reach this if statement, we're going to check to see if this evaluates to be true or false. Currently, our age is set to 18. So this will evaluate to be true, and we will perform whatever is within the set of curly braces. So let's print a message such as, you are an adult. And let's test this. So our age is 18, our if statement evaluates to be true, and therefore we will perform this block of code associated with this if statement, and we will display the message, you are an adult. What if we change this to maybe 12? And then with our if statement, when we reach this condition, this will evaluate to be false. Therefore, we will skip this block of code as if it never even happened. We could perform a different action instead. We could write an else statement. There is no condition. We just need the word else followed by a set of curly braces. Now we are forced to take one of two actions. We will check to see if our condition is true. If it is true, we will perform this block of code. If it's false, we will instead perform this block of code. So let's print a different message. You are not an adult. So we are forced to perform one of two actions. If our condition is true, we will perform our if statement. If it's false, we will perform our else statement. And this states that you are not an adult. Now, it is entirely possible to check more than one condition before reaching an else statement, and that is by using what is called an else if statement. So we type else if, a set of parentheses, and then a set of curly braces. So we can check an additional condition before reaching our else statement. So let's check to see if our age is greater than or equal to 75. All right. And then we will print a message such as, okay, boomer. So pay attention to this. Let's change our age to 75 and run this. All right. Well, it displays you are an adult. That's because our if condition evaluates to true because 75 is greater than or equal to 18. So it's going to skip everything else and ignore these blocks of code and continue on with the rest of the program. So if we want to first check to see if somebody's age is greater than or equal to 75, what we could do is move this to our if statement, and I'll just switch these around and change our else if statement to 18. So we'll first check to see if somebody is greater than or equal to 75. If they are, we will first print OK Boomer. Else if their age is greater than or equal to 18, we will display you are an adult. And let's try this again. And it displays OK Boomer. So you can see that we got an entirely different result with these if statements. If the condition evaluates to be true, it's going to perform its own block of code and skip everything else. You can check more than one condition by adding else if statements. We could check one more thing perhaps. Else if age is greater than or equal to 13, then we can display another message such as you are a teenager. And if we changed our integer variable age to 13, this will display you are a teenager. There is one thing that you should know. These symbols, the less than sign, the equal sign, the greater than sign, these are known as comparison operators. So they work normally as what you would imagine. However, if you want to compare if something or some value is equal, you don't use one equal sign. That's using the assignment operator. So we're attempting to assign our variable age equal to 75. If we need to compare if something is equal, we use two equal signs. So that's just one thing that is specific for programming. So we can check to see if our age is equal to 75. And this time it will print OK Boomer. So that's all what an if statement is. It's a basic form of decision making for your program. If a condition evaluates to be true, then it will perform a block of code. If its condition is false, it will perform its else statement. Unless you have else if statements, then it's one by one going to check to see if these conditions are true before reaching the else statement. Well, ladies and gentlemen, that's the basics of if statements. If you would like a copy of all of this code, I will post this in the comments down below. And if I could ask a favor of you, I would greatly appreciate it if you smash the like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about switches in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Okay, welcome back ladies and gentlemen. In this video I'm going to explain how switches work. A switch is a statement that allows a variable or other value to be tested for equality against a list of values. So if you find yourself in a situation where you're using a lot of if statements back to back, it's probably more efficient to use a switch statement instead. Here are the different data types that we can use to test for equality within a switch. And according to this description, one thing that we can check is the equality of a string. For this program, let's test to see if a string, let's say it's going to be a day of the week, is equal to a list of days of the week. If there's a match, we can display a custom message. So let's say string day equals maybe Friday, because I like Friday. And we will create a switch to see if our day equals a certain day. So this is how to create a switch. Type in the word switch, a set of parentheses, then a set of curly braces. Within the parentheses, we're going to list the value or the variable we would like to test for equality against a listing of cases. So our first case will be Sunday. This is what we're comparing our value or variable to. We're going to compare this variable to our case. So type in the word case followed by the value, colon, and if there is a match, what would you like to do? So I would like to perform a print line statement that states it is Sunday. And then this next part is important. It's important to add the keyword break, so we break out of the switch and continue on with the rest of our code. So let's create another case for Monday. So I'm going to copy and paste, change Sunday to Monday, and I will print it is Monday. So I'm going to repeat this process a few times. And it's done. So I have a case for each day of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and I have a corresponding print line statement for each day of the week: Sunday, Monday, Tuesday, so on and so forth. So with our string of day, we're going to place this within the switch statement to compare for equality against a list of values. One by one, our switch is going to evaluate our day against each case. If there is a match, it's going to perform this subset of code. If there is no match, it's going to continue down to the next case and check to see if these values are equal. So let's test it. Currently our day is set to Friday, so this should display it is Friday. All right, so let's change this to Monday next. And this will display it is Monday. All right, this is why it's important to have these breaks after each case. So I'm going to remove this for this demonstration and show you why these are important. So if we were to run this again, this time we do not have those breaks. As soon as there is a matching case, we will perform this subset of code, as well as each subset of code that comes after our matching case. So that's why it's important to have these breaks within, well, after each case within our switch. So what if there is no match? Let's say our day is equal to pizza, which is not a day, but honestly, it really should be. Well, it will basically just do nothing. So one thing that we could do is add a default. Default, colon, if there is no match, what do we want to do? System.out.println, that is not a day. So let's try this again. If there is no match within our switch, we will perform whatever is set within the default case, which displays pizza is not a day. So that's all what a switch is. It allows a variable or other value to be tested for equality against a list of values. If you find yourself in a situation where you're using a lot of if statements, it might be better to use a switch instead. So that's all about switches. If you would like a copy of this code, I will post this in the comments down below. Please be sure to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video we're going to discuss the three logical operators: the AND, the OR, and the NOT logical operators. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's discuss logical operators. These can be used to connect two or more expressions, and there are currently three that I'm going to discuss. The AND logical operator, which is two ampersands, the OR logical operator, which is two straight bars, and lastly the NOT logical operator, which is an exclamation point. Let's begin with the AND logical operator. We can check to see if two or more conditions are true. If both conditions are true, an entire statement will evaluate to be true. Here's an example. Let's say we have an integer called temperature, temp for short, and we'll set this to 25 degrees Celsius. Let's write an if-else if statement to check to see what the temperature is and display a message based on the result. So let's check to see if our temp is greater than 35. Actually, let's make that 30. If temp is greater than 30, then we will display it is hot outside. So how can we check to see if our temperature is within a certain range? Well, we could use the AND logical operator to do so. Next, let's write an else if statement, and this time we're going to have two conditions, not just one. So first, we'll check to see if our temp is greater than or equal to, let's say, 20. And we would like to check to see if our temp is less than or equal to 30. So in order for this statement to be true, both conditions must be true. That's why we're using the AND logical operator. This side, as well as this side, both of these conditions need to be true for this entire statement to evaluate as true. So if our temperature falls within this range, let's display a message. It is warm outside. And then else, it's cold outside. System.out.println, it is cold outside. And let's try it. So currently our temperature is 25, and when we run this, it displays it's warm outside. If our temperature was 35, then it's going to display it is hot outside. If it's less than 20, well then this portion is going to evaluate to be false, but this portion will evaluate to be true. So therefore, this entire statement will be false then, since both conditions must be true. So if our temperature is 15, which is cold, it's going to display it is cold outside. That is the AND logical operator. For a statement to be true, both conditions must be true. Next up to bat, we have the OR logical operator. This will check to see if one or more conditions is true. If at least one of the conditions is true, then the entire statement is true then. So do you remember those old computer games like Oregon Trail where you usually had to type Q to quit the game? Well, let's replicate something like that via a scanner. So let's accept some user input. Scanner equals new scanner. Within the parentheses, system.in, and we will need an import java.util.scanner. So we will ask the user if they want to quit the game, and in order to do so, you have to press either lowercase q or uppercase q, but we'll need a prompt first. You are playing a game. Press lowercase q or uppercase q to quit. And we will store our answer within a variable. Let's call this response. String response equals scanner.next. Next, we'll store the next key that you press within a variable, a string variable. So let's check to see if our response is equal to lowercase q or uppercase q. If, then within the condition of the if statement, our response, and with strings, to check to see if two strings are equal, you need to use the equals method. It's a little bit different with strings. If our response is equal to lowercase q, we're going to use the OR logical operator. If our response is equal to uppercase q, then that means the user wants to quit the game. You quit the game. Else, they still want to play the game, so we'll print a different message. You are still playing the game. Pew pew. And let's test this. You are playing a game. Press Q or Q to quit. So I'm just going to type no, and it says you are still playing the game. But you know what? This game is kind of lame, so I'm going to press lowercase q to quit. It states you quit the game. On the other hand, I could have pressed uppercase q to quit the game, so let's try that. Uppercase q, you quit the game. So with the OR logical operator, as long as one of these conditions is true, then this entire statement will evaluate to be true. And last but not least, we have the NOT logical operator, which is represented by an exclamation point. This will reverse the Boolean value of a condition. So using the NOT logical operator, we could make some changes to how our program is written. So if we precede these conditions with the NOT logical operator, this will reverse the Boolean value that these evaluate to. So we're checking to see if our response is not equal to Q, or our response is not equal to uppercase Q. And then we should probably change this middle logical operator to be AND. So if our response does not equal lowercase q, and our response does not equal uppercase q, then that means this person, this user, still wants to play the game. Else, they are going to quit the game. So this will work much the same. You are playing a game, press Q or Q to quit. No, because this is a fun game. On second thought, this game is in fact kind of lame, so I'm going to press Q to quit the game. You quit the game. So that is what the not logical operator is. If you precede something with the not logical operator, it's going to reverse the Boolean value based on what it's going to resolve to. So in this case, we check to see if our response does not equal lowercase q and our response does not equal uppercase q, then this person still wants to play the game, else they're going to quit the game. So those are the three logical operators: the AND logical operator, the OR logical operator, as well as the NOT logical operator. If you would like a copy of all this code, I will post everything in the comments down below. Please be sure to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about while loops in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alright guys and gals, let's talk about while loops. A while loop executes a block of code as long as its condition remains true. It's like an if statement, but it will continue that block of code continuously as long as its condition remains true. Here's an example. Let's create a program that will ask somebody for their name. If they attempt to not type in anything, well, we'll keep on prompting the user to type in their name. The only way for them to escape the while loop is to type in something, aka their name. So let's create a scanner. Scanner equals new scanner. Within the parentheses, system.in. We'll need an import, so be sure to include that at the top. Import java.util.scanner. We'll need a name variable. String name equals, and we'll just set this to a pair of quotes for now. This is how to create a while loop. Type while, then you need a set of parentheses, and then a set of curly braces. It's kind of like an if statement. We'll put our condition within the parentheses. If this statement, this condition remains true, then we will execute this block of code continuously until our condition is no longer true, until it evaluates as false. This is our condition. Name dot is blank. If somebody attempts to skip the process of entering their name, it will keep on prompting the user to type in a name. So let's create a print line statement. Actually, I'm going to change this to a print statement. Enter your name. And we will store the result within our name variable. Name equals scanner dot next line. And when we escape the while loop, we will display a welcome message. Hello plus name. All right, that is it. Let's try this. Our program states enter your name. I'm not going to type in anything. I'm just going to hit enter. So you can see it keeps on prompting me to enter my name. Enter your name. No. Enter your name. No. This time I'm going to type in my name because I give up. Enter your name, bro. Therefore, our condition is now false because our name is no longer blank, and we have exited the while loop and continued on with the rest of our code. There is a variation of the while loop. It's called a do loop, and how we write this is that we move the condition to the end of the block of code, and preceding this block of code, we write the word do. So what makes this different is that with the do loop, we will always perform our block of code at least once, and then we check the condition after. So this will work much the same. However, we're always performing this block of code at least once. So the do loop is a variation of the while loop, but it works very similar. It always executes the block of code once. Compared to the while loop, it will first check the condition and then execute the block of code if this is true. So everybody, that is the while loop. If you would like a copy of this code, I will post this in the comments down below. Also be sure to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about for loops in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on people? Let's talk about for loops. A for loop executes a block of code a limited amount of times. Compared to a while loop could continue infinitely depending if its condition remains true. With a for loop, this will execute a limited amount of times. So before we even begin the for loop, we already know how many times that this for loop is going to iterate. So let's create a program for an example that will count from 0 to 10. We can do this with a for loop. So this is how to create a for loop. type in the word for, a set of parentheses, and then a set of curly braces. So with our parentheses, we add a condition along with two other statements. So there's three parts to this for loop. The first part is that we can declare a sort of counter or index. So we will declare int index, and we can set this equal to 0, and then add a semicolon. So what a lot of people do is that they shorten index to I. It's more shorthand. With our second statement, this is our condition. We would like to continue this for loop as long as I is less than or equal to 10, because we stated that for this program, we would like to count from 0 to 10. Now, this third portion, we will increment our counter I by 1 after each iteration. So our for loop, at least within the parentheses, has three separate statements. We declare a counter or index. We call it I, but it's not necessary. That's just a common practice. This is our condition. We will iterate this for loop as long as this condition is true, and then we can increment or decrement our index. Let's take a look at this. How many times is this for loop going to iterate? Well, it's going to iterate a total of 11 times because we're counting 0 as well. So let's test this. With a print line statement, we will display our index of I. So this will count from 0 to 10 and then stop. So let's do the reverse now. Let's start at 10 and count down to 0 and then display a message such as Happy New Year. So with our index, let's set this to 10 and change our condition to continue as long as I is greater than or equal to 0. And then with our index, we will decrement this by 1. And then when we exit the for loop, let's display Happy New Year. So we will start at 10, count down to 0, and display Happy New Year. Now, with this statement, we could increment this or decrement this by more than 1. If we wanted to count down by 2, we would write this as I minus equals 2. So now this will execute a total of, let's see, 1, 2, 3, 4, 5, 6 times. Another way of writing this for loop that is optional is that you can move this third statement to within the for loop. And this will work much the same as it did before. It's just an optional way of writing this. So that's what a for loop is. It's similar to a while loop, except that it will execute a limited amount of times compared to a while loop that could execute an infinite amount of times. With for loops, within the parentheses, there are a total of 3 statements: an index that you can declare, a condition, and then you can increment or decrement the index by a certain amount. So that is for loops. If you would like a copy of this code, I will post this in the comments down below. Please be sure to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how nested loops work in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey, what's going on fellow human beings? In this video, I'm going to explain nested loops. A nested loop is really just a loop inside of another loop. To best demonstrate this, let's create a program where we can set a number of rows and columns and display a rectangle of a particular symbol that we decide upon. So in order to create this program, we'll need a scanner. Scanner equals new scanner. Within the parentheses, we're going to type system.in. We'll need an import. Be sure to include this at the top. Import java.util.scanner. Let's declare a few variables: int rows, int columns, and a string called symbol, depending on the symbol we want to use. And for now, we'll just set this to a blank set of quotes. Next, let's create a few prompts. Enter number of rows, so we will let the user control the amount of rows that will be displayed, and we will store the result within our variable rows. Rows equals, and we need to use our scanner, scanner.nextInt. And let's repeat the process for columns. I will copy everything I have here and change rows to columns. Columns and columns. and we will let the user decide on what symbol they want to display. So within another print line, enter symbol to use. And we will store this within our symbol variable. I guess we could have declared this as a character as well, but it's probably easier if it's a string. Symbol equals scanner.next. Next will store our next token that we type until we hit space or enter. And then this is where the nested loops comes in. We're going to have an outer loop and an inner loop. Our outer loop is going to be in charge of the rows. Our inner loop is going to be in charge of the columns. So let's begin with the outer loop. This will be a for loop. For parentheses, then a set of curly braces. We will add 3 statements to the for loop. The first is our index. Int I for short for index, I equals 1. Then for our second statement, we're going to continue this for loop as long as I is less than or equal to the amount of rows that we have. And our third statement, we will increment our index of I by 1. Within this for loop, all we're going to do is display a print line, a blank print line. So this will move our cursor down to the next row to display the next row of characters. So this is where the nested loop comes in. We're going to create another for loop within this for loop. So we will make another for loop, for parentheses, curly braces. We'll need an index, but we cannot reuse the same one. So let's declare another index, and a common practice for a nested loop is to declare an index of j, because j comes after I in the alphabet, I suppose. So we'll set j to equal 1. That's the first statement. The second statement is that we'll continue this for loop as long as j is less than or equal to the amount of columns that we have. And lastly, we will increment our index of j by 1. Within the nested loop, all we're going to do is display our symbol. Make sure you do this with a print, not a print line statement. So we will print whatever symbol that we have. And that is it. That's it. Let's compile and run this. Enter the number of rows. I would like 4 rows and 5 columns. Which symbol would I like to use? Perhaps the $sign. Hit enter. And here is my rectangle. It has 4 rows. 1, 2, 3, 4, and 5 columns. 1, 2, 3, 4, 5. So what happened here is that our outer for loop is in charge of the rows. Our inner for loop is in charge of the columns. Once we enter the outer for loop, we're immediately going to add a print line just to move down to the next line. And then with the inner for loop, in order to escape the inner for loop, we need to complete all iterations of the inner for loop. So what we will do during each iteration of this inner for loop is print our symbol. And once we print our symbol an amount of times equal to the amount of columns that we want, we can escape the inner for loop. And once we complete our inner for loop, we can finish one iteration of our outer for loop, but we have to complete the process all over again for the next iteration of our outer for loop. So we will enter our inner for loop one more time and have to reset our integer j, our index, back to 1 and repeat the process for the next row, all the way until our outer for loop is complete, and then we can exit the program. So that's all what a nested loop is. It's basically anytime you have a loop inside of another loop. These don't necessarily have to be for loops. You can have any combination of for loops or while loops for this too. Well, ladies and gentlemen, that is one example of how a nested loop could be useful, but you may see these in various different types of contexts. So if you would like a copy of this code, I will post all of this in the comments down below. Please don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how arrays work in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Alright, welcome back ladies and gentlemen. In this video I'm going to explain arrays. An array is used to store multiple values in a single variable. That is it. They're really not that complicated, but they can seem kind of intimidating. So let's begin with a simple string variable called car, and I will assign this a value of Camaro. What I could do is that I could store multiple values within this single variable by turning this variable into an array. And these are the steps to do so. Next to the data type, I'm going to add a set of straight brackets. And then with the values, I'm going to surround the values with a set of curly braces. And that is it. And for fun, I'll rename this as cars because that makes more sense. So it would make more sense to name this something that is plural because it contains more than one value. So let's add a few other cars. Let's say I would like to add a Corvette and a Tesla. And that is it. That is an array of cars. So in order to access one of these elements, arrays have spots, kind of like parking spots, and they are called elements. So let's say I would like to access this first element. So I'm going to take the name of my array, which is cars, add a set of straight brackets, and then list the element number. So computers always start at 0. If I want to access this first element, I'm going to write 0. And I could reassign this. Let's say I would like to instead place my Mustang within element number 0. And let's print whatever is within the first element of our array of cars. Cars, straight brackets, 0. So this will print my string of Mustang. If I want to access the next element, so this is 0, element number 0, and the next one is element 1, then 2, so on and so forth. In my next element of my array of cars, we have a Corvette, and then a Tesla. So what happens if I attempt to access an element that does not exist? So let's put 3 here. Well, what we'll get is an array index out of bound exception because this array does not have this element, element number 3. It only has elements 0, 1, and 2. But I could add another element. Let's say I'm going to add a BMW to element number 3. So then we no longer get that error because our array has a total of 4 elements, 0, 1, 2, 3. One thing that you should know with arrays, when you assign values, they all have to be the same data type. They have to be consistent. For example, I couldn't add the primitive integer value of 1, 2, 3 because what this states is that this is a type mismatch, cannot convert from int to string. So if you have an array of strings, for example, you can only add strings. If this was an array of integers, well, I could only add integers then to this array. So you have to make sure that the data type of the values that you're adding are all consistent with the data type of the array. Now, there is an additional way to create an array, and that is by first allocating the amount of elements that we'll need and then storing the values later on in the program. So this is an additional way to write an array. We type in the data type of the array, straight brackets, the name of the array, we'll call it cars, equals new, the data type again, straight brackets, semicolon. Within the straight brackets, we'll assign how many elements we would like within this array. Let's say we would like 3. So we can assign a total of 3 strings to our array of cars. And let's do that. So later on in this program, right here's a good spot, we will assign each of the elements of our array of cars. So cars at element number 0 will equal my Camaro. And then cars at element 1 will equal a Corvette. And cars at element 2 will equal a Tesla. And then we can display each element of this array. So let's begin with cars at 0. This contains the Camaro, then the Corvette, and then the Tesla. So this is an additional way to write an array. We can first declare the amount of elements that we would like for this array, and then we could assign the values later on in the program. Before we finish this video, I'm going to explain how we can use a for loop to iterate through all of the elements of an array. Let's say we would like to display all of the elements of this array. So let's create a for loop to do that. For, a set of parentheses, and then a set of curly braces. With for loops, there are 3 statements. The first is that we need some sort of index or counter. So let's say int I equals 0. That is the first statement. For the second statement, this is our condition. We'll continue this for loop as long as I is less than our array cars dot length. And lastly, we will increment our index by 1. So let's display whatever is within our array of cars at element number I. So I is going to begin at 0, then after each iteration of this for loop, it's going to increment by 1. So when we run this, this will display all of the elements of our array of cars: Camaro, Corvette, and Tesla. All right, everybody, so that's what an array is. It's really just used to store multiple values within a single variable. If you need to access one of the elements of an array, you just list the name of the array and the element number in which you're trying to access. So if you would like a copy of this code, I will post all of this in the comments down below. Please don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain 2D arrays, also known as multi-dimensional arrays in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright everybody, welcome back. In this video I'm going to be explaining 2D arrays. A 2D array is an array of arrays. Think of a 2D array as having a number of rows and columns. That's how I think of it, at least. We're going to be assigning some cars, some car names, into each element of our 2D array. Think of it like a parking lot, and each element has a row and column, kind of like a parking spot number. So to begin, let's declare a 2D array and allocate some memory. So the data type will be string. Then for a 2D array, we need 2 sets of straight brackets this time. And then the name of the array, we will call this cars, equals new. The data type again, which is string, 2 sets of straight brackets. And then we will list the amount of rows and columns. So let's say this will be 3 by 3. 3 arrays, and each array is going to have 3 elements. So let's begin assigning some cars into our 2D array. Let's begin with row 0. So in order to access a certain element of our array, we type in the array name, and this time we will add 2 sets of straight braces. We would like to access element 0, 0. So this is row 0, column 0, equals, and let's assign a name of Camaro. Now we would like to access row 0, column 1. And let's assign a different car, maybe a Corvette. Cars at row 0, index 2, will equal maybe a Silverado. All right, we're going to move to row 1 now. Actually, I'm just going to copy what we have here, paste it. So we are now on row 1, column 0. And let's assign a different car, maybe a Mustang. And let's repeat the process. Just to speed this up, I'm going to do a little bit of copying and pasting. So we're within row 1, and then we have column 0, 1, and 2. And let's change some of these names. For row 1, column 1, I will assign a value of Ranger. And row 1, column 2, maybe F-150. Okay, so we are now within row 2, column 0. So I'm going to copy that. Change some of the values. Row 2, column 0, I will assign a value of Ferrari. We are now on row 2, column 1, I will assign a value of maybe Lambo for Lamborghini. And then lastly, row 2, column 2, and I will place a Tesla in this element. And there we have it. We have assigned all of the values within our 2D array. So let's display all of the elements of our 2D array using a nested for loop. So we will have an outer for loop in charge of the rows and an inner for loop in charge of the columns. So let's create a nested for loop. So this is the outer for loop. We'll need an index. Int, we'll call it I for index, equals 0. And then we will continue this for loop as long as I is less than cars dot length. And lastly, we will increment our counter, our index I, by 1. Within the for loop, let's add a blank print line just so that we move our cursor down to the next row within the console window when we display each row of cars that we have. Now we need an inner for loop to display each column, each element within each column of our 2D array. So we'll need an index. Let's call this int j because j comes after I. Set this equal to 0. That's the first statement. Our condition is going to look a little funky. We'll continue this inner for loop as long as j is less than cars at index I dot length. So this will take the length of our first row and we'll continue our counter, our index of j, as long as it's less than the length of our row that we're currently on. And then we will increment our index j by 1. Within the inner for loop, all we'll do is print our array of cars at element I for this first set of straight brackets and j. Cars at row I, column j. And then maybe I'll add a space just to separate these. And what we get here is that this will display our 2D array of cars that we have. Now there is an additional way to write this 2D array. Instead of allocating all of the memory for this 2D array, what we could have done is assign all of the values right away to this 2D array when we declared it. If you prefer to write it that way, this is what will change. Instead of allocating all of this space, all of the elements that we would like for this 2D array, we're instead going to assign all of the values. So let's get rid of this portion, and we're first going to assign all of the values within row number 0. This is our first array. So within our set of curly braces, we will add our Camaro, followed by our Corvette, and lastly, our Silverado. So this is row 1. It's its own array. We will add a second array for row number 1. The first row was row number 0. So in our second array of row 1, we have our Mustang, followed by our Ranger, and lastly, our F-150. Okay, that is array number 2, also known as row 1. We are now on row 2. So let's add another array. And we have our Ferrari, followed by our Lambo, and lastly, our Tesla. All right, and then with all of this, I'm going to enclose all of these arrays within another set of curly braces. Then I'll need to add a semicolon to the end. And just so that this is easier to read, I'm going to separate each array within a new line. So it should look something like this. That's good enough. Sorry, I'm very particular about the appearance. Okay, so this is our 2D array of cars that we have, and you can see that it will work much the same even if I remove all of these lines of code. The only difference is that we're assigning all of the values to our 2D array when we declare it. All right, everybody, so that is the basics of 2D arrays. It's really just an array of arrays. Think of it as having rows and columns. If you would like a copy of this code, I will post this in the comments down below. Please be sure to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about a few useful methods of the string class. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Hey, welcome back, my good people. In this video, I'm going to explain a few useful methods of the string class. Now, as you know, a string is a reference data type that can be used to store 1 or more characters, and reference data types have access to some fairly useful methods. Let's begin by creating a string variable called name. String name equals, and let's assign this a value of whatever your name is. So let's type our name variable, dot, and here are all the methods that we have access to. I'll describe and explain a few of the more useful methods that you might be interested in at this level. So let's begin with the equals method. This will compare two strings to see if they are equal. So within the equals method, let's type another string. I'm just going to copy what I have for my name to make this easy. This will return a Boolean value, and we can do something with that Boolean value, such as use it for an if statement or anything else. So I'm going to store the result within a Boolean value. Let's call this result. Boolean result equals name dot equals, and then type in a string. And let's display what the result is. So our equals method is going to compare my two strings, my name variable and whatever string is within here. And this will return true. However, it is case sensitive though. If I made the b in my name lowercase, this will now return false. But I could instead use the equals ignore case method. And now, both of these strings, according to my equals ignore case method, is now true. Next on my list is the length method, and just to keep things simple, I'm going to turn this line into a comment, and I am going to create a new variable. So the length method is going to return an integer based on the length of a string. Int result equals name dot length. And this will return a value of 3 because we have 3 letters in my name, but your name might be different. We also have the char at method. This will return a single character. Char result equals name dot char at. And we list an index if we would like to access the first character in our string. That would be index 0. And the second position would be 1. The third position would be 2. Then you just continue on in that pattern. So the character at index 0 of my name is capital B. Then we have index of. This will return an integer. Int result equals name dot index of. This will find a character and return the index of where the method finds that character. So let's say I would like to find an index of capital B. So this will return the position. And we have a capital B at index 0. If this was O, lowercase o, that is at index 2. We can also check to see if a string is empty. This will return a Boolean value. Boolean result equals name dot is empty. So currently my name is not empty, and this will return false. Now if I got rid of my name and we just have an empty set of quotes here, this will return true because my name variable is now empty. So let me reverse that and move on to the next method. We also have the toUpperCase method. We can change all of the letters in a string all to uppercase. So this will return a string. String result equals name dot toUpperCase. Now my name is all uppercase, and there is also to lowercase. Actually, I'm just going to copy most of this, paste it, and change upper to lower. This will change all of the characters in my name all to lowercase, and now the B in my name is now lowercase. We can also trim some empty space before and after the string. String result equals name dot trim. So this will remove all of this empty space that I just added. The trim method will remove all of this empty space before and after my characters that I have. And the last method I have to show you guys is the replace method. This will return a string, and we can replace a character with another within a string. Name dot replace. And there are 2 values we need to place within the replace method. An old character and a new character that we want to replace the old character with. Let's say we would like to replace all O's with A's. So this will replace the O in my name with A. And now my name is Bra. Well, guys and gals, that is a few of the more useful string methods, but not all of the methods entirely available to you. If you type in a string variable, type dot, at least with Eclipse, this will prompt an entire list. And you can always read through some of the descriptions to see what some of these methods will do. So those are a few of the more useful string methods. If you would like a copy of all this code, I will post all of this in the comments down below. Don't be afraid to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about wrapper classes in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, welcome back guys and gals. In this video I'm going to explain wrapper classes. A wrapper class provides a way to use primitive data types as reference data types. Here are a few examples of primitive data types. They include, but are not limited to, booleans, chars, ints, doubles. There's still many more out there such as bytes, shorts, and floats, but here are a few of the more common ones that we've been working with. So notice that strings are not within this list of primitive data types. That's because strings are already reference data types. Now, reference data types have some advantages and disadvantages. A few advantages, for one, would include that they may contain some useful methods. For example, take the last video on string methods. The string class contains some useful methods, and strings are an example of a reference data type. Also, reference data types can be used with certain collections, and they can be used with, for example, array lists, which we'll learn about in the next video. And a disadvantage of reference data types over primitive data types, for one, is that reference data types are slower to access. If you need to get the value of a primitive data type that is enclosed within a wrapper class, it's going to take more steps. So if you're working with millions of numbers, well, it's going to take a lot more time and a lot more processing power to use reference data types compared to primitive data types, because primitive data types are a lot faster. So each primitive data type has a corresponding wrapper class, and there's a naming convention with these. For the wrapper class, the first letter is capital, and the entire name is, for the most part, spelled out. So boolean would be boolean with a capital B, char would be character with a capital C, int is integer with a capital I, and double is still double but with a capital D. So let's assign a few primitive data types and use the corresponding wrapper class to create a reference data type. So Java has this feature called autoboxing and unboxing. We can directly assign some primitive values to a wrapper class automatically, and here's the definition. So autoboxing is the automatic conversion that the Java compiler makes between primitive data types and their corresponding object wrapper class. So let's use autoboxing to assign a primitive data type, a few primitive data types, to each corresponding wrapper class. So let's begin with a Boolean value. So we're going to list the data type, and it's going to be the wrapper class. So Boolean with a capital B, let's call this variable A equals, and then we can just use autoboxing to directly assign a primitive value to this reference data type. So I'm going to say that Boolean A equals true, and that is it. And let's assign a few others. So we have character B equals, let's assign a character, maybe the @ symbol, integer C equals 1, 2, 3, and double D equals, let's say 3.14. And what we have done is created 4 reference data type variables: Boolean A, character B, integer C, and double D. And for fun, let's create a string variable as well. Let's say string E equals whatever your name is. So are you beginning to see a pattern here? Strings are already a reference data type. That's why the first letter in the string data type, when you declare a variable of this type, is capital compared to the primitive data type variables that we've been working with. So it's kind of like we've been using reference data types all along when working with strings. As we've discussed at the beginning of this video, reference data types have a few advantages and disadvantages, and one of the advantages is that each wrapper class may contain some useful methods, kind of like what we did with the string class in the last video. So we already have a string. Let's look at a few of the methods of Boolean wrapper classes. So type in the name of the Boolean variable A dot, and then here are all the methods that you have access to. The same thing goes with characters. Here's a bunch of methods you can use. Same thing with integers and doubles. So reference data types within the wrapper class, they have access to some useful methods that you can use for your program. Not only that, but you can use these reference data types with certain collections, and we'll be using them for array lists in the next video. So if you need to access the values within a wrapper class, well, there's a feature called autoboxing and unboxing. Autoboxing is the automatic conversion that the Java compiler makes between primitive data types and their corresponding object wrapper class. When we directly assigned some values to each of these reference data types, what we have done is autoboxing. We automatically converted these primitive values to the corresponding wrapper class automatically. But unboxing is the reverse. We can convert a wrapper class to its primitive value. So what I'm saying is that with unboxing, we can treat these reference data type variables as if they were standard primitive values. So for example, let's say if Boolean A is equal to true, then we will display this is true. So even though this is a reference data type, it will still behave as a standard primitive data type because of the unboxing feature. And the same thing goes with B, except B has to be a character. So let's check to see if this is equal to our @. And this is also true. So that is the unboxing feature. You can still treat these reference data types as if they were primitives. So even though there are a few advantages of wrapper classes over the primitive data type that they may contain, there is still the disadvantage that accessing the values contained within a wrapper class still takes a lot more steps compared to using just a raw primitive value. So if you're working on a program that contains millions of numbers, for example, using reference data types, using the wrapper class for each primitive value is going to take a lot more steps compared to just using a standard primitive value. So primitive values are a lot faster than reference data types. So everybody, that's the basics of wrapper classes. If you would like a copy of all this code, I will post all of this in the comments down below. Don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going everybody? It's Bro, hope you're doing well, and in this video I'm going to teach you guys all about array lists in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, well, welcome back ladies and gentlemen. In this video I'm going to be explaining array lists. An array list is a collection. It's a type of resizable array. Elements can be added and removed after the compilation phase, which you cannot normally do with standard arrays. However, they only store reference data types, and I'll give you a few examples. So these are the steps in order to create an array list. First, we type array list. Pay attention to the capitalization. The A and the L are both capital. Then we need a pair of angle brackets, and we're going to list the reference data type within the angle brackets. Let's say we're storing an array list of food. So we will create an array list that will store some strings for the names of food. Now, if you need to store primitive values like an integer, a double, a character, you need to use the wrapper class. So for example, if we needed to store integers within an array list, we would not place int, we would use the appropriate wrapper class and type integer. So we're going to be storing strings which are already reference data types. So let's call this array list food equals new array list. Angle brackets, we're going to list the data type again of string, parentheses, semicolon, and we'll need an import. So at the top of our program outside the class, import java.util.ArrayList. We now have an array list called food that will store strings. So how can we add values to our array list? Well, there is a function to do that. That is the add function. And in order to use the add function, type in the name of the array list dot add, and we can add a string. So let's add a few food items. Let's add pizza to the first element, followed by, I'm going to copy this, hamburger, and hot dog. So let's display all the elements of our array list, and we can do that using a for loop. So for, parentheses, curly braces, and then we will need an index, int I. We'll set this equal to 0. We'll continue this for loop as long as I is less than food. And normally with arrays, you would use dot length, but with array lists, we use dot size. And we are going to increment our index by 1. And then in order to display or retrieve one of the elements of our array, we will use the get function. And let's put this within a print line statement, food.get, and then we are going to list the index of I. So this will display all of the food that is in our array list, pizza, hamburger, and hot dog. Now let's discuss a few useful methods of array lists. The first useful method is the set method, food.set. So we can set a value at a certain index. Let's say at index 0, currently we have pizza at this index. We will replace this value with maybe sushi. And now within our array list, if we display all of the elements using our for loop, we now have sushi, hamburger, and hot dog. So our pizza value has been replaced with sushi because we used the set method. So we can also remove a value at a certain index using the remove method, food.remove. Let's say we would like to remove our hot dog. That is at element number 2. And now we only have sushi and hamburger. And last but not least, we can use the clear method to clear our array list, food.clear. And we no longer have any elements within our array list of food because we cleared it. We ate all the food. All right, everybody, so that is array lists in Java. If you would like a copy of all this code, I will post all of this in the comments down below. Please don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys about two-dimensional array lists in Java. So let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everybody, so we're going to be discussing 2D array lists, and what this is that it's a dynamic list of lists. It's a list of separate lists. So you can actually change the size of these lists during runtime, so that's kind of an advantage of array lists over just standard arrays. So before we begin, make sure you have this import at the top. And what I'm thinking for this video is that we're going to create separate shopping lists, and at the end, we're going to add these separate shopping lists to an array list. It's going to be a list of separate lists. So let's create a array list for maybe bakery goods, like things we need to buy at the bakery at a grocery store. So we'll create an array list, and then we need some angle brackets. And then with array lists, these store objects, so we need to use the wrapper class of the data type that we're storing. So for example, if you need to store integers, you're going to use the wrapper class of integer. But let's store some strings because we're storing the names of things we need to buy. So let's call this array list bakery list. And we're going to set this equal to new array list. All right, let's add a few things to our bakery list. So bakery list dot add. And what do we want to buy? Maybe some pasta. And maybe 2 other things. How about some garlic bread? Everybody loves garlic bread. And donuts, because I like donuts. Okay, so we have an array list called bakery list, and it has these 3 items. We can actually display our bakery list by using a print line statement, and we're going to place our bakery list within here, and we have pasta, garlic bread, and donuts. Now, if you want to retrieve a certain element of this list, we use the .get method, and we specify an index. So 0 would be pasta. So let's create a few other lists. So I'm just going to copy this, and for the next list, let's have this be a produce list. So fruit and vegetables. So produce list, and we need to change this here as well. So we'll change bakery list to produce list for this next array list. And let's add some tomatoes. And what goes with pasta? Maybe some zucchini. And maybe peppers. Okay, and then we'll just add one more. So what about a drinks list? So we'll change produce to drinks. And let's say we only want 2 drinks. So these lists don't have to be the same size as each other because they're all independent lists. So let's say that we want soda and we want coffee. And let's display our drinks list. Oh, we should probably change this here as well. So make sure you do that. Okay, we'll display our drinks list, which has just soda and coffee. Now we have these separate array lists, one for each aisle of a grocery store. Well, at least just a few of them. So what we can do is actually add all of these separate lists to one list, and we can call it maybe grocery list. It will contain different lists of what we need to buy at the grocery store, and they're all kind of organized by their section. We have one for bakery goods, we have one for produce, and we have one for drinks. So let's create a 2D array list to contain these separate array lists. So what we're going to type is array list, and then within the angle brackets, we list the data type of what we want to store. And what we want to store this time is array lists of strings. So we're going to place this within angle brackets. So array list, and within the angle brackets, array list again, and this stores strings. So we need a name for this 2D array list, and the name should be descriptive of what it contains. So we'll just say grocery list, because it contains separate lists of things we need to buy at the grocery store, and they're all organized by section. So grocery list equals new array list. And then we need to add these separate array lists to our 2D array list. So what we're going to do is take our grocery list, and then we're going to add whatever lists that we want to add. So we need to add our bakery list, and we're going to do the same thing for our produce list and our drinks list. So we'll change bakery to produce. And then lastly, we need drinks. So drinks list. So then if we take our grocery list and then display this, what we end up seeing is that we get the total sum of everything that's within our grocery list, and they're all arranged by section or array list. You can see that they're all separated with a comma. So it's a list of lists. Now let's say that you want to retrieve just one list from this array list. Well, you can use the get function, and then you can retrieve something by its index. So let's say that we want the first list in this 2D array list. We're going to get index 0, and this will retrieve the first list. Now let's say that we want the first element of our first list. We're going to add dot get again, and then the index for the element of this inner list. So if we want the first element of the first list, we type in dot get 0 and dot get 0 again. And then when we run this, we have pasta. Now, if we want the last index, so this is, let's see, this is list 2, item number 1. So we'll write get to item number 1, and this retrieves coffee. So that's the basics of 2D array lists. It's just a container for separate array lists. You can do this with other collections too, but we've only really covered array lists. So if you want a copy of all this code, I'll post this in the comments down below. But yeah, that's how two-dimensional array lists work in Java. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about the for each loop in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Hey, what's going on, guys and gals? In this video, I'm going to explain the for each loop, also known as an enhanced for loop. This is a traversing technique to iterate through all the elements in an array or other collection. The benefits is that a for each loop takes less steps and is more readable than a standard for loop. However, it is less flexible. So let's begin by creating an array of animals. So these will be animal names, so the data type will be string. Then we need a set of straight brackets. We will call this array animals equals, and then we will assign a few values. So within our array of animals, let's say we have a cat, a dog, a rat, and a bird. I'm not sure what kind of bird, just use your imagination. Now we could create a for loop to iterate once through each element of this array, but we could also use a for each loop to do this. So this is how to create a for each loop. Type for, a set of parentheses, and then a set of curly braces. So the only part that is different is the statements within the parentheses of the for loop. We're going to begin by listing the data type of our array or other collection. So we're going to list this as string because we're iterating through strings. Next, we need an index. Let's say index I, then colon. Colon represents the word in. For every string index in our array of animals. So lastly, list the array or collection name at the end. So this will iterate once for each index in our array of animals. So what would we like to do within each iteration of this for each loop? Let's display whatever I is. So this is going to be a string, whatever this data type is, so we can print this directly. And when we run this, our for each loop will display all the elements within our array. And now let's try this for each loop using a collection. An array list is a type of collection, so let's create an array list called animals this time. So array list, within angle brackets, we're going to list the data type, which is string, and then we will call this animals equals new array list, angle brackets, list the data type, parentheses, semicolon, and then we'll need an import at the top, import java.util.ArrayList, and then we need to add some values to each element of this array list. Animals.add, we're going to add a cat, then repeat the process for dog, rat, and bird. Dog, rat, and bird. And you can see that nothing has changed. So remember, a for each loop is useful for iterating through all of the elements in an array or other collection. It involves less steps and is more readable, but it's less flexible compared to a standard for loop. So that is everything you need to know to get started with the for each loop, also known as the enhanced for loop. If you would like a copy of all this code, I will post all of this in the comments down below. And don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain methods in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back guys and gals. In this video I'm going to explain methods. A method is a block of code that is executed whenever it is called upon. For example, when we begin our program and execute it, we begin by calling the main method. That's where we've been writing a majority of our code. So anything within this set of curly braces belongs to this main method. This time we're going to create our own method that we can call whenever we need it. So outside of our main method, make sure you don't write this within the main method, we're going to create another method, perhaps a method that will display a message such as hello. And to begin creating a method, we'll need a return type. I'll explain return types later on in this video. For now, we're going to list the word void, followed by a method name. Our main method is called main, and a common naming convention for methods is to have the first letter lowercase. So let's create a method called hello. When we call this method, it will display a message such as hello. So this will be hello with a lowercase h, then we need a set of parentheses, and then a set of curly braces. Anything within the set of curly braces belongs to the hello method. And if we call the hello method, it's going to perform whatever code is between these two curly braces. So what would we like to do when we call this method? Let's display a message such as hello. Now within our main method, we can call, also known as invoking, this method. So within our main method, we can call the hello method whenever we want. Now we have just one issue that we need to take care of, and let me explain. We cannot make a static reference to the non-static method hello from the type main. So this means that we need to precede this method with the keyword of static, because we're calling the hello method from a static method of main right here. So normally we do not need to add this keyword of static, and if you want to learn more about things that are static, I do have a video on it. But for now, we just need to add this keyword in order for this program to work for this example. So when we call the hello method, it's going to perform whatever is within our block of code. And here it just displays the word hello. And we can call this method whenever we want and however many times we want. So if we want to display the word hello 3 times, we can just call the method 3 separate times. And this method will perform its task, its block of code, however many times it is called. One feature available to methods is that we can pass a value or a variable to a method when we call it. For example, we can pass a string variable to represent a name, and then we can use that name for something within our block of code. So for example, let's pass in a name of whatever your name is. Let's say bro. We can pass in a value or a variable. So for this example, I'm going to pass in a variable called name. String name equals bro, and I'm going to pass my variable of name into my method. So if you want to pass a value or a variable to a method, when you call that method, within the parentheses, just list all of the values that you would like to pass to your method. The values or variables that you're sending to a method are known as arguments, and they can be confused with what's known as parameters. In order to pass some values or variables to a method, when we declare our method, we need a matching set of what's known as parameters. Think of these as the rules. In order to call this method, we need a matching set of arguments and parameters. Currently, these are not matching. We're passing in a string, but there is no matching parameter. So this is how to set up a parameter for a method. We're first going to begin by listing the data type of the value that our method is expecting. So we're passing in a string as an argument. So we need a string parameter. So we need to first list the data type, followed by a name for this value. Just to make it simple, I'm going to call this name. So we now have a matching set of arguments and parameters. And now, since we're passing in our name variable to our method of hello, our hello method now has access to a string variable of name, and it contains this value of bro. So now we can use this name for something. Let's display hello plus name. And when we call this method and pass in our name, it's going to display the word hello plus our name. Hello, bro. So with parameters, you don't necessarily need to keep the names of the values consistent. I could change this name to something else, like title, I guess. And then I will switch that around, and this will work just the same. So these don't necessarily have to be called the same thing, the argument and the parameter. You can change the name if you want. Even something like this would work too. I don't know why you would write it like that, but you can. So with methods, you can pass in more than one argument as long as you have a matching set of parameters. This time, let's pass in an integer value. Let's create an integer variable called age. Int age equals, and I'll set this to 21 this time. So within my hello method, I'm going to pass in my name and age as arguments to my hello method. However, we have a problem. If I attempt to run this, we do not have a matching set of arguments, name and age, and parameters. We're passing in a string and an integer, and our method has parameters set up to accept only a string. So we need to finish setting up the parameters for this hello method so that the arguments and parameters match. So we need an integer, and we will call this age, and then we can use this age variable for something. So within another print line statement, let's display you are plus age. And now this will work because we have a matching set of arguments and parameters. And before we finish this video, I would like to explain return types. We can return a value back to the area in which we called a method. So for this example on return types, I think this can be best explained with a separate example. So I'm going to clear out all of this and create a new example. Let's say we have two integer values. Int x, this will equal maybe 3, and int y, this will equal 4. Well, let's create a method that will add these two numbers and return the sum, the result of these two numbers. So outside of the main method, let's declare a method static. Normally we would type void if we're not returning anything, but if we're going to be returning a value, we need to list the data type of the value that we're returning. If we're going to add two integers together and return the sum, we're going to list the return type as integer because that's the data type of the value that we would like to return. We would like to return an integer, and then we will list the method name. Let's call this add, parentheses, and then a set of curly braces. So we cannot normally finish compiling this because if we're listing a return type, we need to list a return statement. What do we want to return? Well, we're going to return an integer, but we'll have to get to that later. So let's begin by setting up the parameters for our add method. Let's say we would like an integer. Let's call this x and int y. So in order to call the add method, we need to pass in two arguments, two integers. So let's call the add method and pass in our variables x and y. And within the add method, we will add these two numbers together. We could store this within a separate variable, int z equals x plus y, and then we could return our value of z. So when we run this, what's going to happen? Well, it doesn't display anything. That's because when we return the value of z to this area in which we called our method, well, we're not currently doing anything with this value. So we could store this within a variable or display it directly to the console window. So let's store the sum within int z equals add x and y. So you may have noticed that we declared this variable twice, int z within our main method and within our add method. This is technically legal because they are known as what's called local variables. Int z is only recognized by anything within the immediate set of curly braces. It's known as a local variable. Our add method does not recognize this int variable of z, so we could declare our own to use, or you can rename it too. It doesn't really matter what you do. So we can store the sum of our add method within int z and then do something with it, such as display it to the console window, system.out.println z. So this will display the sum of 7. Another way in which you could write this, we don't necessarily need to store the value in which we're returning to a variable. We could just directly display it to the console window too. So within my print line, I'm going to call the add method and pass in x and y, and this will still display 7. Another way in which we could shorten our method is that we don't need to store the sum within a variable. We could just return x plus y. So let me clear this line, and we could return x plus y, and this would be valid too. So that's another way of writing this. Well, everybody, those are methods. They are really just a block of code that is executed whenever it is called upon. You can pass in values or variables known as arguments, but in order to do so, your method, when you declare it, needs a matching set of parameters. And then you could return a value if you need to. Instead of using the word void, just list the data type of the value that you're returning. So if you would like a copy of all this code, I will post everything in the comments down below. And don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about overloaded methods in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. All right, everybody, let's discuss overloaded methods. Overloaded methods are methods that share the same name, but they have different parameters. This is allowed because each method needs its own unique method signature. That is the method's name plus its parameters. They can share the same name, but they would need different parameters to give them each a unique method signature. Let's create a few overloaded methods, perhaps just a few add methods that will add some numbers together. Outside of our main method, let's declare a few overloaded methods. So for this example, we'll need these to be static. Let's return an integer, so the return type is going to be int, and this will be called add. And we will accept a few arguments, so we need to set up some corresponding parameters. Let's say int a and int b. And we will return the sum, return a plus b. So let's create another method, an overloaded method, also called add. wait a minute, we have a problem. So we have two methods that are duplicates. Duplicate method add in type main. They both have the same method signature. They both share the same method name as well as the same parameters where they accept two integer values. There are two ways in which we can resolve this. The first is that we can change one of the method names and this error would go away, but that defeats the purpose of overloaded methods. The other way is that we can change the parameters that we have for each method. Let's say we would like two versions, maybe even three versions of our add method. One that accepts two values, another that accepts three values, let's say int c, return a plus b plus c, and another that will accept four values. So we'll have int d, return a plus b plus c plus d. And then our problem went away. So let's test these. I'm just going to add a print line that states which overloaded method we're using. This is overloaded method number 1. And I'm going to copy this and paste it. And we'll change the second instance of this print line to this is overloaded method number 2. And lastly, this is overloaded method number 3. So let's try this. Let's say we have an integer, int x equals add, and we can pass in between 2 and 4 integers. Now I'm going to attempt to pass in a single integer value, but we cannot run and compile this because we do not have a matching method signature. We can pass in between 2 and 4 integers. So let's try this by passing in 2 arguments this time, 2 integer values, and then let's display the sum, the result. System.out.println, our variable of x. So we end up using our first overloaded method. This is overloaded method number 1, and this will display the sum, a plus b, which is 3. And let's try and use our second overloaded method. We need to pass in 3 integer values as arguments, and we are now using our second overloaded method. And lastly, we can pass in 4 integer values, and we end up using our third overloaded method, and we get a sum of 10. And with overloaded methods, not only are the numbers of parameters taken into account, but the data type for each specific parameter. So this time, let's create 3 more add methods, but these ones will accept double values instead of integers. So let's change any instance of int to double, including the return type. All right, and then I'm going to change the number of the overloaded method that we're using. So 6, 5, 4, 3, 2, 1. Our first 3 methods only accept integers, and they will accept between 2 and 4 integers. Our next 3 add methods only accept double values, and they accept between 2 and 4 double values. So we could also pass in some double values to our overloaded methods. Let's change these to 1.0, 2.0, 3.0, and 4.0. And we will need to change the data type of our variable x as well. So double x add 1.0 through 4.0. And we are now using overloaded method number 6, which accepts 4 double arguments. In summary, overloaded methods are methods that share the same name but have different parameters. They can share the same name, but they would need different parameters to give each method a unique method signature. Some factors that are taken into account with parameters are the number of parameters, the data type, and the order of the values. So if you would like a copy of all this code, I will post all of this in the comments down below. Please don't forget to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about the printf method in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Hello all, welcome back to another video. For this topic, I'm going to be explaining the printf method. This is an optional method to control, format, and display text to the console window. Here's an example of the printf method, and this is different from print and print line. With the printf method, there are two arguments we need to place within the parentheses of the printf method. The first is a format string, a string that you would like to display to the console window. And second, we can add either an object, a variable, or a value. To keep it simple for now, I just added a value of 1, 2, 3. So we can format some value and place it at some position within the string. The position in which we want to add this value, whatever it is, can be added to wherever we add a format specifier, which is represented by a %sign. Let's say we would like to add this value at the end of our format string. So we would add a format specifier at the end that is represented by the %sign. And there is a certain amount and number of combinations and characters that we can add after this format specifier, and this will format our value a certain way. If we simply need to display a decimal number, we're going to add a D. It's kind of like a secret code. That's how I think of it, at least. So if we add a %sign and D, we will add this decimal value at this position within our format string, and that will appear down here. I could place this format specifier someplace else, and this value would be added to wherever I put this format specifier. So if I added this format specifier to the beginning of my format string, then this value will appear at the beginning of my string. So with the printf method, you need a format string and either an object, a variable, or a value. Depending on where you place this format specifier, the %sign, your value or variable will appear at this location. Think of it as you're replacing the format specifier with this value, and depending on the combination of flags, numbers, and characters after this format specifier, this is going to format and display your value a certain way depending on what combination of letters and characters comes after. Let's begin with conversion characters. This is a letter that appears after the format specifier, and the conversion character corresponds with the data type of the value that we're attempting to add. So D corresponds with decimal numbers, so we could add an integer at this location. So let's go over a few of the conversion characters that are available to us, but we'll need to create a few variables to do so. So let's begin with a Boolean. Let's call this my Boolean, and I will set this to true. We'll need a character, so let's say char, my char equals, and then pick a symbol that you want to use. We'll need a string, my string equals maybe your name. We'll need an integer, int, my int, and assign it a number. I'm just going to pick one at random, let's say 50. And let's add a double value. So double, my double equals maybe 1000. Okay, so these are not all of the data types that are available to us, but a few of the more common ones for beginners. So let's use the printf method and cover a few of the conversion characters. So we will need to use the printf method, system.out.println, printf, and let's just use the format specifier. So if we need to display a Boolean value, that would be % then B for the conversion character to display a Boolean. And we need to add a second argument. That is the value that we're attempting to add. So let's add my Boolean. And we can now display whatever this value is. So for characters, that is actually %C. And let's display my character. Okay, so strings are %S. So let's copy this, paste it. That is %S. And this will display a string. Should probably get rid of that line too. Okay, and integers are D for decimal, but we've covered that already. So %D for a integer. Let's display my int, which displays 50. And %F for a double value. So that's for floating point numbers and double values. So let's display my double. So remember, with conversion characters, these are certain letters that follow the format specifier, the %sign, and in order to display a certain object, variable, or value, you need a matching conversion character to follow after the format specifier. B for booleans, C for characters, S for strings, D for integers, and F for floats or doubles. Our next field is the width field, so I already created some notes on this. The width field sets the minimum number of characters to be written as output. So here's an example. We have a format string, and we would like to display a value that is of the string data type. So let's say at the end, we're going to add %s to display this string. We can set a minimum number of characters to display. So let's say we want to display at least 10 characters for this string. So before the conversion character, we can set a width, and this is a number. So if we want 10 spaces worth of room to display this string, we would add 10 or some other number before the conversion character. So before we display this, I'm just going to turn these lines into comments, and we will display hello plus my string, which states bro. So this prints a minimum of 10 characters for the name, including the length of the name. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the space that was here already too. So you can set a width, and this will display a minimum number of characters to be written out. And if you set this to be a negative number, that's actually a flag that we'll get into in just a little bit. That'll actually left justify the text within the space that we're allocating to display this value. So this text is now left justified, but all of that empty space now comes after my text, my string. Next on our list is the precision field, and what this will do is set a number of digits of precision when outputting floating point values. These include the data types of floats or doubles. Here's an example. I have a format string that states you have this much money, and then we have a format specifier that will display my double. This is the default, so we need at least %f, and this will display 1000 as well as 6 zeros after our decimal. We can limit the amount of digits that will display after this decimal by using the precision field. So we write this before the conversion character. Let's say we would like to limit the amount of digits that we have after this decimal to 2 to represent cents. So I'm going to add 0.2 for 2 digits. And this will limit the amount of digits that will appear after the decimal portion. And if we change this to a different number like 1, well then this will only display 1. So that is the precision field. It will set a number of digits of precision when outputting floating point values. And lastly, we have flags. These will add an effect to output based on the flag added to the format specifier. Here's a few. We can left justify, we can output a plus or minus sign for a numeric value, we can have numeric values be padded with zeros, and we can separate large numbers by the thousands by using a comma. Let's try a few of these out. Let's copy what we have for our example for precision. So I'm going to copy this line, and let's get rid of the precision. So we have %f. Let's left justify this. So I'm going to set a width, maybe 20, and set this to negative. So this will left justify all of that. Although it's a little difficult to see, I'm going to get rid of the left justify, and this will now be right justified. So this would be useful if you need to line up a bunch of numbers. We can output a plus or minus sign for a numeric value. So I'm going to add +f, and this should be plus 1000. If this was a negative number, like negative 1000, this should appear as a minus now. We can also pad our number with zeros. So let's set a width of maybe 20, and we will right justify it, so we do not need a negative sign, and we are going to add 0. So we now have a bunch of zeros before our number of 1000. And lastly, we can separate each thousands place with a comma simply by adding a comma as the flag. So %, f. So at the 1000s place, we now have a comma. So that is all what the printf method is. It's an optional method to control, format, and display text to the console window. We need at least two arguments, a format string, as well as either an object, a variable, or a value. We can add a format specifier within this format string and add a combination of characters and numbers to format our variable, value, or object a certain way. So that is an intro, more of a crash course to the printf method. If you would like a copy of all this code, I will post everything in the comments down below. This video was a lot of work. Feel free to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about the final keyword in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Okay, ladies and gentlemen, I'm going to be teaching you guys about the final keyword. Anything that is declared as final cannot be changed or updated later in your program. Here's an example. Let's say we have a double variable called pi, and we will store the first few digits of pi, 3.14159. There's still more digits than that, but that's good enough for this example. And let's update the value of pi to maybe 4. And then within a print line statement, let's print the value of pi. So this will display 4 because we updated our variable pi to equal 4. So if we were to use the final keyword, when we declare our variable, we're going to precede our data type with the keyword final. And we can no longer update this value, and it states the final local variable pi cannot be assigned. It must be blank and not using a compound assignment. So we can no longer change the value of pi. We're going to run into a problem, and it states here that we ran into an unresolved compilation problem. So if you declare anything as final, you cannot update it. It is final. That's the law. You can't update it. And one common practice that people will do when they declare something as final is that with the variable name, they will make all the letters uppercase. It's not necessary, that's just common practice. And when we run this program, it displays our number pi of 3.14159. So really, that's the basics of the final keyword. Anything that is final cannot be changed once you declare it. If you would like a copy of this code, I will post this in the comments down below. But yeah, that's how the final keyword works in Java. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys all about object-oriented programming in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey, welcome back. This video is the start of the object-oriented programming portion of the series. The abbreviation people use is OOP, also pronounced as OOP. Now, objects, they can be intimidating, but they're really not that bad once you get to know them. So look around you right now. You are surrounded by different objects. Next to me, I have a phone, a desk, a computer, and a coffee cup. And you can hear me knocking on it right now. Unfortunately, it's empty. So we can use programming to imitate objects in the real world. Anything you can think of, really. An object uses a class. For example, I have a class called car, and we're going to be constructing some car objects. So with objects, they contain attributes and methods. Think of attributes as the characteristics that this object has, and methods as the different actions that this object can perform. For example, let's list some of the attributes of a coffee cup. These are the characteristics of my coffee cup. So for example, let's say that the color of this coffee cup is white. I could store this within a string variable within the class called color. And we can assign this a string value such as white. What about a temperature? That could be a double variable, and let's say that this is room temperature at 20 degrees Celsius. And then what about a status like if it's empty or is it full? This could be a Boolean value such as true or false. And unfortunately, my coffee cup is empty, so empty will equal true. Now, what kinds of methods, what kinds of actions can this coffee cup perform? Let's say we have a drink method, and when we call this method, we can print a message such as, you drink from the cup. Or what about a spill method? if we were to call the spill method in case I decide to spill my coffee everywhere, we could say you spilled your coffee everywhere. So all an object really is a bundle of defining attributes and methods, the characteristics of an object, and what actions that this object can perform. And for today's video, we're going to be creating some car objects. Why? Because, well, I like cars. So we need to create a different class, another class. So you can either do this within the same Java file or a separate Java file. So if you were to create a class within the same Java file, make sure that you declare this class outside of the main class that you're working with. But I like to keep my code organized into different Java files. So for me, I'm going to create another Java file. So within my project folder, I'm going to go to File, New, Class, and I'm going to call this class car because we're constructing car objects, and then click Finish. So I have two classes within my project folder, one called main, for you it may be named something different, and a car class. So we're going to be using this car class to define the attributes and methods of what our cars should have. But if you decide to write this within the same Java file, you'll probably write something like this, but I'm just going to keep these as separate files. Now, what kinds of attributes should our car have? Let's start defining a few. Let's say a make and model. These could be string variables. So let's say string make and pick one of your favorite cars. Let's say string make equals Chevrolet. And we could also have a model like string model equals Corvette because I like Corvettes. What about a year? This could be an integer, int year. And let's say this is a 2020 Chevrolet Corvette. What about a color? String color equals maybe blue. And what about a price? This could be a double variable such as double price. Let's say that this car is 50,000 US dollars and 0 cents. That's probably enough attributes for this example. Now, what kinds of actions, what kinds of methods would we like our car objects to be able to perform? Let's define two methods, a method for drive and a method for brake. So let's define these. Let's say void drive. And what do we want to do when we call this drive function? Let's have a simple print line statement that says, you drive the car. Let's also create a method called brake. Void brake. System.out.println. You step on the brakes. And that should be good for this example. So these are all of the attributes of the car, the defining characteristics, and these are the methods, what actions our car object can perform. Now let's head back to our main class. This is how to construct an instance of another class. We're going to be constructing a car object. So first we begin with the name of the class, which is car. Next, we can create a unique name for this instance of the class, this unique car object, and I will just call this my car to keep it simple, equals new, and then the name of the class again, followed by a set of parentheses, then a semicolon. So my car now has these attributes. It's a 2020 Chevy Corvette that's blue, and the price is $50,000. And it has two methods, a drive method and a brake method. So let's display some of the characteristics of this car. We can do that within a print line statement. And if we want to display or access one of the attributes of this car, we type in the name of the car, which is my car, dot, and then whatever attribute you want to display. Let's display the model. So when we run this, we'll create a car object, and it's called my car, and we're going to print the model. And in the console window, it's going to display the model. Let's display a few of the other attributes too. So let's repeat the process. We type in the name of the object. The name of this object is called my car. I would like to access the make this time. And the make is an attribute, a variable found within this class. So this is going to print the make and the model, and this is a Chevy or Chevrolet Corvette. Now, what if we want to access or perform one of these methods? It's the same process as before, really. So we type in the name of the object, dot, and then the method we would like to call. So we are looking for the drive method, and that is right here. And let's turn these two lines into a comment. So we're going to call the drive method of my car. And it says, you drive the car in the console window. Now let's apply the brakes. So we type in the name of the car, or the object, dot, and we're going to use the brake method this time. Use step on the brakes. Now with classes, we can reuse a class to instantiate multiple instances of this class, meaning that we can reuse this class to create multiple objects, not just one. So let's reuse this car class to create a second car. Let's pretend that we own two cars now. So let's repeat the steps for creating a car. So we type in the name of the class, car, and we need a unique name for this car object. Let's call this car my car 2, I guess, equals new car. And I think I'm going to rename my car as my car 1. So my car is no longer recognized, so let's just change the name to my car 1. So this will display the make and the model of my car 1, and it's still a Chevrolet Corvette. Now let's display the make and the model of my car 2 following these same steps. So in order to display these, let's write this within a printline statement. So we are working with my car 2. We are going to type that name, my car 2, followed by whatever we want to access. We would like to access the make as well as the model. So I'm going to change this to my car 2 dot model. And I'll add a printline statement just to help separate these within the console window. So what we get is that both of these cars, my car 1 and my car 2, are both Chevrolet Corvettes. So the reason behind this is that with our car class, it's acting as a blueprint, and we're saying that whenever we construct an instance of this class, a car object, all of them are going to be Chevrolet Corvettes, the year 2020, they're blue, and they are all $50,000, and they only have a drive and brake method. And to solve this problem, because we don't want all of our cars to be Chevrolet Corvettes, I mean, that wouldn't be a bad problem to have in real life though, but it's not practical for programming. So what we're going to be doing in the next video is learning about constructors, how we can construct objects that have different characteristics, different attributes, so that all of our objects are not the exact same. So if you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's an introduction to object-oriented programming in Java. Hey, how's it going everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys all about constructors in Java, so sit back, relax, and enjoy the show. You too can become a hero and save our channel by punching the like button, throw a comment down below, and smash the subscribe button. Alright guys and gals, in this video I'm going to be explaining constructors to you all. Now a constructor is a special method that is called when an object is instantiated, and when we instantiate something, that's just a fancy term for creating an object. Now for this example, I have two classes. I have my main class that contains my main method, and I also have another class within my project folder called human. We're going to be creating some human objects today. Now, normally the steps of creating an object, we would type in the name of the class. For this example, it's human, a unique name for this specific object. We'll just call this human, all lowercase, equals new human. Now, this portion works very similar to a standard method call, except a constructor is a special method that works behind the scenes that will create an instance of a class for us. It will instantiate an object. Basically speaking, our constructor is acting as a special method, and we can even pass in arguments when we instantiate it. So if we would like to do something with these arguments, like assign them to the attributes of our object, we can set up the constructor within the class. So this is how to create the constructor within our class. It's going to have the same name as the class. For this example, it's human, followed by a set of parentheses and then a set of curly braces. And that's it, we have our constructor. So when we create an instance of this class, it's going to call the constructor much like a method, and anything within the constructor will be performed just like a standard method. So we can actually set up some parameters and pass in some arguments when we create our object. So let's set up some parameters for our human class. What are a few attributes that a human might have? For one, a name, like Bob or something. So let's define the first parameter of string name, perhaps an age, int age, and then a weight. Actually, let's make this a double weight. So we have now set up 3 parameters for this human class. Let's head back to our main class. Now we're going to have a problem. That's because we do not have matching arguments to send our human. That's because we're saying that in order to construct a human, these are the parameters, these are the rules. In order for us to instantiate a human, to create a human object, we need to send our constructor a string, an integer, and a double value to serve as the name, the age, and the weight. So in order to get this program working, within the constructor, we need to pass in some matching arguments. So we need to send a string, an integer, and a double value. So let's call our human Rick, and we'll pass in Rick for the first argument. Let's send an age, perhaps 65, so he's elderly, and then a weight. Perhaps this will be in kilograms. So let's say maybe 70. See, now that error went away, so we can compile and run this, but it currently doesn't do anything. So why is this useful? Why is passing arguments to a constructor useful? Well, this gives us the ability to create different objects that have different attributes. So we could create a second human that has a different name, a different age, and a different weight. But we first need to assign these values to the attributes of our class. So let's head back to our human class, and we need to define a name, an age, and a weight. And let's do this outside of the constructor, but we're not going to assign a value just yet. So let's say string name. We're only going to declare this int age and double weight. And then within the constructor, we're going to assign all of these values to each of these variables. So right now, let's say name equals name, and age equals age, and weight equals weight. Now, this actually isn't going to work, and I'll show you why. So let's attempt to access human1's name. And let's do this with a println statement. System.out.println. To access one of these attributes, we type in the name of the object, dot, and whatever we're trying to access. Let's attempt to access the name. Now, if we were to display the name, it says null. Well, what gives? That's because we need to assign each of these values to this specific object, and one keyword to assign values to this object is to use the this keyword. So when we assign name equals name, age equals age, and weight equals weight, we're going to precede each of these with the keyword this. This dot name, this dot age, and this dot weight. So for all intents and purposes, when we create an instance of a class, when we create an object, we're going to imagine or pretend that we're replacing this keyword with the name of the object. So if we're creating an object called human, replace this or pretend that we're replacing this with human. If we created a second human object, this could be human2. Just pretend that, but stick with the keyword of this. So now if we were to run this, human now has a name. Now let's create a second human. So let's repeat the steps. Human, I'm going to call this human2 and rename human as human1 just to keep things simple. Now we can send different arguments to our constructor. So we need to send a name, an age, and a weight. Well, a string, an integer, and a double. So for our second human, let's call him Morty. We need to send an integer. Let's say he's 16 and he weighs 50 kilograms. And let's attempt to access human2's name. So we can do this within a println statement, human2 dot name. And this should display Morty. So now the point of constructors is that they allow us to construct objects that have varying attributes. And in the last lesson, when we were constructing cars, we were only able to construct blue Corvettes. And with the help of constructors, we can construct objects that have different qualities. So they are still humans, they're objects that are instantiated from the human class, but they have different attributes that make them unique. Here's one situation that you might run into. Now, how can you access an object's attributes from within its class itself? So we can utilize the this keyword to help us with that. So let's pretend that humans have two methods. They have an eat method as well as a drink method. And let's define these both. So for eat, let's say void eat. And within this method, let's create a print line statement that says, this person's name is eating. So in order to access an object's attributes from within its own class, we have to use the this keyword. So if we want to display the person's name plus maybe some text such as is eating, let's type in this dot name to access this object's name plus is eating. So this will print the person's name plus is eating. And let's try this. So let's say human2, which is Morty, is eating. So in order to call this method, we'll have human2 use its eat method. So this will display Morty is eating. Now let's create a drink method, void drink, and we will display this person's name is drinking. System.out.println, this dot name plus is drinking. Burp. And let's say human1, which is Rick, is going to use the drink function because he likes drinking. So human1 dot drink. And here are the results. Morty is eating and Rick is drinking. That's because we stated that human2 is going to use its eat method and human1 is going to use its drink method. So if we had each of these objects perform the other method, a different method, let's say human1 is going to use the eat method and human2 is going to use its drink method. So now each of these objects is using a different method. This time Rick is eating and Morty is drinking. So that's why constructors are useful. They allow us to assign different attributes to each object that we instantiate. So that's the basics of constructors. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of constructors in Java. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys the difference between local and global variables and objects in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, I'm going to explain the difference between local and global variables and objects. So anything that is local is declared inside a method and is visible only to that method. Anything that is global is declared outside a method, but within a class, and is visible to all parts of a class, including any methods found within that class. Here's an example. We're going to create a program where we will roll a dice. So let's handle that with an additional class. So let's go to File, New, Class, and I will call this class Dice Roller. Click Finish. I need to create an instance of this class, so within my main method, I'm going to create an instance of my Dice Roller class. Dice Roller, I'll call this instance Dice Roller for short, equals new Dice Roller. Within our Dice Roller class, we'll create a constructor for this class. It's the same name as the class name, plus a method to roll a dice for us. So the return type is void, and we'll call this method roll. We'll need to declare a few things, an instance of the random class, plus an integer variable to hold our result. So let's create an instance of the random class, random equals new random. We'll need an import as well, so include that. Import java.util.random and an integer variable, and we'll call this number, int number, and we'll set this equal to 0 for now. And lastly, within the constructor, we'll call the roll method. So let's set up the roll method. We're going to take our number variable, set this equal to random.nextInt. We want the numbers 1 through 6, so we'll pass in 6 to this method of nextInt plus 1. And we're adding plus 1 because we would normally get the numbers 0 through 5. And then with a print line statement, we'll display our number to the console window. Here's the issue we're running into. Both our instance of the random class plus our integer number variable are local to our constructor. So anything that is local is declared inside a method and visible only to that method. Well, our constructor counts as a method, so the instance of the random class and our number are only visible to anything within our constructor. Our roll method does not have access to our instance of the random class plus our number. There are two ways in which we can solve this. One is that we can pass these as arguments to a method, and the other way is that we can declare these as global. So let's begin by passing these as arguments. So we're going to pass our instance of the random class plus our number as arguments to our roll method. So let's do that. We're going to pass random and number to our roll method, but we'll need to set up some parameters. This will accept a random argument as well as an integer argument, and we'll call this number. So this will work just fine then. So we have a 4 and a 4 and a 6. So the other way in which we can write this, I'm just going to reverse our changes. We can declare our instance of the random class and our integer number variable as global. These are declared outside a method, but within a class, and it's visible to all parts of a class. So in place of declaring these inside of the constructor for the dice roller, we're going to declare our instance of the random class and our number outside of this method, our constructor. And with our random class, we'll finish instantiating this within the constructor. So let's declare random outside of the constructor as well as our number outside of the constructor as well. So now our roll method has access to our instance of the random class plus our number because these are global. They are declared outside of the method, but within a class. Technically, we don't even really need to assign a value anymore to our number. We can simply just declare these. So this will work just the same as it did before. It's just another way of writing this program. We rolled a 5 and we rolled a 4. So that's the main difference between local and global. Anything that is local is declared inside a method and visible only to that method. Anything that is global is declared outside a method, but within a class, and is visible to all parts of a class. So that's the differences between local and global items in Java. If you would like a copy of this code, I will post all of this in the comments down below. But yeah, that's the main differences between local and global items in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well, and I have a special treat for you guys in this video. We're going to be using overloaded constructors to bake some pizzas. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Ladies and gentlemen, we're going to be discussing overloaded constructors. These are multiple constructors within a class with the same name, but they have different parameters, and that's the key thing to take away from this. When you combine a constructor's name plus its parameters, it's also known as a signature. And if you have constructors with the same name, they need to have different parameters because they should all have their own unique signature. To best demonstrate this, we're going to be baking some pizzas. Within my same project folder, I have a pizza class as well as a class that contains my main method. So let's create the constructor for this pizza. It's the same name as the class, followed by parentheses, and then a set of curly braces. Let's also instantiate an instance of the pizza class. Create a pizza object. So it's the name of the class followed by a unique name for this object. I'm going to call this pizza, all lowercase, equals new pizza, parentheses, semicolon. So we now have a pizza object. And let's assemble this pizza and pass in some ingredients as arguments. So let's say that in order to bake a pizza, we would like a bread, a sauce, a cheese, and a topping. So let's declare some of these variables outside of the constructor. So we have string bread Is it thick crust, flatbread, whatever? A sauce, a cheese, and a topping. I guess all of these variables will be strings for this video, but you can mix and match them. All right, so if we instantiate an instance of the pizza class, create a pizza, let's assign some of these values that we receive, and let's set up the parameters for this pizza constructor. So we would like a bread, so that will be one parameter, a sauce, a cheese, and a topping. Now, in order to create our pizza, we need matching arguments because the parameters are the rules. We have to send our pizza 4 strings, and they will serve as the bread, the sauce, the cheese, and the topping. So what kinds of ingredients should we use to bake our first pizza? Let's say we need a bread. So let's say this is a thick crust pizza. And a sauce, tomato, I guess. A cheese, maybe mozzarella. I probably spelt that wrong. And a topping, let's say pepperoni. I probably spelt that wrong too, but I don't care. So we can now construct a pizza object. And for this pizza constructor, it requires 4 strings that will serve as a bread, a sauce, a cheese, and a topping. And then let's assign these real quick. So this dot bread equals the bread that is passed to us as an argument. And repeat the steps for sauce, cheese, and topping. This dot sauce equals sauce. This dot cheese equals cheese. And this dot topping equals topping. And let's print this pizza. System.out.println. Let's display a message such as, here are the ingredients of your pizza. And I'll just print these all on a new line for each. System.out.println. Pizza.bread, because I want to access the bread variable of our pizza object. And we'll access the others too. So we have sauce, cheese, and a topping. So we're passing in 4 strings. Here are the ingredients of your pizza. It's a thick crust, tomato, mozzarella, pepperoni pizza. All right, now here's a situation. What if we want a plain cheese pizza? We don't want any toppings. So you know what? I'm going to get rid of the pepperoni. But wait a second, we're gonna have a problem. We need to pass in 4 strings, and we're only going to be sending in 3. One way that we can solve this problem is to create overloaded constructors. So overloaded constructors, they can have the same name, but different parameters. So what we can do is create another constructor with the same name. I'm going to copy all of this, paste it. So right now, these parameters are the same. They have these constructors, the same name, as well as the same parameters. So this is not legal because they have the same signature. Let's create a constructor that doesn't have a topping. It's only a bread, a sauce, and a cheese. And we do not need to assign this topping, so we can take that out. And you can see that that issue went away. We can now construct a pizza that has only 3 ingredients. But if we were to attempt to display the topping, it just says null, but everything works just fine. Now, what if we were to remove the cheese? Let's say it's a vegan pizza, just tomato sauce and bread. So we need a constructor that takes 2 arguments, 2 strings. So let's copy one of these constructors, paste it, and change the parameters. So this pizza constructor only takes 2 arguments, a bread and a sauce. And it functions just fine. And why stop there? Let's remove the sauce entirely so we can create a pizza that only has bread, and that's it. So we'll need to create another overloaded constructor that has only 1 parameter, a string value, string bread, and we will assign this bread equals bread. And for some reason, if you wanted to create a pizza that only has bread, well, you can do so. Here are the ingredients of your pizza, thick crust. And then, you can also create a constructor that has no arguments. So that's kind of like what we had in the original video on object-oriented programming. So we have the name of the class with no arguments and no parameters. So you could create an object that has no attributes assigned, where all the ingredients are empty. So a pizza that has nothing will cost you $0.00 in real life, I guess. Well, everybody, that's the basics of overloaded constructors in Java. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of overloaded constructors in Java. Hey, it's your bro. Hope you're doing well. In this video, we're going to be discussing the toString method in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Welcome back, guys and gals. In this video, I'm going to be teaching you guys all about the toString method. This is a special method that all objects inherit. It returns a string that textually represents an object. So let me give you an example. I have another class called car, and a few variables related to cars, such as a make, a model, a color, and a year. And I took the liberty of assigning these values already. So it's a Ford Mustang that's red, and the year is 2021. Now we have 4 variables here, right? What if we wanted to display all of these values? So first we need to create an instance of this class. We're going to create a car object. We can do that by stating car, let's call this car, equals new car. All right, and in order to display all of these values within our car class, we would need a bunch of print line statements. Luckily, I just copied and pasted what I had before. So within a print line, we would print the car's make, the car's model, the car's color, and the car's year. So if we were to run this, this will display all of the values, the textual representation of this object. Now, what if we displayed with a print line statement car instead of one of the attributes? So within a print line statement, I'm going to instead just type in car. And what the heck is this? All right, so let me explain. This is the address of this car object in memory. It's like the street address, like 123 Fake Street. So this is the address where you can find this car object in your computer's memory. So normally we're using the toString method, and all objects will actually inherit a toString method. So if we were to type in the name of our car, we actually have access to a toString method. And by default, we actually call the toString method behind the scenes implicitly when we use a print or print line statement. So if I were to type car.toString, it's going to do the exact same thing, which we have here. So it's going to return the address of where this car object is in memory. But what many people do is that they will override and change the toString method to instead print a textual representation of this object. And that's what we're going to be doing in today's video. Now within our car class, we're going to be overriding the toString method. Method overriding is a different video, so if you'd like to learn more about it, feel free to check out that video. So let's override the toString method and have it do something else. So this is a public method. It's going to be returning a string. So instead of saying void, we're going to be returning a string. And the name of this method is the toString method. Make sure you spell it exactly like this. Now it's asking for us to add a return type. So we're going to return a string back to the toString method when we call it. So let's make up a string. Let's call it my string. It really doesn't matter what you call it for the most part. And let's declare what my string is. My string equals. Now we can actually return all of these values in string representation. So my string is going to equal, let's say make, and we can format this however we want. Make plus maybe a new line plus model. Maybe let's add another new line. The color plus a new line. And the year. And that should be it. All right, another way in which you can write this that only has one line of code instead of declaring the string, my string, we take all of this, copy it, delete the first line, and return everything like that. So that's another way of writing what we had before, done in only one line of code. So this is going to return a string representation of all of these attributes of our car. It's going to return the make, the model, the color, and the year. So now, if we were to run this, we're going to be using our car's toString method, and instead of getting an address of this car, we're going to get a textual representation of this object, all of the attributes that this car has, the make, the model, the color, and the year. So this is an explicit use of the toString method. And not only can we use the toString method explicitly, but we can use it implicitly. So let's write another print line statement, but this time we're going to only print the name of our car. And the result is no different. It's exactly the same. So we're implicitly using the toString method of our car when we use a print or print line statement. So you can use either one. You can either call this toString method explicitly or implicitly. But the point being is that you can override the toString method to return a string representation of all of the attributes of an object. So that's how the toString method works in Java. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how the toString method works in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can create an array of objects in Java, so sit back, relax, and enjoy the show. You too can become a hero and save our channel by punching the like button, throw a comment down below, and smash the subscribe button. Alright guys and gals, in this video I'm going to be explaining how we can create an array of objects. Now here's a few examples of arrays that we've worked on in the past. So the standard formula or steps to creating an array is to type in the data type that we're working with, a name for this array equals new, the data type again, and then a size if you don't plan on assigning values right away from the beginning when you declare this. So we have an array of integers, an array of characters, and an array of strings. So what if we wanted to create an array of objects? For example, I have a class called food. We're going to be storing some food objects within an array. So following these simple steps, let's begin creating an array of objects. So we begin by typing in the name of the data type that we are working with. The name of the data type that we are working with is food for this example. So we're going to type in food, followed by a set of straight braces. And then we need a name for this array. So we could call this foods, but I don't think that would make too much sense. So let's pretend that we're placing food in a refrigerator. Equals new, the data type again, which is food, and then a size if we do not plan on assigning values right away. So let's say that this refrigerator can hold 3 food items. So we now have an array that can hold some food objects for us. Now let's create some food objects. So let's do this after we create our array called refrigerator. So let's create 3 foods to store within this refrigerator. So we type in the name of the class, which is food. Let's call this food1 equals new food. And let's set up the constructor of our food class. So it's the same name as the class. And let's say we want to set up a parameter for a name, string name. This dot name equals name. And then we need to declare this outside of the constructor, string name. So when we create a food, we need to pass in a name. So for food1, let's say that this is pizza. And we'll create a food2 item and a food3 item. Let's say food2 will be a hamburger. We'll pass that in as an argument. And food3 will be a hot dog. So we now have 3 food items. Now we are going to store these food items in our array of food objects, our refrigerator as we call it. So in order to do that, we type in the name of the array, followed by an index. So this always begins at 0 because computers always start with 0. So our refrigerator at index 0, let's store food item number 1, which is our pizza. And for index 1, we'll store food 2. And index 2 will store food 3. And for practice, let's attempt to access one of these elements of our array of food objects called refrigerator and display it to the console window. So we can do that with a print line statement. And let's attempt to access whatever food object is at index 0. So refrigerator, index 0, and let's see what happens. Now remember that this returns the array of where this object is in your computer's memory. So this is the address of where food 1 is located in memory. What I'm trying to do is access the name variable of our food object. So I'm going to tack on dot name to the end of this because we have a name variable for all of our food objects. So this will print the name of whatever food is in element number 0 of our refrigerator, which is pizza. And we can do the same process for the other elements too. So I'm going to print element number 1 as well as element number 2. So if we were to take a look at all of the elements within our refrigerator, we have pizza, a hamburger, and a hot dog. Now there's another way of writing this too. Instead of declaring our array of food objects called refrigerator and setting a memory size, this time we're going to declare our array of food objects and assign all of these values right away. So after we create our food objects, let's declare and assign these values to our array of food objects. So we type in the name of the data type, followed by a name, refrigerator, equals, and then within curly braces, all of the values that we would like to add. We would like to add food 1, food 2, and food 3. And we do not need these lines anymore, so we can take these out. And this will do the exact same thing, but we changed the order of these steps around. So that's the basics of arrays of objects in Java. If you'd like a copy of all of this code, I will post all of this in the comments down below. But yeah, that's the basics of arrays of objects in Java. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can pass objects as arguments to a method, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Well, welcome back ladies and gentlemen. In this video I'm going to teach you guys how we can pass objects as arguments. So let me give you the rundown of what I have so far here. I have a main class, as well as a class called garage and a class called car. What we're going to be doing is sending our garage class some cars so we can park some cars in our garage. So let's create an instance of our garage class and an instance of our car class. So let's create a garage object. Garage, let's call this garage, equals new garage. Let's also create a car. Car, I'll name this car, equals new car. And I'm going to set up a constructor for this car class. Let's say that all cars should have a name. So string name, let's declare this variable. And within the constructor of our car class, we'll set up one parameter of a string that will be called car. This dot name equals name. Now, if we were to instantiate an instance of the car class, we need to send a car name. So let's say we're attempting to park a BMW within our garage class. So let's create a method within our garage class called park. So this is void, it's not returning anything. And we will call this park because we're going to be parking cars. All right, we need to set up the parameters for this method. So we first list the data type, kind of like what we did with the parameter for our string. So the data type is string, but this time, since we would like to pass in our car to the garage, the parameter is going to be car, kind of like what we did with our string, because strings are also objects, and then a name for this car. We can keep it the same just to be consistent, but really you can name this whatever you want like that, but I don't know the point of naming it that, but whatever. So let's just call this car car. And what we can do is just maybe have a print line statement such as the car.name is parked in the garage. And that should be good for now. So in order to call this park method of our garage, we need to send a car to park. So we type in the name of the class, garage, well, the name of the instance of the class, garage, dot, and we do have a park method here. And you can see that we need to send a car in order to call this method. If I attempted to run this, it's not going to work. Just like that. So in order to park a car using the garage's park method, we need to send a car object. So let's send our BMW, garage.park, and we're sending our car. The BMW is parked in the garage. Now let's park a second car. So let's create a second car. I'm going to call this car 2 and rename car as car 1. Car 2 equals new car. And let's say that this is a Tesla. And this time I'm going to park car 2. So garage.park, I'm going to send a different car object. I'm going to send car 2 this time. So we're going to park car 1 and car 2. So the BMW is parked in the garage and the Tesla is parked in the garage as well. So in conclusion, you can pass objects as arguments to a method, but when you declare that method, you have to have the parameters set up to accept objects of that data type. So for our example, we have the data type of car. So we can only send in cars to our garage to park. If we had an additional class such as bicycles and created a bicycle object, well, we could not use the park method of our garage to send in a bicycle object because we can only pass in cars because that is the parameter that we set for this park method. So that's the basics of sending objects as arguments. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how to pass objects as arguments in Java. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how the static keyword modifier works in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, I'm going to be explaining the static keyword modifier. This is a keyword modifier that can be applied to a variable, a method, or even classes, but that's a separate video. So anything that is static is also known as a static member, and a good way of thinking about this is that the class that contains that static member now owns that member, whether it's a variable or a method. So anything that the class owns is shared by all instances of that class, meaning if we create objects from this class, they all have to share this one variable or method. There is only one copy. So let me explain this with an example. I have a class called friend, and we're going to be constructing some friend objects. So I have the constructor and one parameter set up where we have to send in a name. So let's create a static variable called number of friends. So all instances of the friend class have to share this one variable. So we use the static keyword modifier, then the data type of the variable, and let's say this is an integer, and this will be called number of friends. And if we were to display this, system.out.println, now this is owned by the class itself, so we do not need to create a friend object. We can just type in the name of the class, friend, followed by what we're trying to access, number of friends. And I'm using Eclipse. You can see here that I have this little red S next to this variable. That shows that this is a static variable. And if we were to print the number of friends that we have, it's unfortunately 0. So let's create some friends. So let's create one friend object. So friend, let's call him friend1 for the instance name, equals new friend. And assign a friend name of maybe SpongeBob, because that's the first thing I thought of. And then within the constructor, let's increment the amount of friends that we have. So after everything is done, we'll add 1 to the number of friends that we have. So we now have 1 friend. Now let's create another friend. The name of this instance will be friend2, and we'll pass in a name of And now the number of friends that we have is 2. So both friend1 and friend2 are sharing the same number of friends variable because there is only a single copy and the class itself owns the static member. And if we were to create another friend, guess what's going to happen? Friend3, the name this time will be Squidward. And we now have 3 friends. Now, it's entirely possible to access a static variable using an object instance name itself. So let's replace friend with friend1. So it is possible to access this static variable using the named instance of an object from this class, but it's not recommended, and you can see here that there's a warning. The static field friend.numberofFriends should be accessed in a static way. So it is best practice to type in the name of the class that owns the static member, followed by the static member that you're trying to access. So this will display the number of friends that we have, and since there is only one copy, all of these instances of the friend class are forced to share this static member. So what do you think would happen if we removed the static modifier from this variable? Well, for one, we can no longer access this variable in a static way. So you can see that it says, cannot make a static reference to the non-static field friend.numberofFriends. So each of these friend objects now has their very own copy of the number of friends variable, and in order to display one of these copies of the number of friends variable, we would type in the name of the instance of this class, for example, friend1, and their own number of friends is 1. Same thing goes for friend2, as well as friend3. So if we change this back to static, we can make a static reference to this static variable, and this will display the total amount of friends that we have created from this class, which is 3. And not only can you apply the static keyword modifier to a variable, but you can also apply it to a method as well. So let's create a static method that returns the amount of friends that we have within a message. So let's use the static keyword modifier, and then the return type is void, and the name will be display friends. And within this method, we'll just have a println statement. So system.out.println, you have plus number of friends plus friends within a string. So we no longer need this line. Now the preferred way of calling this method is by the class name and not the name of one of its instances. So if we want to call this method, this static method of the friend class, we're going to type the name of the friend class and not one of these instances, dot, and then the method that we want to call. And you can see that we have a static method called display friends. And when we call this method, it's going to display our message, you have 3 friends. And then if we created another friend, for example, like Sandy, and this will be friend 4, and we call this method, we now have 4 friends. Now, a good example of a static method is the round method of the math class. So we type in the name of the math class. This is an unrelated example, by the way, dot round. And you can see that this is a static method. And let's take a look at the math class. So let's look for round. Okay, here is one copy of this method, and you can see that it's a static method. So we type in the name of the math class. Like, it wouldn't make sense to create a math object like math equals new math, right? It's much more simple just to type the name of the class and then use the function that you want, dot round, for example. So that's the benefit of static modifiers. It creates a single copy of a member, a variable, a method, or even an inner class too. And all instances of that class have to share that one static member. And if you need to access that static member, you use the name of the class itself. So that's the basics of the static keyword modifier. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how to use the static modifier in Java. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how inheritance works in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alright everybody, let's talk about inheritance. This is the process where one class acquires the attributes and the methods of another. So here's an example. I have my class that contains my main method, an additional class called vehicle, a class called car, and a class called bicycle. What I would like to do is have my car class and my bicycle class inherit everything from the vehicle class. So let's list a few attributes that vehicles might have. So all vehicles have a speed, supposedly. So let's make a double variable called speed. And we do not really need to assign this for this example. And maybe two methods, perhaps a go method, void, go. And what should we print? Maybe this vehicle is moving. And let's create a stop method. Void, stop. This vehicle is stopped. So I have everything related to vehicles within my vehicle class. So I would like my car class and bicycle class to receive these attributes and methods from the vehicle class so that I do not have to list this twice. So in order to use inheritance, when you define the class, we're going to add extends and then the name of the class which you would like to receive everything from. So car extends my vehicle class. And we'll do the same thing for bicycle. Bicycle extends vehicle. Now the car class and the bicycle class are subclasses of the vehicle class, also known as child classes. And the vehicle class is the superclass, also known as the parent class. So this vehicle class is like an ancestor. It's giving an inheritance to its descendants, meaning its attributes and its methods. So let's create a car object and a bicycle object to see if this theory is true. So let's create a car. Car, we'll name it car equals new car. And we'll have our car use the go method. And it says this vehicle is moving. But we didn't list anything within the car class. So how can this be? How is that possible? Well, since car is a descendant of the vehicle class, it receives everything that the vehicle class has, meaning a speed and a go method and a stop method. Now let's create a bicycle object. So bicycle, let's call this bike equals new bicycle. And we'll have our bicycle object use the stop method, which it apparently has, even though we have nothing listed within the bicycle class. And then both the car class and the bike class should have their own speed variable. So let's also display that. So let's system.out.println car.speed. The same thing goes with our bike object. System.out.println bike.speed. And they should both be 0, which they are. So that's one of the benefits of using inheritance. For one, we do not need to list all of these attributes and methods twice. Now, another benefit of this is that we can have this car class and this bicycle class have their own unique additional attributes and methods, since not all cars and bicycles are the same. They're two completely different objects. So we could say that cars will also have a perhaps number of wheels. So int wheels, and we'll set this to 4. And then bicycles will say int wheels equals 2. And then with cars, they have doors. We can create another variable for that, int doors. And this could be like 2 or 4. I'll just say 4 for now. And then bicycles don't have doors, but they do have pedals. So int pedals. And this will be 2. And if we head back to our main method, let's display the amount of doors that cars have and the amount of pedals that bikes have. So we can do this with a println statement, car.doors. And we'll display this, and we'll do the same thing with bikes, but display the number of pedals, bike.pedals. So our car has 4 doors and our bike has 2 pedals. Now, these attributes are unique to the car class and the bike class. So cars don't have pedals, and if we try and access the pedals variable, well, it's not going to be recognized, and our bike doesn't have doors. So this variable isn't recognized either. So when might you want to use inheritance? Well, for one, you'll probably want to use it if you have more than one class. So if you have two separate classes, for example, cars and bicycles, you can list everything that they have in common, such as a speed, some ability to move or go, and an ability to stop. And then we can just list that within another class and have our car class and bicycle class just receive everything that this vehicle class has, because this is what they all have in common. So that's the basics of inheritance. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of inheritance in Java. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about method overriding in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys, I'm going to teach you all about method overriding. This is done by declaring a method in a subclass, which is already present in a parent class, and this is done so that a child class can have its own implementation of that method. So here's an example. I have two additional classes, a class called animal and a class called dog that extends animal. So the dog class is going to inherit everything that the animal class has. So let's say our animal class has one method, maybe a speak method, void speak. And all that this method will do is just display a message to the console window such as the animal speaks. I don't know what kind of animal it is, but it's speaking. So let's create a dog object, and our dog class is going to inherit everything from the animal class, just a speak method really. So let's create a dog object. Dog equals new dog. And we can have our dog object use the speak method, which will display the animal speaks. Now what we could do is that we can give this class its own implementation of our method, speak. So it's going to have the same name, speak. And I'm just going to copy everything I have here, paste it, and what we are doing now is called method overriding. We're giving this dog class its own implementation of this method, speak. And we can have this method do something more specific for dogs, such as displaying a message like the dog goes bark. And if we were to compile and run this again, our new message says the dog goes bark. Now our speak method within the dog class is considered the overriding method, and the one that it inherits from its parent class is considered the overridden method. So if we're overriding a method, the overriding method should have this annotation on the top, at override. This isn't necessary, but it's considered good practice to add this note in just to let other users know that this is an overriding method, but it doesn't add any additional functionality. So if we were to create an animal object this time, animal, let's call this animal, equals new animal, and we have our animal object use the speak method, it's going to use its own implementation of the speak method, which just states the animal speaks. And if we use dog, this will display the dog goes bark. So each class is going to use the method that is more closely associated with it. With our dog class, if we removed the overriding speak method, well, it's going to next use the closest speak method available to it, which is the one it inherits from the animal class. So this will now display the animal speaks. And that's all really that method overriding is. It allows a child class to have its own implementation of a method that it inherits from a parent class, so that with this method, you could do something that is more specific to this class, such as changing the message from the animal speaks to the dog goes bark. So that's the basics of method overriding in Java. If you'd like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of method overriding in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video we're going to be creating some superhero objects using the super keyword in Java. So sit back, relax, and enjoy the show. You too can become a hero and save our channel by punching the like button, throw a comment down below, and smash the subscribe button. Well, okay everybody, let's talk about the super keyword. This refers to the superclass, also known as the parent class of an object. That's assuming that you're using inheritance. It's very similar to this keyword. This refers to the class that this keyword contains, and super is referring to this object's parent class. So here's an example. I have two additional classes, a class called person and a class called hero, like a superhero that extends the person class. So let's set these two classes up. What are some attributes that a person would have? They would probably have a name and an age, so string name and int age. Then let's also create the constructor for this class, but we'll set the parameters up later. And then for heroes, let's assume that all heroes have a superpower. So this will be string power. And let's also create the constructor for this class called hero. Now, when we create a hero object, let's say that we want to pass in some arguments. So let's create our first hero object. Hero, let's call this hero1 equals new hero. And then we'll send some arguments to our constructor for hero. So let's say we want a name, an age, and a power in that order. So our first hero will have a name of Batman, and then an age of maybe 42, and Batman's power is, well, he's rich, so his power is money. All right, now we need to set up the parameters for our hero constructor. So we need a string, an integer, and a string again. String name, int age, and string power. And we are going to assign these values to each of the attributes that our heroes have. So this dot name equals name, this dot age equals age, and this dot power equals power. Now, the way that I have written this does work, but it's actually not the best way to do this. Since we declared our name and age variables within the person class, we should really assign these values within the constructor for the person class. And with our hero class, we only declared a power variable, so we should assign the power value within the constructor of this specific class. So what we would like to do is send our name value and age value to the super class, to the constructor of the super class. And if you want to get the attention of the super class, you have to use the super keyword. And the super keyword works very similar to this keyword. This refers to this class that we're in. Super refers to the super class, also known as the parent class, which in this case is person. So we would like to call the constructor of the super class person. So we have super set up, that's referring to our person class, and now we need to call the constructor. So all we do after super is add a set of parentheses, and that is it. And we would like to pass in the name and age value as arguments. So let's do that. Name and age. And we no longer need these two lines. We can simply put these within the constructor of our superclass person, and our person constructor will take care of that for us. But we also have to set up the parameters for name and age. String name and int age. And that's it. So you can see that that error went away. So when we create a hero object, we're going to pass in a name, an age, and a power. And when we construct a hero object, we have our parameter set up, a name, an age, and a power, because all heroes should have a name, an age, and a power. So we're immediately going to send our name and age values to the constructor of the superclass, which is person. And the person constructor will take care of that for us because that's its job, to assign names and age values to those variables. So then we can actually print out all of these values. System.out.println hero1 dot name, and let's do the same thing for age and power. Hero1 dot age and hero1 dot power. And this should display everything. Batman, he's 42 and his power is money. So let's create another hero for another example. So this will be hero 2. And this will be Superman. I don't know how old Superman is, but let's say he's 43. And his power, well, he can do a lot of things, so let's just say his power is everything. And let's get rid of these print line statements because we won't need them anymore. All right, so one thing we can do too is use the super keyword to call a method within the superclass. So let's say our person class has a toString method to display the name and the age variables. So let's create that. So we need to add the public keyword to this. There's a separate video on that. Public, we're returning a string, and this is the toString method. And all we're going to do is return our name and our age. So return this dot name. I'll add a new line just to format this. Plus this dot age. And a new line. And we should be good. So here's where the super keyword comes in. Let's say we have a toString method within our hero class as well. And I'm just going to copy this and make a few changes. So we also have a toString method within our hero class. So what we could do is first return the name and the age. So we would like to call the toString method of our super class. So we're going to use the super keyword dot and use the toString method. But we would also like to add the power that we have. So we're just going to tack on plus this dot power. And that's it. And let's display hero2's attributes. So system.out.println hero2.toString. And this should display all of the attributes that our hero has. Superman, he's 43 years old, and his power is basically, well, everything. So that's the basics of the super keyword. It's really referring to the superclass of an object, whereas this refers to this class. Well, that's the basics of the super keyword. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of the super keyword in Java. Hey, what's going on everybody? It's your bro, hope you're doing well. And in this video, I'm going to teach you guys about the abstract keyword in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alright, let's talk about the abstract keyword. So this is a keyword that can be applied to both classes and methods when you define them. Let's begin with abstract classes. An abstract class cannot be instantiated, but they can have a subclass that can be. And here's an example. I have two additional classes, a class called vehicle and a class called car that extends vehicle. So car is the subclass, also known as the child class of the vehicle class, and we can create objects from both of these classes. And let's try that. So first, let's create a car. Car equals new car. And let's also create a vehicle object because we can. So vehicle equals new vehicle. So we can create instances of both of these classes just fine, but we may not want to be able to do so. So adding the abstract keyword to a class adds a layer of security. So here's an example. Let's pretend that we walk into a car dealership and we ask a salesperson for a vehicle, and they might reply with, well, what kind of vehicle are you looking for? Are you looking for a car, a motorcycle, a truck? And we just say, no, we want a plain generic vehicle. And they might think you're crazy because a vehicle is too generic. It's an idea. It's abstract. Well, at least it should be abstract. We need a certain type of vehicle. So what we could do to prevent somebody from creating an instance of a class that is too vague or abstract, we can use the abstract modifier when we declare this class. So with vehicles, let's add the abstract modifier. And we can no longer create an instance of this class. And it says cannot instantiate the type vehicle. So this adds a layer of security to this program. So in order to get this to run, we cannot declare a vehicle object. We have to pick a certain type of vehicle, a child class of the vehicle class, whether it's a car, a bike, a truck, whatever. Now we can also create an abstract method too. So let's declare this within the vehicle class. And an abstract method is declared without an implementation. So that means without a body. So let's say that all vehicles should have a method to go, because that's the point of a vehicle. So all vehicles should go. This is going to be an abstract method. We're going to use the abstract keyword. We need a return type. We'll just make this void, and this will be go. And we do not need a body for this method. And if we attempt to add a body, a set of curly braces, well, we're going to have a problem. And this says abstract methods do not specify a body. So what this does is that it forces us to implement this method in one of the child classes that our vehicle class has. So if we attempt to run this, actually you can see that it's popping up already. The type car must implement the inherited abstract method vehicle.go. So what we could do is add unimplemented methods, and what we're doing is actually method overriding. So we can add our own implementation of this go method, more specifically for cars. So let's say maybe the driver is driving the car, and that should be fine. So we can no longer create an instance of the vehicle class because it's abstract, and a vehicle object is too vague. So we would like to force a user to pick a certain type of vehicle, a class that inherits from the vehicle class. And we can also use the go method that is found within the vehicle class too, but we are forced to override it or implement it in each of the child classes that our vehicle might have. And it's just the same as what we would normally do with calling a method. So car.go, and this will print the driver is driving the car. So that's the whole point of the abstract keyword. It adds a layer of security to your program, and this can be applied to both classes and methods. If it's applied to a class, a user cannot instantiate an instance of an abstract class. And with abstract methods, they are declared without an implementation, but a subclass or child class has to implement that somewhere. Well, that's the basics of the abstract keyword. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of the abstract keyword in Java. Hey, what's going on everybody? It's your bro, hope you're doing well. And in this video, I'm going to teach you guys about different access modifiers in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everyone, so access modifiers add a layer of security to our programs, and there are 3 access modifiers I'm going to cover, besides the default, which is none. They are public, protected, and private. So to best demonstrate this, we're going to need some packages this time. So within your project folder, we're going to create 2 packages. I do have a separate video on packages somewhere within this playlist. So let's call this first package package 1. And all a package is a collection of classes, whereas a class is a collection of code. So we'll call this package 1 and click finish. We'll create a second package called package 2, file, new, package, and this will be package 2, and click finish. We're going to create 2 classes within each package. So let's click on package 1, then go to file, new class. We will call this class A and check public static void main. Let's create a second class called B, file, new class, and this is also going to be within package 1. Name is B. Then within package 2, we're going to create a class called C, file, new class, C. And lastly, file, new class, make sure that this is within package 2, and this is going to be a sub. This is going to be a subclass of the A class. So a sub extends A. In order for us to inherit everything from the class A from package 1, we'll need to include an import. So import package1.a, but I'm just going to change this to an asterisk to import everything. So we'll include some imports within each of these classes. So let's begin with class A. We're going to import everything from package 2. Class B, import everything from package 2. Class C, import everything from package 1 this time. So with our A subclass, we can now inherit everything from the A class within package 1. So let's begin with access modifiers, and we're first going to discuss the default access modifier. So I'm going to create a string variable within my C class. Let's say that this is a string variable called default message, and this will display or hold, this is the default. So currently I'm using no access modifier, and I would like to see who or which classes can see this default message that has no access modifier, the default access modifier. Let's head back to our A class within package1, and let's create an instance of our C class. Well, I suppose we also could have made this a static variable, but hey, too late. So let's create an instance of the C class. C equals new C. And I'm going to attempt to print the default message variable of the C class. So C dot default message. And I'm just going to copy this, paste it. All right, but we're going to have a problem though, and this states that the field C.defaultMessage is not visible. That's because anything using the default access modifier is only visible to anything within the same package. So anything within package 2 is going to be able to access this default message variable, but anything within a different package, such as our A class and B class, cannot. So let's attempt to do this again, but within our A subclass. So I'm going to copy everything I have here, including the main method, and just paste it within our A subclass. So we now actually have access to our default message variable within the C class because these are both within the same package. All right, well, for now, I'm going to move this main method back to our A class within package 1. So let's create another variable, and this is going to be a public variable. So let's use the public modifier. Public, this is going to be a string, and let's call this public message. And this will hold a string of this is public. All right, now I'm going to attempt to access this variable public message from the A class, which is in package 1. So C dot, and you can see it right here, public message, and this will display this is public. That's because anything that uses the public keyword is visible to any package within the project folder. So even though this is in package 2, it's still visible to anything within package 1. And a lot of other classes use this, such as class C. This is public, A sub is public, B is public, and A is public. Now check this out. We have created an instance of our C class within class A. But what would happen if we removed the public access modifier from the class definition of C? Well, now currently, C is using the default access modifier, so our class C is only visible to classes within the same package as class C. If we go back to class A, well, now class A can no longer create an instance of class C because the visibility of C has changed. Class A is within package 1, and we can no longer access class C because class C is only available to classes within the same package. So let's change the visibility of C back to public. So that's all what the public access modifier is. Anything that is public is available or visible to other packages. Our next access modifier is the protected access modifier. So let's create a protected variable. Let's call this string protected message. And let's change the string to this is protected. Here's how the protected access modifier works. So something that is protected is accessible to a different class in a different package as long as that class is a subclass of whatever class contains this protected member. So for this example, let's copy this line of our protected message and paste it within the A class. We're going to take our main method, cut it, and then copy this within our A subclass. Let's remove this instance of our C class, and we're going to create an instance of our A subclass. So A sub, let's call this A sub all lowercase equals new A sub. So A sub extends A. Even though A is in a different package, we have access to this protected variable because something that is protected is accessible to a different class in a different package as long as that class is a subclass of whatever class contains that protected member. So we have an instance of our A subclass, and we should be able to access this protected message variable. So system.out.println A sub dot, and here is our protected message. and it just states this is protected. And our last access modifier is private. So let's create a private variable. Private, let's copy what we have for our default message and change default to private. So this will be private message, and the string will be this is private. All right, now let's copy all of this and paste it within class B. So something that is private is only visible to the class that it contains itself. So only class B has access to this private message. So I'm going to revert everything that I changed for class A. So let's put this main method back in, remove the main method from A sub, and let's create an instance of our B class. So B equals new B. And I would like to access this private message found within class B. So system.out.println B dot, but it doesn't appear that we can actually see that. So let's attempt to actually print this b.private message, but this states the field b.private message is not visible. That's because something that is private is only visible to the class that it contains and nothing else, even if it's within the same package. Well, that's the basics of access modifiers. We have public, protected, the default access modifier, and private. So if you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of access modifiers in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about encapsulation in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Let's talk about encapsulation. This is the concept of attributes of a class being hidden or private. They can be accessed only through special methods called getters and setters. And you really should make attributes private if you don't have a reason to make them public or protected. In this tutorial series, I don't, just for learning purposes. I want to make things as less complicated as possible, so I tend to not use encapsulation. But for your own programs, you probably should, just to add a layer of security. So I have an additional class for this example called car. Let's make some private variables. So let's say we would like a make, a model, and a year. So I want to make these private so that only this class can access them. So private string make, private string model, and private int year. Let's also set up the constructor of the class while we're here. So the parameters are make, model, and year. String make, string model, and int year. And when we construct a car, we'll just say this dot make equals make, this dot model equals model, and this dot year equals year. Now let's attempt to construct a car object. So car equals new car. What kinds of arguments do we want to pass in? We need a make, a model, and a year. So for this car, let's say that this is a Chevrolet. For the next argument, maybe a Camaro and a year. 2021 is good. So this will work just fine. What would happen if we attempt to access one of these private members, like the make, the model, and a year? Let's find out. So system.out.println, I'm going to attempt to print the car's make. And let's see what happens. Well, there's a problem. The field car.make is not visible. That's because this is private. All of these variables are private, so they are hidden. Only this class has access to these members, make, model, and year. So what can we do to retrieve the value of one of these variables? We can use a getter method. So that is a special method found within the class that contains these private members that will send the make, the model, or the year, whatever variable you're working with, to whatever class is calling that method. So we're going to create a getter method for each of our variables that are private, make, model, and year. So let's begin with make. So this is going to be a separate method. It's going to be public. The return type is a string, and we will call this get, then the name of the variable, make. And all we're doing is returning the make, and that's it. Let's repeat the process for model and year. So public string get model, return whatever our model is. And lastly, this is returning an integer, and this is get year, return year. And in order to access one of these attributes, one of these variables, we need to use the appropriate getter method. So instead of accessing this attribute directly, we're going to use one of these methods. Get, and we have make, model, and year. So let's get the make of this car, and it's going to return Chevrolet. So it's as if we're asking this class nicely, can we pretty please get the make, the model, or the year of your car? So that's one way in which you can access a private attribute. You use a getter method, and then you can call that method from anywhere, basically, since we made this public. And if you need to retrieve the other private variables of this class, you just use the appropriate get method. So let's say we want the model, so car.getModel, and the year, car.getYear. So this will retrieve all of the private variables of our car object. Chevrolet Camaro, the year is 2021. So now how can we change the private attributes of an object? Well, we can use what's called a setter method this time. Let's attempt to change the year of this car. Car.year, and we'll change this from 2021 to 2022. Well, the issue that occurs is that the field car.year is not visible since we set this to private. So we would need to create a method called a setter to set the year of this car, the make, the model, and the year. It's kind of like what we did with our getter methods, but these are called setters. So let's create a setter method for the make, the model, and the year so that we can call this method to change one of these values. So this is public. The return type is void. We're not returning anything. And we'll call this set and then the name of each variable that you're working with. So let's create a setter for the make. And we do need one parameter, whatever our make is. So if we call the set make method, we have to pass in a new argument. So string make. This dot make equals make. And actually, since we're setting the make here within a setter method, we no longer need this line. What we could do is call the set make method within the constructor now. So this dot set make, and we have to pass in our make. And let's repeat the steps for model and year. Set model. This will take a string model. This dot model equals model. And we no longer need to set that within the constructor. We'll just call this dot set model and pass in our model. And lastly, we have the year. Public void set year. This has one integer parameter, int year. This dot year equals year. And we can just call that method. This dot set year and pass in our year. And now if we need to change one of these values, we can use the setter method, car dot set year, and we'll pass in a year, like 2022. And then let's display all of these values using our getter methods. And now our car is a 2022 Chevrolet Camaro. Well, that's the basics of encapsulation. All we're really doing is making the attributes of our class private so that they cannot be directly accessed from elsewhere within our program. If you need to retrieve one of these values, you can use a getter method. If you need to change or set one of these values, you can use a setter method so that you can indirectly either get or set these values, and other classes do not have direct access to these values. So if you'd like a copy of all this code, I will post everything in the comments down below. But yeah, that's the basics of encapsulation in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can copy objects in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, I'm going to teach you all how we can copy objects in Java. Here's an example of the setup that I have so far. we're going to be copying some car objects, and I have an additional class called car, and we're going to be using some encapsulation in this video based on the last video on encapsulation. So we have some private variables, a private make, model, and year. We have a constructor for this car, and when we receive each of these arguments, we're going to call the appropriate setter method to assign each of these values. And we have some getter methods as well for each of these values in case we want to get them. Here's what I'm doing within my main method. I have created two cars, car 1 and car 2. Car 1 is a Chevy Camaro, the year is 2021. Car 2 is a Ford Mustang, the year is 2022. I'm going to be first printing the addresses of car 1 and car 2, where these objects are stored in memory, as well as all of car 1's attributes, the make, the model, and the year using the getter methods, and car 2's make, model, and year using the getter methods as well. So this is what we have. These are the addresses of these two objects. Car 1 has an address of this in memory. Car 2 has an address of this in memory. Here are all of car 1's attributes. It's a Chevy Camaro, the year is 2021, which we stated here. And our second car is a Ford Mustang, the year is 2022, and we just displayed all of the attributes using the appropriate getter methods. Let's say that we would like to copy the values from car 1 over to car 2. And a common misconception that people might do or write is that they would write something like this. Car 2 equals car 1, and you do not want to do this. Here's why. So with these two addresses of these cars, they now have the same address, and it appears that these values copied over. Well, that's because car 2 and car 1 are now the same exact car because they have the same address. What we actually did was give car 1 two different names. For all intents and purposes, car 1 is referred to as both car 1 and car 2 because they share the same address in memory. So even though it appears that these values have copied over, they're really just pointing to the same car in memory. So we're not going to be stating car 2 equals car 1. We're going to be creating a copy method within our car class to assign the values from car 1 and apply them to car 2. So let's create a copy method, but first we'll want to call this. So this will look something like this, car2.copy, and we're going to pass in the object that we want to copy. We would like to pass in car 1. So we're sending a car object as an argument to this method. Now we need to set up this method within the car class. So let's go to our car class and create a copy method. Public void, it's not returning anything, and we will call this copy, and this takes one argument. This will take a car object as an argument, so we'll just call this car x. And what we have to do within this method is copy the attributes from car 1 over to car 2. And this is how we can do that. So we can use this keyword. Right now we're referring to car 2 because car 2 is the object that has called this method. So this refers to car 2. This, and we're going to use the setters, set make, set model, and set year. So this dot set make, this dot set model, and this dot set year. Now we need to get the values of car x. That's the car that we passed in, car 1. So within the arguments of each of these methods, we're going to state x dot get make, as well as x dot get model, and lastly x dot get year. And that's all there is to it. So if we head back to our main method and run this, these cars now have two different addresses in memory, so they are both different cars, but they have the same attributes. They're both Chevy Camaros, and the year is 2021. Here's a scenario. So what if we would like to copy the values from one car and apply them to another, but this time we'll do it when we instantiate the car instead of after the fact. So for this example, let's turn these two lines into a comment. And what we're going to be doing is creating something called a copy constructor. So let's instantiate car 2 like we normally would. So car 2 equals new car. But within the constructor of our car, we're going to pass in car 1 as an argument and make a copy of this. So we're going to be using some overloaded constructors, And the second constructor is going to be the copy constructor. So car, the parameter is a car object. So we passed in a car as an argument, and we have to set up the parameter for our car copy constructor. So this will take a car, and we'll call this x. So we would like to take the values of car x and apply them to the values of our new car when we construct it. Luckily, we already have a copy method to take care of that, so it's just a matter of calling this method from within the constructor. So this dot copy, and we're going to make a copy of car x that we receive when we call the car constructor. So this will do the same thing as it did before. These are two different cars, but they all have the same values. The difference is that we assigned the values from car 1 and applied them to car 2 when we constructed this car object. Well, ladies and gentlemen, that's the basics of copying objects in Java. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how to copy objects in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about interfaces in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Well, let's talk about interfaces. Think of interfaces as a template that can be applied to a class. It's similar to inheritance, but it specifies what a class has or must do. Classes can apply more than one interface, so that's a key thing to take away from this, whereas an inheritance is limited to just one direct superclass. Here's an example. I have 3 additional classes. I have a class called rabbit, a class called hawk, and a class called fish. We're going to be creating some interfaces, 2 for this example, one called prey and another called predator, and we're going to have some of these classes implement these interfaces depending on what the animal is. So this is how to create an interface. Go to File, New, Interface, and let's call the first one prey. And click Finish. Alright, so we have an interface called prey. Public interface prey. Let's create another interface. File, New, Interface. This will be predator. Okay, so we have 2 interfaces, prey and predator. With interfaces, you can declare variables normally like you can do with inheritance. You can also declare some methods, and you do not need to create a body for these methods. So when a class is implementing one of these interfaces, they need to implement and define what this method is going to do. So let's begin with prey. Let's write just one method. So what's a method that prey will do? Well, prey flee from predators. So let's create a method called flee. This will be void flee, and that's it. We do not need a body. So void flee, that's it. There is no body to this. And let's say that our rabbit is going to use this interface. Now to implement an interface, when you define the class, just type implements, then the name of the interface. We would like to implement the prey interface. Implements prey. So one thing with interfaces, if you declare a method, it works like an abstract method. We need to define what this method is going to do. So within the rabbit class, we need to add any unimplemented methods. So we're basically overriding this flee method. So what do we want our rabbit to do when we call the flee method? So maybe just a simple system.out.println that states the rabbit is fleeing. And let's test this. Let's create a rabbit object. Rabbit equals new rabbit. And let's see if we can call that method rabbit.flee. There it is. The rabbit is fleeing. Now let's apply the predator template, well, interface, to the hawk class because hawks are predators. They are very rarely prey. Well, I could be wrong. All right, so public class hawk implements predator. And we should probably create a method within predator for this example. So if an animal is a predator, they should have the ability to hunt. So let's create a method called hunt. void hunt. And we do not need to declare a body. So within our hawk class, we need to add any unimplemented methods and define what this does within this implementation. So let's say if the hawk object is going to use the hunt method, we will display the hawk is hunting. And let's create a hawk object this time. So hawk equals new hawk. Hawk dot hunt. The hawk is hunting. Now, since we're implementing the predator interface, there is going to be no flee method for hawks because we're not using the prey interface, we're using the predator interface. So just to prove that, we'll attempt to use hawk.flee, and it doesn't appear that there's a method for that. Yep, method flee is undefined for the type hawk. Alright, now we can apply more than one interface to a class. So with fish can be both prey and predators depending on their size. Bigger fish tend to eat smaller fish. So let's add two templates, two interfaces to our class fish. And this is how to do that. Implements prey, comma, predators. So we're applying both of these templates, these interfaces to our class fish. So we're implementing prey and predator, but we need to add any unimplemented methods, and we have two this time. One hunt from the predator interface and another flee from the prey interface. So let's define these. So system.out.println within hunt, we'll just state that this fish is hunting smaller fish. And with the flee method, system.out.println, let's say this fish is fleeing from a larger fish. And let's try this. So let's create a fish object. Fish equals new fish. Fish dot hunt. So our fish has a hunt method. The fish is hunting smaller fish, and it has a flee method, fish.flee. The fish is fleeing from a larger fish. So in conclusion, an interface, think of it like a template that can be applied to a class. It's similar to inheritance, but it specifies what a class has or must do. And classes can apply more than one interface, and we did that with our fish class. It's implementing both the prey and the predator interfaces, so it has access to both of these methods, but it needs to actually implement these methods by overriding these methods. So that's the basics of interfaces in Java. If you'd like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how interfaces work in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about polymorphism in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Polymorphism. This is a Greek word for poly, meaning many, and morph, meaning form or forms. It's the ability of an object to identify as more than one type. Think of it as being identified as more than one data type. Here's an example. Let's say we're going to have a race, and we can enter in all different sorts of vehicles into this race. They don't all have to be the same. So we have a few additional classes, a class called vehicle. Vehicle is going to act as the parent class for my class car. So car extends vehicle, bicycle extends vehicle, and boat extends vehicle. So car, bicycle, and boat are all subclasses or children classes of the vehicle superclass. So let's create an instance of our car, bicycle, and boat. Luckily, through the magic of copying and pasting, I have done that already. We have a car object, a bicycle object, and a boat object. So let's store, well, at least attempt to store all of these objects within an array called racers. Racers equals, and then we will place our car, bicycle, and boat within this array. So what's the data type of this array going to be? Well, we're going to have a problem. Could we make this cars? Well, we could store our car object within an array of cars, but not our bicycle and our boat. The same thing goes for bicycle. We could store our bicycle, but not the car and the boat. And lastly, with the boat data type, we can store the boat, but not the car and the bicycle. And to solve this issue, we can use the power of polymorphism. So, for example, our car identifies as a car, but since it extends the vehicle class, it also identifies as a vehicle. Same thing goes with our bicycle and our boat. So, one thing they all have in common is that they are all vehicles, so we can change the data type of this array to vehicles. And therefore, we can store our car, our bicycle, and our boat, because all of these objects also identify as vehicles. So if you're going to store objects within an array, and they're all different object types, you would have to find what they have in common and make an array of that type. So that's how to store different objects within an array using polymorphism. And now for our arrays, we're going to call a go method that we're going to define within each of our classes car, bicycle, and boat. So let's begin with car. Let's create a go method. So let's make this public, void, it's not returning anything, and this will be called go. So when we call this method, all we'll do is have a printline statement, system.out.println. Let's say something like, the car begins moving. Okay, let's repeat the process for bicycle and boat. Let's change car to bicycle, and within the boat class, car to boat. So each of these methods, well, each of these classes has their own go method, and we could call them individually kind of like this, car.go, bicycle.go, and boat.go. So this would work, but there's actually a better way to write this. And what would be better is if we were to create an enhanced for loop to iterate through all of the elements of this array of vehicles. So the data type for this enhanced for loop is going to be vehicle. We'll use x as our counter, colon, and then the name of the array, which is racers. So this is going to iterate once through all of the elements of this array of vehicles called racers. X represents the vehicle we are currently working with. So x dot, and we would like to use the go method. So our enhanced for loop doesn't care what kind of vehicle you are, if you're a car, a bicycle, or a boat. It cares that you're a vehicle, and if you're a vehicle, use your go method, whatever kind of vehicle you are. So there's one more step to this too. The method go is undefined for the type vehicle, so we need to make sure we have this go method within our class of vehicle, and I just generated that here. So what we're doing is actually method overriding within the car, the bicycle, and the boat class. So this isn't necessary, but it's considered good practice to add the add override annotation to each of these methods. And then our enhanced for loop is going to iterate through all of the elements of our array of vehicles called racers. So it doesn't care what kind of vehicle you are. If you're a vehicle, use your go method. Well, luckily our car, our bicycle, and our boat all also identify as a vehicle. So that's all that polymorphism is. It's the ability of an object to identify as more than one type. Think of it as identifying as more than one data type. Our car does identify as a car, but it also identifies as a vehicle. Same thing can be said with our bicycle and our boat. But not only that, all objects are children classes of the object class, so they also identify as objects. So you could write this using the object data type, but there's a few other changes that we would have to make. So that's all that polymorphism is. It's the ability of an object to identify as more than one type. So if you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of polymorphism in Java. How's it going, everybody? It's your bro here, hope you're doing well, and in this video we're going to be discussing dynamic polymorphism in Java, so let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, so we're going to be discussing dynamic polymorphism, and I know that sounds somewhat intimidating, but it's not too bad once you break down the vocabulary. So what we learned in the last video on polymorphism is that polymorphism is a Greek term. Poly means many, and then morph means either shape or form. And when you put those two together, it means many shapes or forms. So picture a Corvette. A Corvette can have many shapes and forms. It identifies as one, a Corvette. It also identifies as a car, also as a vehicle, and it also identifies as an object. Now, the word dynamic, that means in programming, after the compilation phase, after the program compiles. So this is during runtime, after the program is already running. So when you combine these two words together, dynamic polymorphism, it's the ability of an object to take many shapes or forms after the program is already running. So what we're going to be doing for this video is declaring an object of the animal class, which we have to make still, and we'll call this object animal, and we'll give the user two choices. They can have a dog or a cat. So we're going to end up either declaring this as an instance of the dog class and use the dog constructor, or use the cat constructor, but we don't know quite yet. So we're going to ask the user during runtime. So for now, we're only going to declare that we want an animal of the animal class, but we don't know if they're going to be a dog or a cat. They're going to assume one of those forms. So let's create a few classes. So within your project folder, you can right click, go to new, class, and let's create an animal class. And this is going to be the parent class for dog and cat. So that's good for now. Let's head back to our project folder and create a dog class. So dog is going to extends animal because dog is the child class of animal. And let's create a cat class. So cat, finish, cat extends the animal class. Let's also give these classes maybe just one method. So we'll make this a public void method, and let's call it speak. So this animal is going to say something relevant to the type of animal that it is. So maybe cat goes meow. And let's do the same thing for dog, and I'll just copy this, paste it, and we'll change cat to dog. Dog goes bark. And let's do the same thing for animal, even though we don't have to. So what's something generic that all animals say? I can't really think of anything, so I'm just going to make up something. Animal goes burr. So the speak method for the dog class and the speak method for the cat class are actually overridden methods. They're overriding the speak method of the animal class. So it's considered good practice to add a note that says override to let other users know that this is a overridden method. And if we instantiate an object of the dog class or the cat class, it's going to use its associated speak method compared to the generic speak method for the animal class. Now let's head back to our main class. So what we're going to be doing is prompting the user to type in if they want a dog or a cat, and then we're going to instantiate an object of that type, of that specific form. So let's create a prompt, but we'll need a scanner first. So let's create an instance of a scanner. So scanner, let's call it scanner with a lowercase s, equals new scanner. Then within parentheses, system.in. And then we'll need to import something. So make sure you have this import at the top. Now let's create a prompt for the user. So we'll system.out.println, what animal do you want? And then we'll give them two choices. So maybe we'll do this on a second line. So maybe we'll type in 1 equals dog or 2 equals cat. Maybe I'll just make this a print statement. Okay, and then let's give the user a choice. So we'll assign this to a variable. So we'll make this an integer because it's going to store a number. So int choice equals scanner dot next int. All right, so then we're going to have a few if statements here. So if choice is equal to 1, what we'll do is that we're going to take our animal object and we're going to finish instantiating this. So new, and we're going to use the dog constructor. We're going to construct this animal as a dog, and then we'll have this animal use its speak function. So this is going to be an overridden method. It's going to use this specific overridden method for dogs. Let's do the same thing for the cat. So we'll change this to an else if statement, choice equals 2, animal equals new cat, and we'll use the cat constructor. The animal will still use its speak method, and then else, they must have typed in something wrong. We'll instantiate this with the animal class. So new animal, use the animal constructor. System.out.println. That choice was invalid. And then maybe we'll use the animal.speak method as well. All right, let's test this. What animal do you want? Let's pick a dog. I like dogs. Dog goes bark. And let's try it again. What animal do you want? I want a cat this time. Cat goes meow. And let's try this one last time. Let's make up a random number. I like the number 42. That choice was invalid. Animal goes brr. So that's one of the benefits of dynamic polymorphism. You can declare an object and make space for it in memory, even if you don't know what type of object you want quite yet. So for example, we said that we want an animal and we're going to make room in our program for an animal, but we don't know quite yet what kind of animal it's going to be. And in our case, we're not sure if this animal is going to be a dog or a cat. So here's a few other examples of dynamic polymorphism. So do you remember in pretty much any game from the Pokemon series, you had to choose if you were a boy or a girl? Well, you could declare that your data type is a human as a placeholder, but you're going to use the appropriate game sprite for a boy or a girl once you make your decision. Otherwise, let's take World of Warcraft. So you have to pick a character class, but when you first create your character, you don't have one picked out quite yet. So you have to later decide if this character is going to be a paladin, a hunter, a mage, etc. And then once this object does assume a form during runtime, it's going to inherit everything from the parent classes, and if there's any methods that are overridden, they're going to use these overridden methods in place of any previous methods that they might have had. So that's the basics of dynamic polymorphism. If you want a copy of all this code, I'll post all of this in the comments down below. But, well, yeah, that's the basics for dynamic polymorphism in Java. Hey, how's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys how we can handle exceptions in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alright guys and gals, let's talk about exceptions. These are events that occur during the execution of a program that disrupt the normal flow of instructions. Think of these as unexpected events that occur that will stop your program, like if you divide by 0, that's referred to as an arithmetic exception, and that will stop your program. We would like some way to gracefully handle these exceptions and continue on with the set of instructions and ignore that exception. So let's say we would like to create a program where we divide two numbers and display the result. So let's write a program like that. So first let's create a scanner. Scanner equals new scanner. Within the constructor, we're going to say system.in. And we'll create a prompt to enter a number in. Let's say a whole number. Enter a whole number to divide. Let's store this within a variable called int x. Int x equals scanner dot next int. And let's create a second variable called y. We'll divide x by y. Enter a whole number to divide by. And we'll store this within variable y. And we'll say int z equals x divided by y. And we will print the result to the console window. System.out.println, let's say result plus z, and that should be good. Okay, let's intentionally divide a number by 0. Enter a whole number to divide. 5 divided by 0, boom, exception. Now our console window states exception in thread main, and this is the type of exception that we encountered. We encountered an arithmetic exception because we divided a number by 0 at line 18. Int z equals x divided by y. So one way in which we can handle these exceptions and prevent our program from being interrupted is to surround any dangerous code within a try block. So we type try outside of the dangerous code and surround all of the dangerous code within a set of curly braces. And I'm just going to indent all of this. So we're going to try all of this code. If we encounter an exception, we're going to perform whatever is within our catch block, which we will follow this with. Catch, parentheses, and then a set of curly braces. So we're going to list the type of exception we would like to catch within the parentheses of our catch block. So let's attempt to catch an arithmetic exception. Arithmetic exception, and then we'll call this exception E. All right, so if we encounter an arithmetic exception, we're going to instead stop what we're doing within this try block and perform whatever is within our catch block. So let's print a message instead. You can't divide by 0, idiot. And let's try this again. Enter a whole number to divide. 5 divided by 0. You can't divide by 0, idiot. So you can see that our program was not interrupted because we caught the arithmetic exception that we encountered, and we instead performed whatever code is within the catch block. So here's another type of exception that we might run into. What if somebody doesn't enter in a number? Let's say we enter in a whole number to divide, like 5, and we decide to divide by the number pizza. Well, now we encountered an input mismatch exception. We can also catch that as well, and we can do that within another catch block. So this time, we'll attempt to catch an input mismatch exception. And I'm just going to copy this because I do not feel like typing it. Input mismatch exception E. And let's print something. Please enter a number, OMFG. And you might have to import something too, apparently. Okay, let's try this again. Enter a whole number to divide. Let's divide 5 by pizza again. Please enter a number, OMFG. So there is a catch block that will catch all exceptions, but it's kind of considered lazy to use by itself. It's exception E, and this will catch basically all exceptions, but it's considered good practice to catch and handle individual exceptions, and then you can add this in as a last resort if you forget a certain type of exception that you want to catch. So a common thing that people will write when they use exception E is something went wrong. But it's better to address and handle specific exceptions though. So as a last resort, we'll just add catch exception E at the very end in case there's anything that we do not anticipate. There is one more type of block. It's called a finally block. A finally block will always execute whether or not we catch an exception. So let's add that at the very end. Finally, and then a set of curly braces. So just to test this, let's print a simple message such as this will always print, and then I'll show you some uses later. So let's take this seriously for once. Enter a whole number to divide, 5 divided by 1, and we get the result, and we still execute whatever is within the finally block. Now this time, let's try and cause an exception. Enter a whole number to divide, 5 divided by the number pizza. We encountered and handled an exception, and we still executed whatever is within the finally block. Now, a good use of the finally block is to close any open scanners or files that might be open. So let's type in the name of the scanner, .close. But we'll need to move the scanner outside of the try block because our finally block does not recognize it. There we go. All right, so the finally block is a good thing to add to close any scanners or files that might be open. That's all what an exception is. It's an event that occurs during the execution of a program that disrupts the normal flow of instructions. Any code that is considered dangerous, you can surround with a try block. We can try this code. If we encounter any exceptions, we have catch blocks that can catch specific exceptions, or basically all exceptions, and handle them. And then lastly, you can add a finally block if there's any open scanners or files that you want to close, or if there's anything else you want to do before you move on with the rest of the program. So that's the basics of exceptions in Java. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's an introduction to exceptions in Java. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about the file class in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Welcome back, guys and gals. In this video, we're going to be discussing the file class. Now, a file is an abstract representation of file and directory path names. What we'll be doing in this video is detecting to see if we have a certain file someplace within our computer. So here's an example. Here's my desktop. Please excuse the mess. I'm going to create a new text file on my desktop. So I'm going to go to File, New, Text Document. I'll call this secret_message. And I'm going to copy and paste this text document within my project folder. So I'm going to click on my project folder and paste it. So now within my project folder, I have a txt file called secret message. What I'm going to do is just detect to see if I have a file called secretmessage.txt within my project folder to begin with. So we need to create a file object using the file class, but we'll need this import at the top too. So let's create a file object. File equals new file. And within the constructor of this file object, we're going to list the file that we're going to associate with this file object. So I'm going to list the name of this file. So within quotes, this title is secret_message.txt. Be sure to include the file extension if it has one. So in order to check to see if a file exists or not, there is a method to do so. So within an if statement, we're going to write file.exists. So if our file exists, if there is a match, we will execute this if statement, and let's just write a message. That file exists. Surprise face. Else, that file won't exist. So within an else statement, we'll display that file doesn't exist. Frowny face. All right, let's try this. And it states that file exists. So what if I don't have the file extension? Right now, we're just looking for a plain file that says secret message, and it states that file doesn't exist. So be sure to include the file extension if it has one. So what if I removed this file? So I'm going to delete it, and let's run this again. And it states that that file doesn't exist. So with the file constructor of our file object, when we list a file name, we're going to begin looking within our project folder as the initial directory. But what if a file is located someplace else within our computer and not necessarily within the same project folder? What we're instead going to do is list the full file path within the constructor, plus the file name too. Well, here we are again back in my desktop, so I would like to see or detect if my secret message is on my desktop, but I need to get the full file path. So I'm going to right click on my file, go to properties, and then copy this location. So this is the file path. Within the file constructor, I'm going to paste my file location plus the name of the file that I'm looking for. So if you have backslashes, make sure to include double backslashes because that's an escape sequence. On the other hand, forward slashes would work too. So just to demonstrate, let's switch these to 1/ each. Kind of like that. All right, so let's run this again. If I have this file name at this file location, it's going to state that file exists or it doesn't exist if it's not there. And it states that file exists. So remember, if your file is within your project folder, you only need the file name. If it's anyplace else, you'll want to list the file path. So let's cover a few other useful methods of the file class. But for now, I'm going to move my secret message back into my project folder. And with the file path, I'm just going to list the file name. So it states that this file exists. Let's cover the getPath method. So I'm going to write this within a print line statement, file.getPath. So the path is whatever you have listed within the constructor of the file class. So this is just going to display that secretmessage.txt. Now, if you want the location of where this file is within your computer, that is the absolute path, and there is a separate function for that, file.getAbsolutePath. And this file of mine here is at this location within my computer. This is the full file path. The isFile method will return true or false depending if your file is in fact a file. So let's use the file.isFile method. So if this file is a file, it's going to return true, which it is. If you select a folder, well, this is going to be false then. So that's one way in which you can verify if a file is in fact a file and not a folder. We can also delete a file too. File.delete. So this is actually going to delete my file within my project folder, or I can set a file path if I would like to delete a file that's someplace else within my computer. So this is going to delete this file after running it. So I'm going to run this program. Well, what the heck? It appears that this file is still within my project folder even though I called the delete function. Well, that's because we need to refresh this. So I'm going to right click and click refresh, or you can type F5. So you can see that that file is no longer there. And if we were to run this program one more time, well, our file no longer exists, and it states that file doesn't exist. So those are just a few relevant methods. There's still way more methods out there, and you can always take a look through a few of these too. But I thought those are some of the more useful and pertinent ones to you. So that's everything you need to know to get started using files in Java. If you would like a copy of all of this code, I will post all of this in the comments down below. But yeah, that's how the file class works in Java. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can use file writers in Java to write to a file. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Well, welcome back ladies and gentlemen. In this video I'm going to teach you guys how we can write to a file in Java. So we're going to use a class called the file writer class to help us with this. So let's create an instance of our file writer class. File writer, let's just call this writer for short, equals new file writer. And then within the constructor of this file writer, we're going to list the file path or the file name. So let's just have this appear within our project folder. So I'm going to come up with a name for this file. Let's write a poem, so I'm going to call this poem.txt. So we'll need a few imports. Let's include those at the top. All right, now with file writers, we'll need to add try and catch blocks. So we're going to surround our file writer with a try block, and we'll also have a catch block as well. So this just auto-generated, that'll be just fine. Now, in order to write to this file writer object, we're going to use a particular method, and that is the write method. And this will take a string. So let's write maybe the first line of a poem, like roses are red. Now, the last thing that we should do is close this file writer. So at the end, writer.close. And let's test this. So I'm going to refresh my project folder by pressing F5, and here's my poem, and it says roses are red. Now, if you need to add a new line to this, be sure to use the new line escape sequence, that is \n. So let's add a few more lines to this. So let's add violets are blue, new line, booty, 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 new line, rockin' everywhere. And let's test this. So this is going to overwrite what you have currently. So now we have 4 lines to this file that we have. You can also append some text as well using the append method. Writer.append. And this will add a string or some characters at the end of your file. So maybe I'll write new line, then within parentheses, a poem by bro. And that should be good. So this will append and add some text to the end of our poem. Let's try it. Roses are red, violets are blue, booty, 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 rockin' everywhere, a poem by bro. So really that's all there is to a file writer. You create an instance of a file writer. You can use the write function, the append function. Just be sure to close the writer when you're done with it. So that's the basics of file writers in Java. If you would like a copy of this code, I will post this in the comments down below. But yeah, that's the basics of file writers in Java. Hey, how's it going everybody? It's your bro, hope you're doing well. And in this video, I'm going to teach you guys how we can use the file reader class to read the contents of a file. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Okay, guys and gals, let's discuss the file reader class. The file reader class allows us to read the contents of a file as a stream of characters, one by one, and when we use the read method, it's going to return an integer value which contains the byte value of whatever character we're currently reading, and we can easily cast that as a character value. So let's create an instance of the file reader class. File reader, let's call this reader for short, equals new file reader. And we're going to need an import as well, so let's include that. Import java.io.fileReader. Within the constructor of the file reader, we're going to list the file name or the file path. I'm going to create a text file called art.txt. I'm going to read and display some ASCII art today, and we'll also need to surround this with a try and catch block because this is considered dangerous code. My next step is that I need to create a txt file called art. What I'm going to do, just to make this easy, is create this on my desktop and then copy and paste it over to my project folder. So this is going to be called art, and just to verify the details, I'm going to go to properties, take a look at the name, art, and it's a txt file, so we should be good. So I'm going to paste some ASCII art from the internet. If you don't want to do so, you can just write some lines of text for this example, maybe a poem. Roses are red, violets are blue. But instead, I want to have some fun with this and find some art to use. This looks like a decent website to get some ASCII art. ASCII, art, archive, find a piece that you like. I'm going to copy this one, paste it within my file, and then save it. Then I'm going to take this file and paste it within my project folder. Our next step is to use the read method of our file reader to read the first character of our file. This is going to return an integer value which contains the byte value of that first character. So we can store this integer value within a variable. So let's create an integer variable called maybe data. Int data equals reader.read. All right, we'll need an additional clause to our try and catch blocks. So we would like to handle any IO exceptions that happen. Then we should be good. So we're going to read the first character within our file, but we would like to continue reading. But if our read method returns -1, that means there is no more data to be read. That is the end of the file. So we would like to continue reading as long as our read method does not return -1. What we would like to do is continue reading this file as long as the value returned does not equal -1. And we can accomplish that with a while loop. While our data does not equal -1. If it is -1, that means there is no more data to be read. So let's print to the console window our data, but we'll need to cast this as a character value. So make sure you use print and not print line, because if you do, it's going to print a new line after each individual character. And then we would like to read the next character, so let's copy what we have here and paste it. Data equals reader.read. And then lastly, outside of the while loop, let's close our reader. So reader.close. And then when we run this, it will display the contents of our file, the ASCII art that I posted, or if you have something else, it will display that. So that's the basics of the file reader class. If you would like a copy of this code, I will post all of this in the comments down below. But yeah, that's the basics of the file reader class in Java. Hey, how's it going, everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can create an audio player in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. For this project, we're going to be using the package javax.sound.sampled. However, this is not compatible with MP3 files, but it is compatible with WAV files. So make sure that you have a WAV file that you want to use. I'll direct you to a resource to get some audio files. If you need a sample audio file, I would recommend YouTube's audio library, and you can do a quick Google search to find this and click the first link, and then you can search for any song or sound effect that you need, and to download a song, just click this download button. And then once you have your song downloaded, it's probably going to be an MP3 file. Look up a WAV file converter and click any one of these links, and then you can begin the process of converting your MP3 file to a WAV audio file. Once you have downloaded your WAV file, I would recommend copying it, go to your project folder, and then paste it. So within my project folder, I now have this WAV audio file called Level Up. With that out of the way, we can begin. Our first step is to include this import at the top, import javax.sound.sampled, and we will import everything related to this package. Our next step is to create a file. File equals new file, parentheses, semicolon. Within the constructor of my file, I'm going to list my file name and or the file path. Since my WAV file is within my project folder, I only have to list the file name, and the name of my WAV file is level_up.wav. So be sure to include the extension at the end too if you have one. So I'm going to include some imports as we go along. Our next step is to create an audio input stream. Audio input stream, I will call this audio stream for short, equals audio system dot get audio input stream, and place your file as an argument to this method. Now we will either need to surround this with a try and catch block or add a throws declaration. Just to make this more readable, I'm going to add a throws declaration. We also need to create a clip object. Clip equals audio system dot get clip. And then we need to open this clip by using the open method of our clip. Clip.open. And we are going to pass in our audio stream as an argument to the open method of our clip. And also add a throws declaration or surround with a try and catch block. And we should be good. Now we are going to use the start method to begin playing this audio file. So clip.start. And let's run this. And nothing appears to be playing, and our program terminated. Well, what gives, bro? You're a liar. Hold on, wait a second. So with our audio clip, it's actually attempting to play in a background thread, and our program does not wait around for background threads. So as soon as it runs out of code, it's going to terminate, which you can see here. What we need to do is somehow keep our program open and running so it doesn't terminate. There's one of a few ways we can do this. One, we could create some sort of GUI system, and as long as we don't hit that X in the corner at the top, it will continue to play our clip. Or we could create a scanner that will wait around for some user input, so the program will not terminate. Just for simplicity, let's create a scanner. Scanner equals new scanner, system.in. Be sure to include this import at the top as well. So I'm going to wait around for some user input, so this should pause our program while our program is waiting for us to type in something. And let's save the response that we have into a variable called response. String response equals scanner.next. Since our program is going to wait around for some user input, it's not going to terminate. Let's try it. Since we now have a clip created, it's just a matter of calling the appropriate method for this clip. We have start, we have stop, we can reset, we can also quit too. So let's create a sort of audio player within our console window. So I'm going to move our start method and move it near the bottom. What we'll do is create a while loop that will ask for a response. And depending on the response, we can play, we can stop, we can reset, or we can quit. So let's create a while loop. While our response equals, let's say uppercase Q, but we should use the not logical operator. while our response does not equal Q. And for good measure, we should use the toUpperCase method to make all responses uppercase, because somebody might type in something that's lowercase. Response equals response dot toUpperCase. All right, and then let's create a prompt. Let's say P equals play and S equals stop, R equals reset, and Q equals quit. Then within a maybe print statement, enter your choice. And then we will accept a response. Actually, we should move all this within the while loop. And we are going to declare our string outside of the while loop. String response equals, and we'll just set this to a blank set of quotes. Response equals scanner.next, response equals response toUpperCase. And now our next step is that we should create a switch. Switch, we will examine our response and look for a matching case. Our first case will be P for play. Case P, what are we going to do? We should use the start method of our clip. And we will break. All right, and then we should also have a default as well. Default system.out.println, not a valid response. So let's test the P command that we have. Enter your choice, and you have noticed that our audio clip is not actually playing yet until I type P or lowercase p and hit enter. And you can click this red button to terminate as well. So let's create a stop method, a case for stopping. Case, capital S, clip dot stop. And then break. Let's test this too. So I'm going to press P to play, hit enter, and then S to stop. We can also reset as well. Let's make a case for that. Case R for reset. This one's a little different. Clip dot set microsecond position. So we can set our clip at a certain position at a amount of milliseconds. If we want to reset this clip, we will set this to 0. That is the beginning. And then break. And now we should be able to reset our audio clip. So I'm going to press P to play. And then I'm just going to reset a bunch of times. And then stop. And lastly, we should create a case to quit and exit out of our while loop. We should probably close our clip as well. Case Q, and to close a clip, clip dot close. And break. And we should be able to quit. Going to press P to play, and Q to quit. Actually, let's add a print line too, just to verify that we actually did escape the while loop. Bye. All right, let's run this one last time. So we can play. We can stop. We can reset. We can play again. And we can quit. Bye. All right, everybody, so that's one way in which you can play an audio clip in Java. If you would like a copy of all this code, I will post all of this in the comments down below. Feel free to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro here. Hope you're doing well. This is my new and improved Java Swing tutorial series, and in this video I'm going to teach you guys how we can create a simple JFrame that we can later add components to. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay everybody, so let's create a JFrame. So a JFrame is a GUI window to add components to. We're not going to be adding any components in this video, but in the next video we're going to cover labels. So to begin, let's create an instance of a JFrame. So JFrame, let's call this frame, equals new JFrame. So this creates a frame for us, an instance of a frame. However, we'll need an import, so we'll add that at the top. Import javax.swing.jframe. So if we were to run this, it's actually not visible, so we need to set the visibility to true. So we'll add that at the end. Frame.setVisible, and we're going to set this to true. So this will make frame visible. So we can actually see it now. However, it is very small, so let's increase the size. So we can do that by saying the name of the frame dot set size. So we can pass in a dimension or a width and a height, and this is in integers. So let's say this frame will be 420 by 420 because 420 is a funny number. So this sets the X dimension and Y dimension of our frame. And this should be visible now. Here's our JFrame. Let's set some other things. Let's change the title. So we can do that by saying frame.setTitle. And we can set this to a string. I'll call this JFrame title goes here. And this will display at the top. So set this to whatever you want your title for your window to be. So this sets title of frame. Now pay attention to this. So when we hit this X button in the corner, it's going to actually hide our frame, but not actually close out of the program. So if you want to close out of the program and exit, we're going to change a setting. We're going to use frame.setDefaultClose operation, and we're going to set this to jFrame.ExitOnClose. So when we hit that X button, it's going to exit out of application. And by default, it's normally hide on close. So it appears that we killed the application, but it's still running in the background. Otherwise, there is do nothing on close, and you can actually prevent somebody from hitting the X button to close out of the frame, which is actually kind of annoying, but that's how you can do that. But let's set this back to exit on close because we want to exit out of the application when we hit that X button. Now, another thing that we can do is that we can resize our window. So we can actually prevent that. So we're going to say frame.set resizable false. So what this will do is prevent frame from being resized. So we can no longer resize this even if we tried. We can no longer make this full screen either with the maximize button. So here's something else for you guys. How do we change the icon for the top left of our frame window? Normally it's the Java logo, but we can actually change that to something that suits our program better. So I'm actually going to use the logo for my channel and change the icon from the Java logo to my logo. So if you want, feel free to pause the video and download an image that you might want to use. Here's my logo. I'm going to change the icon of my frame to this logo instead of the default Java logo. So what I'm going to do is copy this, go to my project folder, and then paste it. So then we're going to create an image icon out of this. So image, then icon. Let's call this image just image equals new image icon. And then we're going to list either the file path or the file name. Since this is within my project folder, I only have to list the file name. So this file name is logo.png, logo.png. And then we're going to need another import. So javax.swing.imageIcon at the top. So this will create an image icon. And now what we're going to do is set the image icon of the frame. So we'll say frame.setIconImage. And within the parentheses of this method here, we're going to say image.getImage. So this will change icon of frame. So then, if we tried this, our image is now at the top left of our frame in place of the Java logo that was there by default. Pretty cool, huh? Now let's change the background color of our frame. So what we're going to do is that we're going to say frame.getContentPane. We're going to have to do a little bit of method chaining, followed by .setBackground, and then you can place a color within here. So there's a few basic colors, such as color dot, let's say green. And then we're going to need an import as well, so make sure to include this at the top, java.awt.color. So this will change color of background. So now this window should be green. However, you might not like some of the default colors. You can create a custom color too. So within the set background method, we're going to say new color, and we have a few options. We can place some RGB values here or a hexadecimal color value. So let's begin with some RGB values. So all zeros, this is black. So the background is now black, and this is on a range from 0 to 255. With 255 for all three values is just white. So the first value is the amount of red. And you can see it says bright red as you can make it, really. The second value is green. So that's 255. And remember, this is on a range of 0 to 255. And the last one is blue. So you can adjust the amount of red, green, and blue that you want. So I'm just going to make up some random numbers. 123, 50, 250. I have no idea what color this is. So, oh, I actually really like that. That's like a Twitch purple, so to say. I think I'm keeping that, actually. I'm going to remember this number. 123, 50, 250. All right, you can also place a hexadecimal value here. So you say 0x, and then it's a series of 6 values. So all zeros would be black. Otherwise, all F's would be white. And if you don't believe me, I'll prove you wrong. So you can always go to Google and look up hexadecimal color values, and you can pick a color that you want. So 1, 2, 3, 4, 5, 6 would be this shade of blue, which is actually pretty sweet. Otherwise, you can really pick any color you want and put that here. And the last thing that I got for you guys today in this video is that there are two, I would say, different ways in which you can create a frame. The first is just to create an instance of a frame and give it a name, and then you can change all of the members and properties of this frame by just saying the name of the frame, dot, and then whatever change you want to make. The other way is that you can use a JFrame as a parent class to a child class. So I'll show you how to do that because I do this quite often in this tutorial series. So what we're going to do is actually create another class that's going to be a child class of JFrame. So go to your source folder, then go to File, New, Class, and I'll call this My Frame. So My Frame extends JFrame. This is the subclass or child class, and JFrame is the parent class, also known as the superclass. Then we're going to need this import at the top as well. So the other way in which we can create a JFrame, I'm actually going to copy this, turn all of this into a comment because we won't really need it right now. And then I'm going to create a constructor for my frame. So this constructor is going to be called when we create an instance of my frame. And I'm going to paste everything within here. However, we're going to replace the name of our frame and take out that line as well. So instead of saying frame.setTitle, we're actually going to replace the word frame with the word this. So an easy way that you can make these changes is go to Edit, find Replace, and we're going to replace frame with this and replace all. So replace the word frame or whatever else you called your frame at this point with this. And we're going to create an instance of the myFrame class. So we'll do that here. So we're going to say myFrame instead of JFrame. And let's call this myFrame equals new myFrame. And this will do the exact same thing as all of this code, where it creates basically a duplicate of the frame we had. So you don't necessarily need to create a name for this instance if you don't plan on using this name for anything. So one thing that we can also do is take out this portion of the code if we don't really plan on using the name or a name for your myFrame. You can just say new myFrame, and this works as well. However, if you need to make some changes within this class to your myFrame, you might have to actually create a name for it. All right, so that's the basics of frames in Java. If you'd like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how you can create a frame in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create some labels in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, people, so let's discuss labels. A label is a GUI component. It functions like a display area for a string of text, an image, or even both. So before we begin, we'll need a frame so we can add a label to the frame because a label is a component. So we'll need to be sure to create a frame. I'm just going to paste what I have here from the last lesson. So jframe frame equals new frame, frame.setDefaultClose operation, jframe exit on close, set a size, I just picked 500 by 500, and frame.setVisible to true. And then we'll just need this import as well. So how do we create a label? Well, that's a good question. It's very similar to what we did with our jframe. So instead of saying jframe frame equals new frame, we can instead say jlabel. We can call this label equals new jlabel. We can set some string of text, an image, or both. But we'll need an import as well, so let's include that. I'm just going to be adding imports as we go along. So let's set the text for the label. So we can do that using the label.setText function, and then we can set some text. So maybe I'll say, bro, do you even code? So there's two different ways that you can set text for a label. You can either use the setText method. Otherwise, what you could do, let's say that we delete this. When you create an instance of your label, you can just pass in some text like this. But I'll just do this on a different line for now, just for teaching purposes. So what this will do is set text of label. And this will create a label. So now what we need to do is actually add the label to the frame. And this is a very easy step to forget about. So we'll type in frame.add, and what do we want to add? So you can see that it's suggesting a component. We're going to add our label, and then we're going to compile this and run this. So here's our string of text. Bro, do you even code? So normally with our label, with how our layout manager is for our frame, it's using a border layout. So it likes to take strings or images and it likes to center it and put it on the left-hand side, but we'll change that later. So let's begin next by creating an image icon so we can add an image to this label. So let's create an image icon, and I have a picture that I want to use. I call it dude.png. So I would like to add this image to my label as well as my text. So I'm going to create a name for this image. I'll just call it image. Image icon image equals new image icon. And then we can put a file path here or a file name if it's within the same folder. So this is in the same project folder as my Java file here. So this is dude.png. And then we'll need an import for this too. So then we're going to set the icon for this label. So label.set icon. And you can see that it's asking for an icon. Luckily, our image is an icon. So we'll put image here and then run this again. So here's our image. Well, it's an image icon and our text. Now let's take a closer examination of our label. With Java's Swing graphical user interface, it likes to take a string of text and put it on the right-hand side of your image when creating a label. So we can actually move the string of text around relative to the image. This is how we can do that. There's two functions to help us with that. That is set horizontal text position and set vertical text position. Let's begin by setting the horizontal text position. So we're going to take label.set horizontal text position, and we can pass in a constant. So there's three options that we can use really to help us with this. They are jlabel.left, center, or right. Let's say that I want to put this in the center. That would be jlabel.center. So now when we run this, our text is going to be overlapping our image. So by default, horizontal text position will put the text on the right. So if you want this centered, you would use jlabel.center. Otherwise, you can use jlabel.left if you want this on the left. So the options for this would be set text left, center, or right of image icon. So then let's set the vertical text position. So that is label.set vertical text position. And we have top, center, or bottom. So let's set this to jlabel.top. And then our text is going to be to the center and above our image. So this will set text top, center, or bottom of image icon. Okay guys, let's get a little crazy. Let's change the font color as well as the font styling of the string of text of our label. So let's begin with the font color, and we can use the label.setForeground method to do that for us. We can pass in a color, and there's a few constants that you can use. So let's say that we want green. We can say color.green. Alternatively, what you could do, if you want a more customized color, is that you can pass in a new color, and you can set the RGB values, or you can set a hex value here. So if you're using hex color values, if you want green, that would be 0x00FF00. So now the font color of our text is now green. What if you want to change the font styling? Well, there is a method that will do that for you. So that is label.setFont, and we can pass in a new font, kind of like what we did with our new color. So let's create a new font. We can set the type of font that we want. So one of my personal favorites is MV Bully, but use whatever font that you personally want. And we can set the styling if it's plain, bold, underline, italic. So there's a few constants for this. So font dot, and you can pick one of these. I'll just set this to plain. And then you can set a size. So I will pick 20. So then after compiling and running this, the font is now changed for the text of our label. So this will set font of text, and this will set font color of text. Here's another useful method. There is a set icon text gap where you can adjust how far away your text is from your image. So let's try that. So label.set icon text gap, and we place an integer number within here. So if I set this to, let's say 100, there is going to be a fairly large gap between our text and our image. You can also set this to a negative number and you can pull things in closer. So if I set this to -25, now our text is very close to our image. So this will set gap of text to image. Now let's change the background color. So we're going to use the label.setBackgroundColor method, and we can pass in a color. I'm just going to use a constant this time. So let's say black. Color.black. Like that. All right, so this will set the background color. However, let's take a look to see what happens. So the color does not really necessarily change. There is another method that we have to follow this up with, and that is the label.setOpaque method, and we're going to set this to true. So if true, the component, our label, paints every pixel within its bounds. So basically, to display the background color, you need to set opaque to true. So this will display background color. So now this should be black. So our label is not just this little section. The label likes to take up as much room as possible. Even if we were to expand this window, the label is going to expand as well. Later on, I'll show you a few ways that we can limit the size of this label if you want to place this label specifically somewhere within your frame. But for now, there's a few different methods where we can move the contents of the label around. So right now, this entire area is the label because the label likes to take up as much room as possible. Even if we were to resize this, the entire thing is our label, and I'll prove it to you by setting the border color. So first we'll actually need a border. So I'm going to create a border right after we create our image icon. So we'll type in border equals border factory. I misspelled factory, let me fix that. Border factory dot create, and there's a few borders that you can pick from. I'm just going to pick a simple line border, and we can set this to a color. So maybe color dot green. And then you can set a border width. So I will pick 3. 3 sounds good. So then we'll probably need an import too. So import border.border, I guess. All right, so then let's set the border for this label. So label.setBorder, and we're going to use the border that we created. It's just called border. So then after running this, the border of our label is now green. So it's not just this little area with our text and our image. The label likes to take up as much room as possible, and you can see that with the border. So one trick that you have available to you is that you can move the text as well as the image around within the label. So by default, it likes to be in the center vertically and to the left horizontally. So we can change where this text and this image is placed within the label. So we can move this to maybe the right side, maybe to the top, to the bottom, one of the corners. This is how we can do that. So we're going to use label.setVertical alignment if we want to change the vertical positioning within the label. So we'll set a constant, JLabel, and we can pick either top, center, or bottom. So right now it's center. So let's try moving this to the top. So now this is in the top left of our label, the text as well as the image. But I think I'll keep this in the center because I want this to be in the middle. So this will set vertical position of icon plus text within label. And then we can do the same thing with set horizontal alignment. So label.set horizontal alignment. And it's either, let's see, left, center, or right. So I'm just going to set this to center. So label.center. So now this text and image will always stay in the center of our label, even if we were to resize this frame. So this will set horizontal position of icon plus text within label. Now you're probably thinking that it's kind of stupid that the label is taking up the entire frame. Well, that's because of the default layout manager that we're using. So one thing that we can do, at least until we get to the lesson on layout managers, is that we can set the layout manager that we're using to null, and then we can manually set the size and the placement of this label so it won't really take up the entire frame that we have. So let's take our frame, not the label, frame dot set layout, and for the layout manager that we're going to use, normally with the default it's border layout. Let's set this to null. And then when we run this, it doesn't display anything. Well, that's because now we have to set the bounds for the label. So we're going to set where we want this label placed, the X coordinates as well as the Y coordinates, and the dimensions of this label. So let's add label dot set bounds. So we have to pass in a value for X, Y, the width, and the height. So for X, let's say 0, Y is 0 for the width. Let's make this 250, and the height 250 as well. And then let's take a look at this. So you can see that with our label, it places the top left corner of our label where we set the X and Y positioning to. So 0, 0 is the top left of our frame, and it also set a size for our label, so 250 by 250. If we were to change the size of our label, let's say 350 by 350, well, this label is going to expand in size. However, it still likes to stick to the top left corner because we set the coordinates to be 0, 0. So let's change the coordinates as well, but I will change this back to maybe 250 by 250. And then let's say X is now 100. So now the positioning for this label will move on the X-axis to the right by 100 pixels. And if I set Y to maybe 100, well, then this is going to be also pushed down by 100 pixels. And then if we were to resize our frame, this is actually going to stay in the same place. So use what works for you, what you want for your program. So this will set X and Y position within frame as well as dimensions. Now, I have one last trick for you guys that you might find very useful, and that is the use of the pack functions of frames. So to demonstrate this, I need to get rid of our set bounds method that we have for our label. I'll just turn this into a comment, and the same thing with frame.setLayout. We'll just use the default layout manager that we have, and the method is called frame.pack. It's the pack method of frames. So what this does is that this will resize the size of the frame to accommodate all of the components that you have. So after running this, actually we don't even really necessarily need a size for the frame. The size of the frame will adjust to fit all of the components that you have, and then you can resize this if you want to. Otherwise, you can use set resizable false if you don't want people to resize this. So if we were to actually expand the size of the components within the label, such as the text size, so let's say that I want this to be 50, well, the size of the frame, since we're using the pack method, is going to adjust to accommodate the size of whatever's within the label. So that's something that you might find useful, but however you might like to use the set bounds method or the default layout manager, it depends on what you want for your program, but you have options. Oh, and I forgot to mention this, if you're going to use the pack method, make sure that you add all of your components before using pack. Otherwise, this doesn't work, so I'll prove it to you. So we're going to pack and then add our label. So you can see that it doesn't work, we just get this little tiny box. So make sure that you add all the components and then pack. Well, that's the basics of creating labels in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create labels. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys about panels in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright people, let's discuss jpanels. It's a GUI component that functions as a container to hold other components, and you can add a jpanel to a frame, and it will sort of section off areas of your frame. So let's create a frame. So I'm just going to paste this just to save a little bit of time. So jframe frame equals new frame. Be sure to include any necessary imports. Frame.set default close operation, jframe exit on close. We're going to be using no layout manager, at least until we get to the video discussing layout managers. So frame.set layout null, because we're manually going to place all of the components that we have. Frame.set size 750 by 750 and frame.set visible true. Now to create a jpanel, it's very similar to creating a jframe. So we say jpanel, let's call this panel equals new jpanel. And let's change the background color and be sure to include any necessary imports. So we'll say panel.set background and let's pass in a color. So color, let's make this red. Actually, since we're going to be creating a few different panels, let's instead call this maybe red panel. Then we'll have a maybe blue panel and a green panel. So be sure to change that here as well. Then we're going to set the bounds. Since we're using no layout manager, we have to manually place the coordinates and the width and the height of this panel. So red panel dot set bounds. So we need X and Y for where this panel is going to be placed, as well as the width and the height. So for the X position, let's put this where X is 0, where Y is 0. So this is going to be in the top left corner of the frame. And for the width, let's make this 250 by 250, so it's a square. And then lastly, this is very easy to forget about. We need to add this panel to the frame. So let's do that at the end. Frame.add, what are we adding? We're adding a component. Our jpanel is a component. Let's add that. Red panel. And let's run this. So this is our frame, and this is our panel. We can add components to the panel just like what we can do with our frame. So let's create a few other panels to create different sections for this frame. Like this is one section, we can create a different section to hold other components. And then we can add components kind of like what we did with our frame. So let's create maybe a blue panel this time. So I'm going to copy this, change red to blue, and make sure to change it here as well. So blue panel and blue panel, and we'll change the color to blue. And let's place this where X is 250, Y is 0, and we'll keep the dimensions the same. And we need to add this panel to the frame. So frame.add blue panel. So now we should have a blue panel next to our red panel, which we do. And let's create one more panel, maybe a larger one that's green, that will take up this section of our frame. So let's call this green panel. So let's change blue to green. So green, 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 and here as well. So we'll place this where X is 0, Y is 250, and let's make this 500 by 250. And then we need to add this to the frame. So frame.add green panel. And then this should give us a nice square that's made up of separate jpanels. Cool. Yeah, so those are jpanels. Let's add a component. So let's make a label. So let's do this at the top. JLabel, label equals new JLabel. And I'll set some text as well. So label.set text. Hi. And you can add an icon too if you want. I'll do that just for this demonstration. We'll need to create an image icon. So image icon, icon equals new image icon. And this file that I have is thumbsup.png, and it looks like this. So this is thumbsup.png. And include this import, but I misspelled image. All right, then label.set icon. All right, now with this label, we can add this to either the frame or we can add this to a panel. So let's add this to one of the panels. Let's say the red panel. So let's add that here. So instead of saying frame.add label, we're going to say the panel that we want to add this to, because these panels function like containers. So let's add this to the red panel. So red panel.add label. And this should appear in our red panel, which it does. Let's instead add this to a different panel, like the blue panel. And now this label is contained within the blue panel. And let's try it for the green panel. And now this label appears in the green panel. And you can also move this label around within the container too. However, these panels, they use something called a flow layout manager. And in the last video on labels, the frames that we use have a border layout. All you really need to know about flow layouts right now is that with components that you add to a container that's using a flow layout manager, it will take all these components, stick them to the top, and center them, and it will add components until this first row is filled. Once that row is filled, it's going to add components to the second row. But for now, we don't really know how that works. That's a video for a different day. Let's just set the layout for our panel to a border layout just because we're comfortable with that. And then later I'll demonstrate using no layout manager and how we can place this label. So let's set the layout for our green panel, and we're kind of comfortable with border layouts now and moving labels within a frame that's using a border layout. So green panel dot set layout, and then we can pass in a new border layout. So this is the same layout that our JFrame uses. And if we're using the border layout, it's going to place any components to the center vertically and to the left horizontally. And then we can use set vertical and set horizontal alignment for this label to move this label around within the container. And then later we'll set no layout manager so we can place coordinates if you prefer to do it that way. So let's set the vertical and horizontal alignment for this label. So we'll do that at the top, label.set vertical alignment, and this takes a constant, J label, and let's move this to the top. So then our label will move as far as it can to the top vertically, and it gets stuck at the top of this container because, well, it's a container. It doesn't like to allow components outside of the container. And if we were to set this to bottom, take a wild guess, it's going to move to the bottom of the container. And then let's also set the horizontal alignment because we can. So label.set horizontal alignment, and we can pick left, center, or right. Let's pick the right this time. So J label dot right. And our label will stick to the bottom and to the right of the container that it's in. Now, what if we switch this label to a different panel, like the red panel? First, we'll just want to change the layout that we're using. So let's change the red panel layout to a new border layout. And then we're going to add our label to the red panel this time. So let's take a guess as to where this label is going to move to. It's going to move to the bottom right corner of the red panel. And if we switch this to blue, and I'm just going to copy this because we'll want to set this to a border layout. So blue panel and blue panel.add label. Now this is within the bottom right of the blue panel. So what if you don't want to use a layout manager? Well, this is what we can do. We're going to set null for the layout for each of these panels. So let's change this to null for all 3 panels. And let's take a look to see what changes were made. All right, so we need to set the bounds for this label now. So let's do that here. Label.set bounds. We're going to place X coordinate, a Y coordinate, a width, and a height. So let's say we want this in the top left corner. That is where X is 0 and Y is 0. Let's say for the width, this will be 75, and for the height, 75 as well. Now, we added our label to the blue panel. So it's going to be in the top left corner of the blue panel and not necessarily the top left corner of our frame, because with set bounds, it's going to place your component at these coordinates relative to the container that it's in. Since this label is within the blue panel is acting as the container and not necessarily the frame. So if we were to move this label to a different panel, it's going to be within a new container. So let's say we want to add this label to the green panel. So now this label is going to be in the top left of our green panel, and you can do the same thing with red too. And then if we were to move the X position and Y position of this label, let's say 100 and 100. And now this label is moved down on the Y-axis by 100 pixels and on the X-axis to the right by 100 pixels relative to the corner of the container that it's within, this green panel, and not necessarily the frame itself. So we don't really need this set vertical alignment and set horizontal alignment if you're using no layout manager. This is something you'll want to use if you're using a border layout. All right, everybody, so that's the basics of panels. It's basically a GUI component that functions as a container to hold other components. So you can add components to a panel, and then you can add the panel to a frame. So that's the basics of panels. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of panels in Java. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a simple button in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. All right, my fellow human beings, let's discuss JButtons. A JButton is a Java GUI button that performs an action when you click on it. We're going to be creating a frame and then adding a button to that frame. However, with this frame, it's going to implement something called the Action Listener interface. So I think it would be best to demonstrate this with a different class instead of using our main class with the main method. So let's create a different class. So file, new, class. I will call this myFrame, and we'll have myFrame extends JFrame. So myFrame extends JFrame. MyFrame will be the subclass of JFrame, so it will inherit everything from the JFrame class and behave exactly like a JFrame. So let's create an instance of myFrame. So myFrame, let's call this frame equals new myFrame. And actually, we don't really need to give this a name because I don't think we're going to be doing anything else within this class. You can even just shorten that line to just new myFrame, and that'll work just fine. We're going to spend a majority of the time within this myFrame class. So to begin, we'll need a constructor for this class, so myFrame. And to create a frame, we say this, well, to set up the frame, I should say, we'll need these few lines of code. Instead of saying like frame.set default close operation, it's just this. So this dot set default close operation, JFrame exit on close. We're going to be using no layout manager, so this dot set layout to null, this dot set size, 500 by 500 is decent, and this dot set visible to true. So this should display a JFrame now. All right, so let's create a button at this point. So it's very similar to creating any other component. So that's JButton. Let's call this button equals new JButton. and then we will need an import too. And then let's set the bounds for this button. So button dot set bounds. So we have x, y, width, and height. I will place this maybe where x is 200, where y is 100. For the width, let's make this 100, and the height maybe 50. So then to actually display the button, we need to add this to our frame. So this dot add, what are we adding? We're adding our button. And let's run this. So here's our button. It currently doesn't do anything. So we need our class to implement the action listener interface. So implements action listener. So we're going to need to implement a method, the action performed method. So this frame will now listen for events. So one thing we can do, we can check to see if the event that occurs is our button. So we do that with if e.getSource is equal to our button. Then what are we going to do? All right, you can see one problem here though. This button is not global. It's only local within the constructor of myFrame. So we can actually turn this into a global component. So what we need to do is actually declare this outside of the constructor, because right now, since we declared this within the constructor, only anything within the constructor has access to this. So we'll say jButton button, and we'll finish instantiating this button within the constructor. And you can see that this error went away. So now what do we want to do when we click on this button? Let's just do a system.out.println, and I will print out the word poo. All right, so then when we click on this button, it performs an action. So if the action performed is equal to the button, it's going to do this. The button is going to poo. However, this button doesn't seem to be doing anything. That's because we need to add an action listener directly to the button. So button.add action listener, and we can pass in this. Since this class is implementing the action listener interface, so now this should do something. And now when we click on the button starts printing the word poo. Now is the perfect opportunity for me to introduce something called a lambda expression. It's actually a shortcut that you can use in place of action listeners. So this is an advanced shortcut. I do have an entire video dedicated to this that you might want to watch at some point. So what we can do, instead of implementing the action listener interface, and instead of using the action performed method, when we add an action listener to this button, we can place a lambda expression here. And this is how to write one. We write E within the parentheses, followed by an arrow, and then what we want this button or other component to do. So let's just system.out.println the word poo again, because we can. So poo. And when we run this, it does the exact same thing, just with less syntax. However, this is a more advanced concept. I do have an entire video dedicated to lambda expressions if you're interested. Let's customize this button. Well, because we can. Because we can is actually a great reason for many things. So let's set the text for this button. So button.set text. And then I will write, I'm a button. There's our text. So if you look at the text for the button, there's this annoying border around the text. We can actually get rid of that. We need to set focusable false because the button is focusable. So button.set focusable, and we're going to set this to false. So that should get rid of that box that's around the text of the button. Let's also increase the size of this button too. So I think I will make this 250 by 100. That should be decent. And let's move this over a little bit. I'll try and at least get this close to centering this. All right, let's add an icon too. So we'll need to create an icon. So this is an image icon. I'll call this icon equals new image icon. We're going to list the source for this. So I have a picture on my desktop I want to use. It's just a pointer finger basically. So this is point.png. And then we'll need to import as well. All right, so button.set icon. And we're setting this to the name of our icon, which is coincidentally icon. Now I want the icon on the right-hand side of the text. So there's a method for that. So what we're gonna do is button.set horizontal text position. So j button dot, let's say center. I'm also going to change the vertical text position. So button dot set vertical text position, and this will be j button dot, let's say bottom. So the pointer finger should be in the center and above our text. Let's also change the font too. So button dot set font, and we can pass in a new font. New font. I will pick maybe Comic Sans. Then you can style this. You can make this bold, plain, italic, whatever. I'll make this bold. And then a size. All right, let's take a look. All right, not too bad. I'm gonna pull the text in a little bit closer, and there's a method to do that. So button.set icon text gap. And I'm going to set this to a negative number to pull the text in closer. Negative 15 should do it. Not too bad, not too bad. Let's also change the font color. So button.set foreground, and I will pick maybe cyan. All right. Let's change the background color now of the button. So button.set background, and I will just pick maybe like light gray or something. Light gray. Okay, let's add a border. So button.set border, and we can actually pass in a new border too. So border factory dot create, and then pick a border that you want. I will pick etched border. And let's take a look. So there we go, it kind of has like a 3D effect. Oh, you can also disable a button too. There's a method for that. So button.set enabled, and set this to false. This will disable a button. And actually, if you want a button to be only clickable once and then it's disabled, you can put this within the action performed method. So if we were to do this, we could only click this button once and then it's disabled. So that's something that's an option to you. A feature that's available to you with buttons is that you can change components within a frame on a button click. Let's say that we want to display a label on our frame after we click a button. So let's create a label, and we'll add this label to our frame. So we should declare this label outside of the constructor so that the action performed method has access to it. So j label, we'll call this label, and we'll finish instantiating this within the constructor. So now label equals new j label. And I'll create an image icon. So I plan on using this image, and I'm just going to add this to our label to demonstrate this. So let's create a new image icon, image icon, I'll call this icon 2 because just the word icon is already taken, equals new image icon. And this file name is face.png. Now we can set the icon for this label, so label.set icon, and the icon that I want to use is icon2. Let's also set the bounds for this label, so label.set bounds. So I will place this where x is 150, where y is 250. The width will be 150, and the same thing with the height. So we can also set the visibility for this label, so label.set visible, and I'm going to set this to false because I do not want this to appear, at least right away. And then lastly, we need to add this label to the frame, so don't forget about doing that. So this dot add label. And then with the action performed method, after we click this button, let's set the visibility of the label to true. So label dot set visible true. So then when we run this and we click the button, our label is now visible. Well, that's how to create a simple button in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of buttons. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how border layout managers work in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Let's discuss border layouts. A border layout is used within a container to place components in one of 5 major areas. They are north, south, west, east, and center. So here's some code that I've written for an example. You don't need to copy this. We'll get to this later. I have created 5 separate panels, and I gave them all a unique color. I have attached one of these panels to one of the borders. So panel 1 is attached to the north, then panel 2 to the west, east, south, and then center. Let's see what this looks like. So lo and behold, this is a border layout. The center panel will expand in size proportionately to the size of the frame. The top and bottom borders, they will expand horizontally, but not vertically when you resize this frame. And with the west and the east borders, they will expand vertically, but not horizontally when you expand this frame. Here's some uses of a border layout. You can use the north border for some sort of title. You can use the west or the east border for some sort of sidebar or navigation bar. You can use the south border for some sort of footer for your program. And the center border, you can use this for the, I would say, main part or main body of your program. So let's recreate what we witnessed step by step. So first we'll need a JFrame. So JFrame frame equals new JFrame. Frame dot set default close operation JFrame dot exit on close. Let's set a size. So frame dot set size. I'll make this 500 by 500. And frame dot set visible and set this to true. Let's create some panels. So JPanel, we'll call this panel 1 equals new JPanel. And we'll create the other panels as well. So 2, 3, 4, 5. Let's give them all a color. So let's begin with panel 1. Panel 1 dot set background, and this was red, so color dot red. Let's do the same for the others. So we have panel 2, 3, 4, 5. The second panel, this was green, but you can pick whatever colors you want. Doesn't matter. 3 was yellow. 4 was magenta, and 5 was blue. And before we add these panels to our frame, we need to set up the frame with a border layout. So this is normally the default layout manager, but you'll need to do this for other layout managers though. So to change the layout manager, you type in the name of the container, in this case it's our frame, .set layout, and then you pass in a new layout manager. So if we want to set up a container with a border layout, we type in new border layout. So for our frame, this isn't going to do anything, but if you're doing this with a panel or other container, you would need to set this up with a new border layout. And lastly, we just need to add these panels to our frame. So frame.add, what are we adding? We're adding a component, our panel. So let's add panel 1. And then to set a component to one of the borders, when you add this component, you add a comma, and then type in border layout dot and then the direction. So we can set this to north if we want this attached to the top. So now at the top of this program, we have a red bar, our red panel. This will expand horizontally, but not vertically. And we can actually change the dimensions on this. So this is panel 1. Changing the width won't do anything, but we can change the height though for this. So if we set this to 50, you can see it has half the height now, but the width still expands to accommodate the size of the frame. Let's add the other panels. So it's the same process as before. Frame.add, let's add panel 2, and panel 2 we'll put on the west. So border layout.west. And then we have this green sidebar that you saw previously. So this will expand vertically, but not horizontally. And we can even change the dimensions for this. So this time I'm going to change the width to 50 and the height will stay the same because it doesn't really matter. So now the width of this panel is cut in half because we changed this from 100 to 50. And let's finish by adding the others. So panel 3, this will be on the east. So border layout.east. Here's our east panel, and then we have south. So this will be panel 4, border layout.south. And then of course center. So panel 5, border layout.center. Just like this. So one option available to you is that you can add margins between these components. This is how we can do that. So when we set a container, our frame, with a new border layout, when we pass in a new border layout, we can actually send in some margins for the width and margins for the height. So let's say that we want 10 pixels of margin for the width and 0 for the height. This is what this might look like. So with the west and the east panels, they have 10 pixels worth of margin. Now let's do that with the height this time. So now we'll have 10 pixels of margin for the width and the height between all these panels. So now all of these components are now separated by 10 pixels worth of margin. So if you need to add margin between components, you can just pass them in when you create a new border layout. Here's an advanced trick that you can do. With these panels, they can also act as a container with their own layout manager, and they use something called a flow layout manager by default. So let's say that we want to add some panels within our center panel, kind of like subpanels. This is how we can do that. So I'm just going to copy everything we have just to save time, beginning when we create these instances of our panels to when we set the size for the panels. So I'm just going to add a comment that these are sub panels. So it's the same process as before really, but let's call these panels 6, 7, 8, 9, and 10. And we're going to change the colors for these as well, so make sure to change the name. Okay, so with panel 6, let's say that this is black. panel 7 will be dark gray. Panel 8 will just be gray. Panel 9 will be light gray. And panel 10 will just be white. So we need to set panel 5 with a new border layout, because with our frame, we added a new border layout to this, but now panel 5 is also acting as our container, so we can set this with its own unique layout manager. So with panel 5, set this to a new border layout. Then we need to set a preferred size for each of these panels. So that's 6, 7, 8, 9, and 10. And let's say that these are all going to be 50 by 50. I'm just going to copy this a bunch of times to save time. 7, 8, 9, 10. All right, now we can add these subpanels to panel 5, which is the center panel. So it's the same process that we did with our frame. So instead of saying frame, panel 5 is going to act as the container. So panel 5 dot add, let's add panel 6. So panel 6, comma, then if we want to add this to the north border, we type in border layout dot north. And this is what this currently looks like. So we have a panel within another panel, and let's add the others. So panel 5 dot add panel 7. But make sure you change this to a different border. So let's change that to the south. There we go. So panel 5 dot add panel 8. Let's add this to the west. Here it is. Panel 5 dot add panel 9. This will go on the east. And then lastly, we have the center panel. So that's panel 5 dot add panel 10. Border layout dot center. And there it is. I don't really see the point of this, but I just wanted to let you know that you can do stuff like this. So that's the basics of using border layouts in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how border layouts work in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how the Flow Layout Manager works in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Well, the Flow layout, it places components in a row sized at their preferred size. If the horizontal space in the container is too small, then the Flow layout class uses the next available row. So we'll need a frame. I'm just going to paste what I had previously. So jframe frame equals new jframe. Frame.set default close operation, jframe exit on close, set your preferred size, and then frame.set visible true. To set up a frame or other container class with a flow layout, we use a certain function called set layout, and then we pass in a new layout manager. So new flow layout. So by default, frames use a border layout. So this time we're setting this with a flow layout. Now we'll need to add some components to this frame to demonstrate the effects of a flow layout. So let's create some buttons. So J button, we'll call this button 1 equals new J button. All right, so I'm going to show you guys a shortcut too for creating components. So let's say that we're adding this button to the frame. So frame.add, then we say button 1, right? One shortcut that we can do just to save time is that instead of calling this by name, we can just say new J button and pass this in to the frame when we add this. And then we can give this like a number if we wanted to. So this will create a new J button for us. All right, so one problem that you might run into is that sometimes these components don't always display if you set the visibility to true before you actually add the components. So actually, if we were to move this window, this button appears. So I'm just going to set the visibility at the very end so we don't run into any problems. So then this should display right away. There it is. All right, let's create a bunch of buttons to demonstrate this. So I'm going to copy this line of code where we create a new J button and add this to the frame, maybe like 9 times or so. So we'll call this button 2, 3, 4, 5, 6, 7, 8, 9. All right, so we should have 9 buttons now, and they're all centered within the top row. So with flow layouts, if they run out of room within their first row, the components will be pushed down to the next row, kind of like this. Pretty sweet, right? So it's kind of like a waterfall or something. It's flowing like water. So we can also set an alignment for these components. So when you pass in a new flow layout, you can type in flow layout dot, and if you want this to start on the left, you can say leading, and there's a few options here. So now what these components do is that they stick to the left-hand side, they're leading, and if you were to expand this frame, they will stay in the top left corner. And then when you compress this frame, they will be pushed down. So the default is actually center. So we should see no change with what we had previously, where they will all stay in the center. And there's also trailing as well, so let's switch this to trailing. And now they will stick to the right-hand side, and if you were to compress this frame, they will be pushed down. You can also set the horizontal and vertical gaps between the components too. So I'm going to change this back to center. To set some spacing, you pass in some integers when you actually create a new flow layout. So the first number is the horizontal spacing, and the second number is the vertical spacing. So if we set these both to 0, these buttons are going to be touching, which they are. So let's set the vertical spacing to 10. So now we have 10 pixels worth of space around the components. And then let's set the horizontal spacing to also 10. So now we have extra spacing between these components. With layout managers, you can also add layout managers to panels. So let's create a panel and add all of these buttons to our panel, then add the panel to the frame. So we'll need to create a panel and set this up with a flow layout manager. So let's create a panel, jPanel. We'll call this panel equals new jPanel. Then let's set a size for this panel as well. So panel.set preferred size. We need to pass in the dimensions by saying new dimension. Let's say this is 250 by 250. And let's set the background color so we can better see this. Panel.set background. Let's say light gray. So color.light gray. All right, so then with these buttons, we're going to be adding these to the panel in place of the frame. So one shortcut that you can do if you're using the Eclipse IDE, select all of the code that you want to edit. If you want to replace a certain word, you can go to Edit, find Replace. I'm going to replace the word frame with panel, and then replace all. All right, so we're going to be adding these buttons to the panel. However, we still need to set the layout manager for the panel because I forgot to do that. So panel.set layout, and then we are passing in a new flow layout. New flow layout. And actually, by default, panels already use a flow layout, but I'm just doing this again for teaching purposes. So this panel has a flow layout, and we're adding all of the buttons to the panel this time. And then we need to add the panel to the frame. So frame.add panel. So this is what this looks like now. This panel is acting as the container, and since these buttons ran out of room within the first row, the next set of buttons got pushed down to the next row. And if we were to change the width of this panel, it's going to push the buttons down even further, down further rows. So let's set the width to now 100. So these buttons are pushed down even further because this panel is using a flow layout, just like what the frame was using in the previous example. So that's the basics of the Flow Layout Manager. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the Flow Layout Manager in Java. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys all about grid layouts in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's discuss the Grid Layout Manager. So this places components in a grid of cells in a number of rows and columns, with each component taking all of the available space within its cell, and each cell is the same size. So to begin, we'll need a frame. We're going to add buttons to our frame. The frame is going to have a grid layout. So to create a frame, like always, we just say JFrame, we give it a name like frame equals new JFrame, frame.set default close operation, JFrame exit on close, give it a size, the size doesn't matter, and frame.set visible to true. So let's create a whole bunch of buttons. I don't know how many, maybe 9. So to create a button, we just type in JButton. We can give this a name like button1 equals new JButton. And then when we instantiate this, we can set some text to the button. So let's just pass in 1. And then we can add this button to the frame. So frame.add button1. So there's a shortcut you can do that we learned in the last video on Flow Layout Managers. This will still work, but just to save time, I'm going to shorten the lines of code that we have to write. So instead of creating a button with a name, we can create an anonymous button. So all we need to pass in when we add this component to the frame is instead a new JButton, and then you can set the text right away too. The other way works just fine. That just requires more lines of code, but do what you prefer. I'm just shortening this to save some time for us. So we're going to add a bunch of buttons to the frame to demonstrate a grid layout. So I'm going to create 9 separate buttons. All of them will be numbered. And once you have a whole bunch of buttons, it doesn't matter how many, we're ready to move on. With frames, by default, they use a border layout manager. So the components like to take up as much room as possible. So with this button, this number 9 button, it's taking up the entire frame and all the other buttons are hidden underneath. So we need to change the layout manager that we're using for the containing class, which is our frame. So frame.setLayout, and we're going to pass in a layout manager. Which layout manager? A new grid layout. Well, because that's what we're learning about. And when we run this, all of these components, all of these buttons are all arranged in one row and one column for each component that we have. But we can specify the amount of rows and columns that we want for this grid. We could say the first number is the amount of rows, and the second number is the amount of columns. So here we have 9 rows and 1 column. So they will all be stacked vertically like this, and then they will expand to fit the size of the frame, but all of the components will also stay the same size as each other. Let's say we want 3 rows and 3 columns. This is what this might look like. So we have 3 rows and 3 columns, and later on in this series we do create a calculator program as well as a game of tic-tac-toe, so a grid layout works perfect for those programs. Now when we create our instance of a grid layout, we can also add some arguments for the horizontal margins and vertical margins between these components. So let's add 2 more arguments, and we'll just set them to 0 for now. So this third position is the horizontal spacing between components, and the fourth one is the vertical spacing. So if I were to set this third argument to 10, we're going to have 10 pixels worth of margin between these components, between each column. And this fourth argument is the vertical margin. So if you combine these both together, you have 10 pixels worth of margin around all of the components. Now what happens if you have an uneven amount of components that you add to a grid layout? So we have 3 by 3, so that works perfect for 9 components. Let's say that we add 1 more. We're going to add a 10th button. Like that. So what happens now is that this will actually create a new column for us. So we have 3 rows and 4 columns. and it tries to make this as evenly balanced as possible. So that's the basics of grid layout managers. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of grid layouts in Java. Hey, how's it going, everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys all about J-layered panes in Java, so you can do cool stuff like this, such as stack components on a GUI frame. So let's get into it. Before you reach the end of this video, make sure to like, comment, and subscribe so that we together can challenge and defeat the mighty YouTube algorithm. Hey everyone, I'm going to be teaching you guys about the J-layered pane. What this is that this is a swing container that provides a third dimension for positioning components. So think of it like the depth or the z-index. So this is very similar to a J panel, except we can also specify different layers on the J-layered pane. We can have components be stacked on top of one another or underneath. So let's begin by creating an instance of the J-layered pane. So what we're going to do here is just type in J-layered pane. We need a name for this pane, so we'll call this just layered pane with a lowercase l equals new J-layered pane. Now we're also going to need a J-frame setup, and we've done this in previous videos, so if you need a J-frame, feel free to pause the video and type all of this in. So make sure that the layout manager is set to null. Now what we're going to do with this layered pane is actually add this to our J-frame, but first we're going to set the bounds for this. So we're going to type in the name of our J-layered pane, dot set bounds. And then I would recommend just picking the same dimensions for your J-frame, or you can pick a different size, but I think for this example we should have it be the same. So I'm going to set this where X is 0 and Y is 0, so this will begin in the top left corner. I want this to be 500 pixels for the width and 500 for the height. Now what we're going to do is actually add this layered pane to our J-frame, and I'll do that right underneath where we instantiate this J-frame. So frame.add layered pane. So now we have a layered pane attached to our J-frame, and now we can add components to our layered pane here. So let's take a look to see what we have so far. Here is our J-frame. It is 500 by 500, and there is an invisible layered pane attached to here. So we'll actually need to add some components so we can see this in action. So we'll need to add some maybe J-labels or some other components to this. I like J-labels, so let's add those. So J-label, and we'll call this label label1 equals new J-label. And we're going to take label 1 and set this to opaque. Set opaque true so we can actually see this. And let's add a background color. So label 1 dot set background, and then we'll place the words color dot red. And since we're not using a layout manager, we're going to set the bounds for this label on our layered pane. So label 1 dot set bounds, and we'll have this label begin where X is 50, Y is 50, and for the dimensions, this will be 200 by 200. All right, so let's do the same thing, and we can just copy these and make maybe 2 more labels. So we'll have label 1, label 2, and label 3, but make sure to change it here as well, so you'll want these also to be their respective labels. So label 2 for this paragraph here, and then label 3 for everything here. Let's change the second label to be maybe green, the third one to maybe blue, and we'll also change the bounds. So I'll have the second one begin where X is 100 and Y is 100, and then for label 3, I'll have this begin where X is 150 and Y is 150. So what we need to do next is actually add all of these labels to our layered pane. So let's do that after we instantiate our layered pane. So we can add that right here. So type in the name of your layered pane, dot add, and the name of the component that you want to add. So let's add label 1, and let's do the same thing for each of these components. So do the same thing for label 2 and label 3. So let's run this and see what we have so far. Now label 1 is our red box, so the first component by default that is added to your layered pane will appear on the top, the next one will be underneath, and so on and so forth with that pattern. So we can actually change the order in which these are stacked on top of each other, and with layered panes, there's actually a name for each layer. Here's a visual. Alright everyone, well here's a visual of all the layers within a J layered pane. So each of these layers actually has a specific name, and you can specify which layer in which you want to add a component, and when these are all stacked on top of each other, it adds some depth to a program, so it appears that visuals are stacked on top of each other. Now you don't have to remember all these names, there's actually a shortcut I'm going to show you guys in just a moment, but let's begin just by adding 2 components to our default layer, and maybe 1 to our drag layer. So let's head back to our program and try that. So with label 1 and label 2, what we're going to do is that if we want to add this to the bottom layer, which is the drag layer, we're going to add the component followed by a comma, then type in J layered pane dot. You can actually pick the layers from here. So the bottom one was default. So let's see if we can find that default layer. So let's copy this and add this to label 2. Then let's take label 3 and add this to the top layer, which was drag. So I have an extra comma there. Let me fix that. Okay, so that was drag layer, which is right here. So when we run this, the blue box is actually going to appear at the top, and the rest are at the bottom. So there's actually a shortcut for this because, let's be honest, we're not going to remember all the different layer names and their order. So what we can do in place of typing J layered pane dot, then pick a layer, what you can do is just add a number, and there's an associated number with each layer. Let's say we want the base layer, that is 0. But we need to do one more thing just besides place a number here. We need to use the wrapper class. So type in integer dot value of, and then place the layer number. So if we want this at the bottom, we can just place layer 0. So just type in number 0. And let's add label 3 on top of that. So we can just copy this and say integer dot value of 1. And then let's place the green box at the very top. So we'll say integer dot value of 2. You could also pick a higher number here as well. So what ends up happening now is that our green box is at the very top. So the higher the number, the higher the placement is when you stack these on top of each other. So that's really the basics of J layered panes. You add components to a J layered pane, specify the layered number or by name, and then add the layered pane to your frame or other container. So if you'd like a copy of all this code, I'll post this in the comments down below. And well, yeah, that's the basics of using J layered panes in Java. Hey, how's it going everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can open a new window using Java Swing. So let's get into it. Before you reach the end of this video, make sure to like, comment, and subscribe so that we together can challenge and defeat the mighty YouTube algorithm. Alright everyone, so we're going to create a new project. So if you're using Eclipse, go to File, New, Java Project. And I'll call this project How to Open a New Window. I know I'm really creative like that. And then click Finish, and we're not going to create a module for this. Now we're going to go to our project, locate the source folder, and we're going to create 3 files. So File, New, Class. I'll call the first one Main, and it's going to hold our main method, so you'll want to be sure to click this checkbox here. Click Finish. Let's go back to our source folder, File, New, Class, and let's call this second file Launch Page. It's going to launch a new window when we click on a button, and then click Finish, and then back to the source folder, File, New, File, New, Class, and we'll call this New Window. This is the window we're trying to open, so New Window, and then click Finish. Alright, now within your main class, this is what we're going to type. We're going to create an instance of our launch page. So we're going to type in the name of the class, launch page, and we'll call this launch page with a lowercase l equals new launch page. And that's it for our main method. In fact, our entire main class here. So we're going to do some things on our launch page here. So the first thing that we're going to want to do is to create our constructor. We'll call this launch page so it matches the class name. And then we're going to declare two objects within our class, but before the constructor, a jframe frame equals new jframe. And I'm thinking what we can do for this project is that this page will only contain a button, and when we click on the button, it'll bring us to a new page. So we'll do something simple like that. Then I'm just going to import these things, so javax.swing. And then let's create a J button to put on this frame. So J button, and we'll call this my button equals new J button. And we can set some text on this button right away. We'll just type in new window. And then we'll need to import this. Okay, let's go to our constructor and add a few things. So let's create the frame first. So frame dot set default close operation, and then within the parentheses, jframe dot exit on close. So this will actually stop when we exit out of it. And then we'll need to set a size for this frame. So frame dot set size. I usually pick 420 by 420. And then we need to set a layout, frame dot set layout. And then I usually type in null because I like to manually place everything. And then we need to set the visibility to true. So frame dot set visible true. Okay, let's create our button and add it to our frame. So we'll do that before our frame within our constructor. So that is called my button. That's the name of our button. My button dot set bounds, and we'll place this where x is 100, and then maybe where y is 160. This will be 200 pixels long and 40 pixels for the height. Then this is normally focusable, so we want to set focusable to false. It's not entirely necessary, but sometimes buttons are highlighted and it's kind of annoying. And then we need to add an action listener. So my button dot add action listener. And then within parentheses, just type in this. Now we'll need this class to implement the action listener interface. So right next to your class name, type in implements action listener. And we'll probably need an import. Okay, so we'll need this import as well. And we need to add unimplemented methods. So this is going to be our action performed method when we click on the button. But first we should make sure that everything is here. So let's see if our button is actually on the panel. Oh, nope, not yet, because we need to add the button to the frame because I forgot. So frame.add my button. Honestly, that's very easy to do, to forget to add something to your frame. Okay, it should be there now. Yeah, we're good. So it currently doesn't do anything. So what we should do is that we're going to create a new instance of our new window class whenever we click on this button. So go to your action performed method. And this is where we're going to type if e.get source parentheses is equal to my button. We're going to trigger an event. So what we'll do is create a new instance of our new window class. So new window, and we'll call this maybe my window equals new window. That's kind of a tongue twister. Maybe I should have named it something different, but hey, it works. Okay, so then when we click on this, it's going to launch an instance of our new window class, but we actually have to work on that class now because it doesn't appear to do anything. So that's pretty much everything for our launch page. There's one more line that we're going to add near the end of this, so we'll be heading back here later. So let's go to our new window class then. So what we're going to do here is create a constructor first. So new window, parentheses, curly braces. And outside of our constructor, we're going to create a JFrame so we can actually see what's going on. So JFrame, and we'll call this frame equals new JFrame, parentheses, semicolon. And let's create a label that'll just say hello so we can see something. So we'll create a J label, and we'll call this label equals new J label. And let's set some text such as hello. Then we're going to do a few things within our constructor, but we need to import a few things. All right, so within our constructor, we're going to create a frame, and honestly, we can just copy this from our launch page. So frame.set default close operation, we need to set the size, a layout, and the visibility. And I'm just gonna copy all this because I'm lazy and paste it right in here near the end. Let's work on our label. So label.set bounds, we'll place this where x is 0, where y is 0. This will be 100 pixels long and a height of 50 pixels. And let's also set the font, just because it's normally like very small. So label.set font, new font, parentheses. So we don't really care for a font type, but if you want a specific font, you can place that here. I'll just set it to the default and put null here. We'll have this be plain, so font.plain, and a size of 25. And we need to import something as well. There we go. And we need to add the label to the frame. So I'll do that here. Frame.add label. Okay, so let's run this. Okay, let's click on the new window button to launch a new window. All right, we got one. One problem though, if we keep on clicking on this button, we'll keep on getting new windows. So we have like a bunch here. So if you only want there to be one window, this is what you can do. So going back to our launch page, so the first line within our action performed method within our if statement, this is what we're going to type. Frame.dispose, parentheses, semicolon. So it's going to basically close out of our frame. So now if we were to run this and we click on the new window button, it's going to get rid of the launch page and open a new window. So to sum up everything, if you want to open a new window, you'll want to create an instance of the class that contains the window that you want to appear. And then you'll want to hook this up to like some sort of event to trigger it. And in my case, it's a button. So when we click the button here, it's going to perform the action performed method and then create an instance of our new window class then. So there's other ways that you can instantiate a new window of this class or whatever else you want to name this, but you usually need some way to actually trigger this being instantiated. But for this example, we just have this hooked up to a button. But yeah, that's the basics of opening a new window in Java. If you want a copy of all this code, I'll post it in the comments down below. And that's one of a few ways to open a new window in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create dialog boxes in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey, I'm going to teach you guys about JOptionPaint. This is a pop-up standard dialog box that prompts the user for a value or informs them of something. Before we begin, we'll need this import at the top, javax.swing.jOptionPaint. There's a few variations of dialog boxes that we can create. Let's begin with a standard message that informs the user of something. So in order to create a dialog box, we need to type in the name of JOptionPaint, which is the name of this class, JOptionPaint. And a simple message is show message dialog. So that's show message dialog. And there's 3 variations of this. They each have different arguments that they accept. So the second one accepts 4 arguments, a parent component, a message, a title, and a message type. For now, we'll just set the parent component to null because we don't have one. A message, this can be any sort of message. So this is what will appear within the dialog box. This is some useless info. You can set a title for this box. I'll just set this to title, and then a message type, and there's a few variations of these. So a plain vanilla message would be J option, make sure you get the capitalization right, J option pane dot plain message. So this is a plain message with no styling whatsoever. And this is what we have. Here's our dialog box. The title is set to title. This is some useless info. Okay, thanks for letting me know. This fourth argument is the message type. So depending on what value we place here, it's going to give our message dialog box a different look and feel. So there's 5 I'm going to show you. This is one of them. I'm just going to copy and paste this 5 times and then give you a demonstration of each. So the first one was a plain message. The second one I'll introduce to you guys is information message. The third is going to be a question message, then a warning message, and then an error message. And then I'll turn these into comments just so that they all don't appear at once. So this is the look and feel for the information message, the second one. So maybe I'll change this to, here is more useless info. All right, so what's different about this one is that there's this icon in the top left corner of this dialog box that just says I, and it says, here's more useless info. Okay, great. So our third dialog box is question message. And I'll change the message here, like we're asking a question. Really? So we have a question mark icon and it says, really? Okay. This fourth one you guys will probably like. This is a warning message. So this is one thing that you might see during like those fake tech support scams where there'll be like a pop-up dialog box that says your computer has a virus. Let's mimic something like that. Your computer has a virus. And this is a warning message. Your computer has a virus. So if you want to be annoying, what you could do is stick this within a while loop. While true, basically do this forever. So this isn't going to go away even if we were to click OK or exit out of this. So your computer has a virus. Okay, I can't seem to click out of this, so it's just going on forever. So that's one annoying thing you can do. That's a cool trick you can show your friends. So let's go over the last one. That is error message. We can let the user know that something went wrong. So that is this last one. I'm going to turn that into a comment for now. So this is joptionpane.error message. Call tech support now or else. Man, they're really getting desperate with these scams. They're starting to threaten people. And this is the error message. It has a red X within what looks like a stop sign. All right, so those are basic message dialog boxes. We can also have the user respond to something, and we can actually ask for a yes, no, or cancel response. So a different dialog box is show confirm dialog. So joptionpane dot show confirm dialog. So it's the same as before. We have a parent component, message, title, and an option type. So for parent component, I'm going to set this to null. Message, we can ask whatever we want. Bro, do you even code? Pick a title. This is my title. And then an option type. So J option pane dot, and we can select what kinds of responses we want available. We can have yes, no, cancel options, just yes, no, or only yes. Let's go with yes, no, cancel. And then we need a semicolon at the end. And this is what we have. Here's our confirmed dialog box. It has our question, bro, do you even code? And there are different buttons you can add to this dialog box. So we added the one with yes, no, and cancel. But currently this doesn't do anything. So let's actually display what this returns using a println statement. So system.out.println, I'm going to take this whole line of code and put this within the println statement. Then I need to get rid of that semicolon. There. All right, so if we were to select yes, this returns 0, no returns 1, cancel returns 2, and then if you click the X button, it returns -1. One technique available to you, you could store this within a variable. Let's say int answer equals jOptionPane.showConfirmDialog. Based on the value that is stored within this variable, you could run this through an if statement or a switch, and depending on the answer or what value is stored within here, you can do one of a few things. So that's how showConfirmDialog works. Next, we have showInputDialog, where the user can actually type in something. So to do that, it is jOptionPane.showInputDialog. And we can simply just put a message within here, like, what is your name? And then we can store the result in a variable like string name equals jOptionPane.showInputDialog. And then I'm going to turn this into a comment and run this. So what is your name? My name is Bro. Okay. And then we can like display this or something. So hello plus name. And let's try that again. What is your name? Bro. Okay. Hello, bro. Okay, people, so the last one I have for you guys today is showOptionDialog. This combines all of them together into one. So that is jOptionPane.showOptionDialog. And there are a ton of arguments within here, but it's okay. We're going to go through these one at a time. So for the parent component, we're going to set this to null. What do we want our message to be? Maybe you are awesome. You can set a title. I'll set this to secret message. You can set an option type. So these are the buttons that you want to add, or the response type for this dialog box. So jOptionPane. You can select whatever you want. I'll just have the standard yes, no, cancel option. Then a message type. That's what we added up here at the top for our message dialog boxes. For now, I'll just set this to perhaps information message. So that is jOptionPane, information, message. We can also add our own icon and our own options for our buttons, but for now, I'll just set these to null, but we'll get into that in just a moment. So null, null, and the initial value is what is initially selected. I'll just set this to 0. And then a semicolon at the end. Okay, let's try this. You are awesome. No, I'll be humbled this time. Okay, so let's actually add our own icon to this. It's going to replace whatever icon we have set for the message type. So I'm going to create an image icon out of this image that I have. It's just called smile.png. So I need to create an image icon. Image icon, I'll call this icon, equals new image icon. I need to set the file path or the file name if it's within the same project folder. So this is smile.png. I'll need an import as well for this. Okay, so I have this image icon just called icon. I'm going to add that to this argument here. It's the third from the last one, so that is icon. And this should override the previous symbol that we have. So now it's using my image in place of the I symbol that we had previously. We can also add our own options for these buttons, but this will take an array of components or reference data types. So let's create an array of strings. So a string, an array of strings. We'll call this responses. What do we want to add to these buttons in place of yes, no, cancel? So maybe for the first option, no, you're awesome. Then for the second option, perhaps, thank you. And for the third option, we'll just maybe blush. All right, so we take this array and we're going to place it in the second to last argument. I think I'm going to add these all on a new line just so we can see everything here, because it's getting very long. All right, we should be good. And this is the value that you initially want to be selected. So if you want the first button selected, set this to 0. If you want the second one, set this to 1. And here is our dialog box. Secret message, you are awesome. No, you're awesome, thank you, or blush. No, you're awesome. All right, so that's the basics of JOptionPane. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of JOptionPane in Java. Hey, what's going on everybody? It's your bro here, hope you're doing well. And in this video, I'm going to teach you guys how we can create a text field in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, everybody, we're going to be creating a JText field. This is a GUI text box component that can be used to add, set, or get some text. So imagine you're logging into a website and you type in your username and password. Well, those boxes are perfect examples of text boxes. We're also going to create a submit button so that when we enter in a username, we can submit whatever text we enter in. But we're going to implement an action listener, so it's best if we create a new class to do this. So within my source folder, I'm going to go to File, New, Class, and I will call this class MyFrame. MyFrame will extends JFrame, so it's going to behave exactly as a JFrame. This will also implements the action listener interface so that this frame can listen for events like a button click when we want to submit a username. So make sure to add all of these imports. And since we're implementing an interface, we need to add any unimplemented methods. So make sure to add public void action performed. We're also going to create a constructor for this class, so MyFrame. And we have to go through the motions of setting up a frame. I'm going to copy and paste this. So you just type in this.set default close operation, JFrame exit on close. We're going to use a flow layout for this example, so make sure you use a flow layout. You can also set this to null if you want, but you have to manually place your components. We're going to pack this frame so that the size of the frame will adjust to fit the components that you add, and then finish this up with this.set visible true. And then we have to create an instance of this frame. So we'll say MyFrame frame equals new MyFrame. Let's head back to our MyFrame class, and we're going to create a JText field. So JText field, we'll call this text field, equals new JText field. And we'll need an import for this. Import JText field. And let's set some dimensions for this text field. So text field dot set preferred size, and we'll pass in a new dimension. Let's say 250 by 40. So 250 for the width and 40 for the height. And we'll need an import for dimension. Now we need to add this text field to our frame. So make sure you add this before you actually pack the frame. So this dot add, we're adding our text field. And we should have a text field now within our frame, which we do. And we can type in text like this. What if we want to submit some text? We'll probably want a button. So let's create a button to the left-hand side of this text field. So J button, we'll call this button equals new J button. And we can set some text right away too. Let's say submit. And we're going to add this button to our frame. So this dot add button. Now you notice we have a submit button, but it currently doesn't do anything. So we need to add an action listener. So let's do that here. Button dot add action listener. Since this class is implementing an action listener interface, we can simply just pass in this. And when this frame detects an event, we can check to see if that event is the button. So if e.getSource is equal to our button, we're going to do something. We're going to take our text field dot get text. Okay, but let's take a look at this. Our button and our text field are not recognized. That's because we declared our button and text field within the constructor, so they're only local to the constructor. We need to declare these outside of the constructor so that they're global. So we'll copy this and paste it. JButton button, that's all we need, as well as JTextField text field. So here we're declaring this twice. We don't need to do that. Since we declared these components outside of the constructor, they are now global so that this action performed method now has access to them. So make sure to take out JButton for the button and JTextField for the text field. And now these should be recognized. All right, so we're going to use this method, getText, to retrieve whatever text is within our text box, our text field. So let's print out a message. I'm going to surround this with a print line statement. So we could say maybe welcome plus whatever the text is that somebody types in. Let's try this. So let's say we enter in our username, brocode, and click submit. It says, welcome brocode. Let's customize the appearance of this text field. Well, because we can. So let's begin by changing the font. So text field dot set font, and we can pass in a new font and pick whatever font you want. I will pick Consolas, and then we can say font.plain or bold or italic. And then we can also pick a font size. So I will pick 35. 35 is a good number. And let's take a look. That's pretty sweet. Let's change the font color. So we do that with set foreground, text field dot set foreground. And we can pass in a color like color.green, or we can pass in some RGB values or a hex value. So we can do that with new color, and I'm just going to use a hex value this time. You can look these up online. That is for green 0x00FF00. So this is a bright green color. Sweet. Let's change the background color. So text field dot set background, and we can pass in like a preset color or a new color. I'm just going to turn this to black. So color dot black. And now we have a black J text field. But you can see that the caret, that's that line that is blinking. It's a little difficult to see. We can actually change the color of that as well. So text field dot set caret, well, set caret color, then we can pass in a color. So I will pick color dot white. And this caret, this line, when you type in something, is now visible. Let's set the text of our text field. So text field dot set text, and we pass in a string. We could place the string username here so that somebody knows to type in their username. So it just says username, but you can edit this and type in whatever you want. Hacker123. If for some reason you need to prevent somebody from editing this text field, you can do so with the set editable method. So we type in the name of the text field, dot set editable, and we can set this to false. So that when set editable is set to false, we can no longer edit this text field, even though I'm trying really hard to do so. Here's an idea. What if we disabled the text field as well as this button after we submit a username? So within this action performed method, we're going to get rid of this line, text field.set editable false, place this within our action performed method, and let's also disable that button as well. So button.set enabled, and we'll set this to false, so that after we submit a username like hacker123 and click submit, we can no longer submit another username. So that's an option that's also available to you. So yeah, that's the basics of creating JText fields in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating a J text field in Java. What's going on, everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create a simple checkbox in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everyone, we're going to be creating a J checkbox. This is a GUI component that can be selected or deselected. So let me give you a rundown of my setup that I have. We covered this in the last video. So we have two classes, a main class. It doesn't really matter what you call it, as long as it contains a main method. We're going to create a new instance of myFrame. So myFrame will extends JFrame, so it behaves exactly like a JFrame, but it also implements an action listener interface. Within the constructor of myFrame, I have this.set default close operation, JFrame exit on close. We're using a flow layout manager. We're going to pack this frame and set the visibility to true. And then we'll also need an action performed method so we can listen for events. All right, once you have all of that, we're ready to begin. This is how to create a J checkbox. So within the constructor, for now, I'm just going to declare a J checkbox. J checkbox. And we will call this checkbox equals new J checkbox. We'll probably need an import, so include that. And then I'm adding this checkbox to the frame. So before we pack this dot add the name of your checkbox. And this is what we have so far. Just a simple selectable checkbox, but we'll probably want to add some text. We don't know what we're selecting exactly. So after we create this checkbox, let's set the text. You can either pass this into the constructor, or we can use the set text method. So checkbox.setText. And we'll place some sample text like, I'm not a robot. Seriously guys, I'm not. And this is what we have now. I'm not a robot. Last time I checked, I wasn't. So there's this annoying border around the text. We can get rid of that. You have to set focusable to false. Checkbox.set focusable false. And that will take care of that issue. So this text is somewhat small and difficult to read. We can actually change the font too. Checkbox.set font. New font, and pass in whatever font you want. You can copy me if you want. So Consolas, font, plain, and then a size. 35 is good, but doesn't matter what you pick. And that's a little bit easier to read. So what can we do with this? Let's create a button, and when we click on this button, it's going to tell us if this is selected or not. So let's create a button before this checkbox. So that's a J button. We'll call this button equals new J button. And we'll need an import as well. And let's set some text. You can either pass this into the constructor, a string, or we can use the set text method. So button.setText. And I will set this to submit. We're also going to need to add an action listener. So button.add action listener. Since we're implementing an action listener interface, we can simply just pass in this. All right, so we have an action listener that's attached to this button. When we click on the button, it's going to trigger this action performed method. So we need to check to see if the event that happens is equal to the button. So if e.getSource is equal to our button. Now let's take a look at this button. This button is not recognized, or this action performed method does not recognize this button. That's because we declared this button within the constructor. So we should make this global by declaring this outside of the constructor, because right now it's only local to everything within our constructor. So I'm going to copy this portion, paste it, and we do not need to declare this twice. So at the top, JButton button, then button equals new JButton. So then our action performed method now recognizes this button. And we'll need to do the same thing with our checkbox. So checkbox equals new checkbox. Now we're going to determine to see if this checkbox is selected. So there's a function to do that, checkbox dot is selected. And this is going to return true or false. For now, I'll just print this. So system.out.println, and we're going to print the result. You can also assign this to a variable too. That would work as well. And let's try this. I'm not a robot. Oh, we need to add the button. Crap. Let's do that. So this dot add button. I sometimes forget to add components. You will too, probably. All right. I'm not a robot. Cool. This says I am not a robot. Now I am a robot. Now I'm not. Now I am. So, did you guys know you can actually change the appearance of this checkbox? We can set this to an image. So I have a few images that I want to use. This picture of an X, I just called this x.png, and a picture of a green check mark. So I want to change the checkbox to these images when the checkbox is deselected or selected. So I'm just going to create some image icons. Feel free to pause the video if you want to look for some icons that you want to use. So image icon, I will call the X icon just X icon. And then we have another image icon, and I will call this check icon. And then I will finish instantiating these within our constructor. Right here is good, I suppose. All right, so X icon equals new image icon, and we list where this is located. Since this is within my project folder, I can just list the name. So that is x.png. And I'll do the same thing for my checkmark icon here. So that is check icon. And the name is checkmark.png. To add an icon to a checkbox, when it's deselected, you type in the name of the checkbox, and we use the .setIcon method, and we pass in an icon that we want to use. We want to use this X icon, which is the red X that we have. And this is our icon. However, if we were to click on this, it doesn't appear to do anything, even though we can toggle this between checked and unchecked, selected or deselected. So we're also going to combine this with set selected icon. So checkbox dot set selected icon, and I'm going to use my check icon. And then now when we run this, we can actually change the image when we select this checkbox. All right, so that's the basics of creating a simple checkbox in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating a checkbox in Java. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys all about radio buttons in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Well, howdy, y'all. We're going to be talking about radio buttons in this video. So, the definition of JRadio buttons is that these are one or more buttons in a grouping in which only one may be selected per group. So let me give you a demonstration of my setup before we actually get into radio buttons. I have two classes, one just called main, it contains my main method, and an instance of my other class, myFrame. So myFrame extends JFrame, it behaves exactly like a JFrame, it also implements an action listener. And within this constructor, I just have this.set default close operation, JFrame exit on close. I'm using a new flow layout, this.pack and this.set visible set to true. And then I also have an action performed method within here. So let's get started by making some JRadio buttons. Here's a scenario for this example. Let's say that I'm buying you lunch because I'm such a nice guy, but you can only pick one item from the menu. You can pick either a slice of pizza, a hamburger, or a hot dog. So we're going to create 3 radio buttons, and you can select one of those choices, and we're going to place all of these within one grouping. So let's begin by creating a radio button for pizza. So to create a radio button, it is JRadio button, and we'll call this radio button the pizza button. J radio button pizza button equals new J radio button. All right, let's do the same thing for a hamburger button and a hot dog button. So J radio button, this will be our hamburger button, and then a hot dog button. So we can set some text. We can either use the set text method, or we can just pass in a string within the constructor. So just for convenience, I'm going to pass in pizza, then hamburger, then hot dog. And then we need to add these buttons to the frame. So this dot add, let's add our pizza button first, followed by hamburger and then hot dog. And this is what we should have. All right, we have pizza, hamburger, and hot dog. But wait a second, we've been bamboozled. We can select all of these items if we wanted. So we can actually limit the choice selection to only one item, but we have to put all of these radio buttons within the same grouping, because right now we can select all of these, and I promised you only one thing for lunch today. So we need to place these within a button group. So let's place this here. We're going to create a new button group, and we'll just call this group equals new button group. And then we need to add these radio buttons to this group. We can do that by typing in the name of the group, dot add, and what are we adding? All of these buttons. So let's add the pizza button, followed by the hamburger button, so group dot add hamburger button, and then the hot dog button. And now we can only select one item. One thing you should know, every time that you select one of these choices, it's actually triggering an event, and we can use our action performed method to detect which button was selected. So within our action performed method, we can place a simple if statement. If e.get source is equal to, let's begin with our pizza button. If somebody selects the pizza button, then they get pizza. So let's do a system.out.println, you ordered pizza. But notice, this action performed method does not recognize our pizza button. That's because we declared our pizza button within the constructor of our myFrame class. So this is a local component. We need to turn this global, so we can do that by just declaring this outside of our constructor. Since we've declared this pizza button outside of the constructor, this action performed method does recognize it now. However, we want to get rid of this portion where we declare this pizza button twice, but we do want to finish instantiating this, and we should do the same thing for our hamburger button as well as our hot dog button. So we're going to declare these, but not yet instantiate them until we're within our constructor. So hamburger button equals new JRadio button, and then we want to declare the hot dog button outside of the constructor, and then instantiate it within the constructor. So then the action performed method can actually recognize all of these components. So if e.getSource is equal to the pizza button, we'll print you ordered pizza. Then we'll do the same thing for our hamburger button and our hot dog button. And let's just use an else if statement to keep this simple. There's more sophisticated ways of doing this, but we're still noobs, so it's okay if we do if statements. So if e.getSource is equal to the hamburger button, I don't feel like typing all this, so I'm going to paste it. Then we will just system.out.println, you ordered a hamburger. And then else if e.getSource is equal to our hot dog button. System.out.println, you ordered a hot dog. And let's run this. Here we have our pizza button, hamburger button, and our hot dog button. But wait a second, we've been bamboozled again, because when we select these, it's not printing out our message. Well, that's because we still need to add an action listener to each of these buttons. So let's work on that next. I'll just add them here. So let's select each of these buttons. So we have our pizza button, and we need to add an action listener. So pizza button.add action listener. Now, since we're implementing an action listener interface, we can simply just pass in this. And then let's do the same thing for our hamburger button and our hot dog button. Now these radio buttons will be able to listen for events, and when we click on one of our radio buttons, we will order our selected item. You ordered a pizza, you ordered a hamburger, and you ordered a hot dog. This is entirely optional, but you can actually change the icons that you're using for these radio buttons. So within my project folder, I have 3 images that I want to use. An emoji of a slice of pizza, a hot dog, and a hamburger. So I'm going to create some image icons out of these, and we're going to set the icon for each of these radio buttons to that image. So if you have a few in mind, let's begin. So let's create a few image icons. So for my first icon, this will be my pizza icon. Then I'll do the same thing for hamburger and hot dog. And then within the constructor, I'll finish instantiating these. So pizza icon equals new image icon. And I'm going to list the file path of where this is located. Since this is within my same project folder, I can just simply list the file name. So my first image is pizza.png. And then hamburger, then hot dog. Alright, so I have all of my image icons set up. Now to add an icon to a button, there is a function to do so. I'll add them here. So type in the name of the button. There it is, pizza button. Dot, you can either set icon or set selected icon. I'm just going to use set icon and list the icon that you want to use. I want to use my pizza icon. So I'll put that here, and then let's do the same for the other buttons. So hamburger button, dot set icon, hamburger icon. And then lastly, hot dog. And now those circles are going to be replaced with our images. And they work just the same. So we have a slice of pizza, a hamburger, and a hot dog. All right, so that's the basics of creating radio buttons in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating radio buttons in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys all about combo boxes in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, all you wonderful people, let's discuss JCombo boxes. This is a GUI component that combines a button or editable field and a drop-down list. We can create a drop-down list and select one of a few different items. So before we begin, here's my setup. I have 2 classes, a main class that contains my main method, and then a myFrame class, which extends JFrame and implements the action listener interface. And then within the main class, I just created an instance of myFrame. So within this myFrame class, I have a constructor, this .setDefaultClose operation, JFrame exit on close. We're using a new flow layout, and we're going to finish this with this .pack and this .setVisible set to true. This is the standard procedure for us that we've been doing for this GUI tutorial series. And then we also have an action performed method that will respond to certain events. Now let's create a jComboBox. I'm going to place that here. So let's first declare this, that is jComboBox, and we will call this ComboBox equals new jComboBox. Now we have our combo box, but we need to populate this combo box with a listing of different options that the user can select. So when we construct this jCombo box, we can pass into the constructor an array of reference data types. These can be objects, or they can be primitive data types, but you have to use the wrapper class. Let's say that we want a drop-down menu of animals, and a user can select one of these. So a string is actually a reference data type, but it has to be an array. So we'll create a string array called animals, and let's fill this array with some animal names. So let's say dog, and then cat, and then maybe bird. So with this array of animals, we can pass this into our constructor when we create our jCombo box. And then lastly, we just need to add this combo box to the frame. So this dot add, and we are adding our combo box. And then when we run this, we have a drop-down menu, a combo box, and we can select one of these items. However, it currently doesn't do anything, so within the action performed method, we need to fill in a few things. And actually, whenever we select one of these items, it's actually triggering an event. So within the action performed method, we will create an if statement if e.getSource is equal to our combo box. Then what we're going to do, well, we can do one of a few things, but first, this action performed method does not recognize our combo box. That's because we declared this combo box within the constructor, so it's local. We need to turn this global by declaring this outside of the constructor. So jComboBox, combo box, and we do not need to declare this twice. Since we're declaring this combo box within the class, everything within the class now recognizes this. So our action performed method now recognizes this combo box. So if our combo box does something, then what we could do is get the current selected item. So let's type in the name of the combo box, combobox.getSelectedItem, and then I'll just print this. So let's put this within a print line statement. So system.out.println. I'm going to copy this and paste it. System.out.println, combobox.getSelectedItem. However, we need to add an action listener to this combo box because it still doesn't return what we want, basically. So we need to add an action listener to this combo box. So let's add that here. combobox.addActionListener. Since this class is implementing the action listener interface, we can just pass in this, and this will work just fine then. So then, whenever we select an item from this jCombo box, it's going to trigger an event and get the current selected item. So let's say we want a dog, well, we have a dog, cat, and then bird. Another method that functions similarly to getSelectedItem is getSelectedIndex. So for now, I'm just going to copy this, and I'm going to turn this into a comment so we can ignore it. And then we're going to use the getSelectedIndex method instead. So combobox.getSelectedIndex. And this will return the index of what we select. So this always begins with index 0. So dog would be 0, it prints 0. Bird would be 2, and then cat would be 1. Here's a few helpful methods that you might find useful for combo boxes, and in order to use these methods, we type in the name of the combo box, and here's a bunch of the different methods available to you. Let's begin with setEditable, and we can set this to true. And what this does is that when we set the editability to true, we can actually type in something to look for. So let's say that I want to select cat. I can just simply type in cat, or I can select it from this drop-down menu and it returns that item that we selected. Let's go over a few others. So we can actually get the item count. So that is combobox.getItemCount. And then we'll need to display this. So let's put this within a printline statement. So system.out.println, combobox.getItemCount. And this prints the current amount of items, which is 3. We can also add an item later. So combo box dot add item. So we need to pass in an object, a reference data type. Let's pass in a string, maybe a horse. So with add item, this will add an item to the end of this. So now we have dog, cat, bird, horse. We can also insert something at a certain index. So combo box dot insert item at. We need an item and an index. Let's say we want pig for the first item at index 0. So let's pass in a string that says pig and then an index 0. So this should be at the beginning now. However, it's not currently selected. See, pig is at the top, but dog was selected. So we can actually set the selected item at a certain index when this runs. So in order to do that, it's combo box dot set selected index, and you pass in an index. So if I were to set this to 0, it's always going to select index 0 when this first runs. So now our item pig is now selected because we have set selected index set to 0, and our item pig is now set to 0. We can also remove an item too. So let's turn these into a comment just to ignore these. So combo box dot remove item. And let's say we want to remove our cat because our cat ran away, but don't worry, he'll come back. So now we only have dog and bird. We can also remove items at a certain index. So combo box dot remove item at. And let's say 0. So whatever item is at index 0, it's going to remove that. So this time our dog ran away. He went to go chase the mailman. So we only have a cat and a bird. And I have one more for you guys. So combo box dot remove all items. And this will clear our combo box so that there is nothing within here. So this could probably be useful for something if you need to reset it. One thing that you should remember is that with these J combo boxes, we need to pass in an array of reference data types. For example, if we attempted to pass in an array of integers, well, since this is a primitive data type, this actually wouldn't work. Let's say we're attempting to store the numbers 1, 2, and 3 and add these to our J combo box. So in order to do something like this, we would have to use the wrapper class version of this. So for integer, it is integer with a capital I and you spell it fully. If this were double instead of lowercase double, this would be capital double because this is the wrapper class version of a double. So just make sure that you're using wrapper classes if you need to store a primitive data type within an array. All right, so that's the basics of combo boxes in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of combo boxes in Java. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys all about J sliders in Java. And at the end of this video, we're going to create a project where we can use a slider to adjust the temperature. So let's get into it. Before you reach the end of this video, make sure to like, comment, and subscribe so that we together can challenge and defeat the mighty YouTube algorithm. Alright everyone, so a JSlider is a GUI component that lets the user enter a value by using an adjustable sliding knob on a track. So to best demonstrate this, let's create another class to keep things organized. So go to your source folder, go to File, New, Class, and let's call this class Slider Demo. Click Finish. And then we're going to go back to our main class and create an instance of this slider demo class. So we're going to type slider demo, and we'll call this slider demo with a lowercase s equals new slider demo, parentheses, semicolon. So let's head to that class and start working here. So we're going to need a few things to import. So make sure you have these three imports, java.awt.*, javax.swing.asterisk, and javax.swing.event.asterisk. Now with this class, we're going to implement the change listener interface. So next to our class definition, we're going to type implements change listener. So then with our slider, we can actually update something whenever we make a change. Now we're going to add an unimplemented method, and it's going to be state changed, but we're going to save that for the very end. First, let's work on our constructor for this slider demo class. So we'll just copy this and paste it, add a set of parentheses and a set of curly braces. Now what we'll do is actually declare a few global objects here. So the first thing is that we'll want a frame, so jFrame, and we'll call this frame. And that's it for now. We'll actually instantiate these within the constructor. We're also going to want a jPanel, so jPanel, and we'll call this panel. We'll need a label, so jLabel, label, and lastly a slider, which is the main piece of this lesson. So to do that, you need to declare a jslider, and we'll call this slider. All right, now going within our constructor here, we're going to instantiate these objects. So the first thing that we'll create is our frame. So frame equals new jFrame, and let's set the text to slider, but spell it right, slider demo. And then we will want to instantiate our panel because we're going to add the panel to the frame. So panel equals new jPanel. We'll instantiate our label. So label equals new jLabel. And then lastly, our slider. So slider equals new jSlider, parentheses, semicolon. Okay, now with the slider, there's a few values that we can add. So with sliders, we can have a spectrum of ranges, and then we can have the user adjust a knob, and then they can enter in a value that way. So the first set of values is the minimum and the maximum set of numbers for our slider. So let's say that we want somebody to adjust a knob on a track between the numbers 0 and 100. So what we'll do for the first number, the minimum, is enter in 0, and then separate it with a comma. Then you can enter in the maximum number. So let's say 100. So maybe we're finding the temperature of maybe water between the temperature of 0 and 100 degrees Celsius. So we're going to set a minimum of 0 and a max of 100. And now there's a third value we can add. This is the starting point for the slider. Let's say we want this to start in the middle. Well, we could say 50 for the starting point. Now, before we get ahead of ourselves, let's add everything to the frame. So first we'll add the slider to the panel, and later we're going to add the panel to the frame. So we'll start with panel.add slider. Then we're also going to add the label to the panel. So panel.add label, and then frame.add panel. And then let's set the size for our frame. So frame.set size, and I like to pick 420 by 420. And then we need to set the frame to be visible. So frame.set visible true. All right, so first let's work on our slider then. So let's set the preferred size for this slider. So we type in the name of the slider, dot, and then we're going to use the set preferred size method. We're going to type in new dimension, and we're going to give a width and a height. So 400 is a decent width. So 400 for the width and 200 for the height's pretty decent, I would say. Let's actually see what we have so far. Okay, yeah, here's our slider then. So it's just a bar that's adjustable. There's no markings or anything, so we need to add that later. All right, now what we're going to do is add paint ticks. So slider.set paint ticks, and within parentheses, we're going to place the word true. So let's see what this looks like now. All right, so we also need to add the tick spacing. So these are little, I want to say, notches that kind of give you an idea of the range of numbers. So what we'll type in here is slider dot set minor tick spacing. So how often do you want a notch in this slider? Let's say every 10 units, every 10 of whatever you're counting by. In our case, it's degrees Celsius. So let's try it now. So these aren't numbered yet, but you can see about every 10, we should have at least like 10 ranges. Starting at 0, then they go all the way up to 100, and there's a little like notch here. Now we're going to set some major tick spacing, so that comes next. So I'm just going to copy this, and we're going to change a few things. So set paint track, and we want this to be true. And the next thing is set major tick space, and let's set this to 25. Okay, now after each 25 units, there's a larger tick. These are major ticks, and the small ones are minor ticks then. And now with the slider, we can actually add values to each of these major ticks. And let me show you how to do that. So I'll add that maybe right here. So what we're going to type is slider.setPaintLabels, and we're going to set this to true. Now we have our numbers for each of our major ticks, but not the minor ticks. And it gives our whole range between 0 and 100. And you can see that when we started this program, it begun like right in the middle at 50 because we set this value, this argument, the third one, to 50. The first one is the minimum, which is 0, and the second value is the maximum, which is 100. So if you adjusted these numbers, it would also adjust the numbers on our slider. Let's also change the font on here too. So maybe I'll do that next. So slider.set font, new font. I really cannot spell today. And maybe I'll give this a font of MV Bully because that's one of my favorite fonts. And then font.plain. We don't need to do any styling. And I will pick a font size of 15. And let's see what this looks like now. Not too bad, not too bad. Looks more modern, I would say. So one trick you can do with this slider bar is that by default this is horizontal, so we could actually change this to a vertical slider bar, and that kind of resembles a thermometer since we're taking the temperature. So in order to change that to vertical then, type the name of the slider, dot, set, orientation. And then within here we're going to type swing constants, and then dot vertical. And let's take a look. Yeah, I would say that would fit a thermometer of sorts. Then if you want to change it back, it's going to be the same process, but change vertical to horizontal. And this is what we had previously, but I think for this demonstration, I'm going to keep it as vertical, but I'll just turn this into a comment just so you have it for your notes. All right, let's add a label. So we'll have a label underneath that will display the current temperature, whatever this is set to. So let's add that right underneath our slider, but before we add everything to our panel and our frame. Now to set the text for the label, type in the name of the label, and we're going to use the set text function, and then we're going to change the text. So I'm going to insert the degree symbol. I actually don't know how to do this normally, so I copied it from Google. Then degrees C equals, and then if we want to retrieve what the current value of the slider is set to, we can add plus slider, and we'll use the get value function of the slider. All right, let's take a look at this now. So it says it's set to 50 degrees Celsius, but I think I'm going to increase the font. So I'm just going to copy this, paste it, and change slider to label. And let's set this to maybe 25, so it's more visible. That's better. Okay, so it's currently set to 50, but if we adjust this, this number doesn't change. So I'll teach you guys how to do that. And we're going to do this within our state changed method. So what we're going to type in here is label.set text. Actually, we can just copy this and paste it. That'd probably be easier. So whenever the state changes for the slider, it's going to execute this line of code and update it. Now, the last thing that we need to do is that we need something to trigger our state changed method. So we need to add a change listener to our slider, and we can just add that here. So type in slider.add change listener, and then within parentheses, type in the word this. So this should work now. Let's try it. Okay, so the midpoint is 50 degrees Celsius, the minimum is 0, which we have here, and the max is 100. And now if we adjusted this slider, this value is also changing whenever we adjust the knob on this track. So it has a minimum of 0 and a max of 100 like we intended, and it's adjusting whenever we actually move the knob on this track then. So that's how JSliders work. It's a GUI component that lets the user enter a value by using an adjustable sliding knob on a track. So if you're looking for extra practice, your assignment is to post the code for a slider that you've made in the comments down below. But yeah, that's one of a few ways you can create a JSlider in Java. Hey, how's it going, everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how JProgress bars work in Java, so let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everybody, we're going to be building a progress bar, and this is defined as a visual aid to let the user know that an operation is processing. So it's usually good practice to let the user know what's going on behind the scenes, if something's processing, you're waiting on something. Otherwise, if there's no sort of visual cue, the user might close out of your application because they think it's frozen. So let's create a progress bar. We're going to create a new class within our project folder. So file, new class. I'll call this progress bar demo, but call it whatever you want. Click finish. Then we're going to create an instance of this within our main class. So we'll type the name of the class, and I'll call this instance just demo equals new progress bar demo. All right, so we're done with this class. Let's go back to our progress bar demo class, and we're going to import a few things. Import java.awt.asterisk and import javax.swing.asterisk. Then let's create the constructor for this class. So we're going to type in the name of the class, followed by a set of parentheses and curly braces. And before the constructor, we're going to declare a few things. So we'll create a JFrame, and we'll call this frame equals new JFrame. And we're going to create a component called a JProgress bar. So JProgress bar, and we'll call this bar for short, equals new JProgress bar. Okay, now within the constructor, let's create the frame so we can add the bar to the frame. So frame dot set default close operation, jframe dot exit on close, and then frame dot set size. Pick whatever size you want, and then I usually set no layout manager, so set layout to null. Only in certain situations I like layout managers. And then we need to take our frame and set the visibility to true. Okay, now we are going to create the JProgress bar. So we're going to set the initial value first. So we're going to type bar.setValue. And if you want to start at 0, type in 0 here. Don't know why you'd want to start at a different number, but hey, maybe you can set this to 100 and count down for something. All right, then we're going to set the bounds because we're using no layout manager. So bar.setBounds, and let's start in the top left corner. So we'll set X to 0, Y to 0, and then we'll need to choose a length for this. So maybe I'll type in 420 to match the size of my frame, and then maybe 50 pixels for the height. And then we need to add this bar to our frame. So we'll type in frame.add bar. And let's see what we got so far going on. Okay, we got a nice little bar here, so that's a good start. So with this progress bar, there is actually a special method. So type in bar, and this method is called set string painted, and then pass in true within here. And what this does is that it adds a percentage to your progress bar, and when you fill the progress bar or set the value, this percentage is going to change. So that's kind of cool. All right, so let's fill this progress bar. So all we really need to do is just take this bar and set the value to something else. That's like the bare minimum, I would say. But I think what we'll do is actually put this within a while loop, and we'll have the value of our progress bar increase by a certain amount every second or so. There's so many different ways that you can create a progress bar. This is just like a basic demonstration. So let's do that within a fill method. So at the end of our constructor, we'll call a fill method, and we're going to declare this. So outside of the constructor, we'll make a public void method called fill. And what we'll do is just set the value whenever we call this. All right, so let's just set this to 10 to begin with. So when we run this, it's immediately set to 10. Now what I think we'll do is actually put this within a while loop, and we'll start at 0. So we'll create a counter. So int counter, set this equal to 0, create a while loop, and within the while loop, what we'll do is that we'll continue this while loop as long as our counter is less than or equal to 100. And we're going to take our bar and set the value to whatever our counter is. So if we want to simulate the progress bar increasing over time, we can use the thread.sleep method here, and we can set this to maybe 1000 milliseconds. So this is going to pause our program for 1 second after each iteration of the while loop. And we're going to need to surround this with a try and catch block. And then let's increase our counter, maybe by 10%. So we can say counter plus equals 10. This is the shorthand for saying counter equals counter plus 10. So let's see what happens now. All right, so it starts at 0, and it's going up by 10% every second. Almost there. All right. I think I'm gonna speed this up a little bit, so maybe I'll change the counter to increment by 1% each time, and change the thread.sleep method to perhaps 50 milliseconds. So it's going to appear to go actually faster this time, and it's increasing by 1% after each iteration of the while loop. All right, we can also add some text on our bar. So maybe we'll set this after the while loop is complete. We'll display a message such as done. So we type in the name of the progress bar, set string, and then you can add some text. So maybe we'll type in done. And that should be good. So let's try it again. And then when it's finished, it says done, but it's a little difficult to see. So let's change the font of the progress bar. So if we want to change the font, we can type in bar.set font. Then within parentheses, we're going to pass in new font, parentheses again. We can pick a font style. I like MV Bully, it's one of my favorite fonts. Then let's set this to bold. So font.bold. And for a size, maybe 25. But bold has to be all capital. I forget about that sometimes. Okay, let's take a look at this now. All right, that's much better. You can actually see it this time. And when it says done, that's actually visible this time, and it's not so small. Let's also change the foreground color. So bar.set foreground. Then within here, we just send in a color. So maybe color dot, maybe red. And let's take a look. And the fill color is now red. Actually, this would be kind of cool for some sort of HP bar for a video game, but you'd probably want to start at maybe 100 and then just progress this downwards. And let's also change the background color. So bar.set background, maybe black. Color dot black. So the background is black and the fill color is red. So another thing, with this jProgress bar, within the constructor, you can pass in a minimum and a maximum value for this progress bar. So maybe we'll set the minimum to 0, and then the max, maybe 500. Actually, you know what? Let's create like some sort of HP bar in a video game. So I think what we'll do is actually count downwards. So we'll change our while loop. We'll continue this as long as counter is greater than or equal to 1 or 0, I guess. Actually, greater than 0 would be better. And then we'll decrease our counter by maybe 1. So that's minus equals 1. All right, so let's try this. Oh, we should probably set our counter to whatever this was, 500. Okay, that kind of appears to be somebody's HP draining like in a video game. That's pretty cool too. But we'll switch back to the example we had previously, so I'm just going to undo all of this. But yeah, you can pass in a minimum and a maximum value to your progress bar. Alright everybody, well that's the basics of jProgress bars, and with this set value method of the jProgress bar, there's so many different things you can do with this. You won't necessarily have your thread asleep for so many milliseconds before updating this. You might link this to some sort of like task. After the task is complete, you can increment this counter by something. There's really no right way or wrong way to do this. This is just like one of a few different ways to demonstrate this concept. So if you want a copy of all this code, I'll post this in the comments down below. But yeah, that's the basics of how jProgress bars work in Java. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create a menu bar in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright people, let's dive into this. So I have two classes, a main class and then a myFrame class. MyFrame extends JFrame, so it behaves exactly like a JFrame. It also implements the action listener interface. And within my main class, I just have a new instance of MyFrame. And within the constructor of MyFrame, I have 4 lines of code. This.set default close operation, JFrame exit on close. This.set size, set this to whatever size you want. I just picked 500 by 500. This.set layout, I'm using a new flow layout. And this.set visible set to true. And then also make sure you have an action performed method. So let's begin. To create a menu bar, we first need to create the menu bar, then we add separate menus or tabs, kind of like what we have at the top here with our IDEs. There's different tabs that you can navigate to, and there are also menu items that you add to each of these tabs, to each of these menus. So let's begin by creating the menu bar to actually be as the container to contain all of these menus and menu items. So let's create a J menu bar, and we will call this menu bar equals new J menu bar. And then instead of adding this to the frame, we set it. So type in the name of the frame you're using. For me, it's just this. So this dot set menu bar. And we place the name of the menu bar within this method. That's set J menu bar, by the way. All right, so let's try this. All right, so nothing is currently visible. That's because we have to add menus to this menu bar, kind of like what we have at the top of our IDEs. So let's create menus for file, edit, and help. So these are J menus. J menu, let's call the first menu file menu equals new J menu. And then you can either set some text or pass this to the constructor. I will just say file. And let's do the same thing for edit and help. So we have an edit menu that says edit, and a help menu that says help. Now with these menus, we add them to the menu bar, we don't set them. So we type in the name of our menu bar, menu bar dot add. Then we're going to add these individual menus. So we're going to add the file menu first, followed by the edit menu, then help menu. So edit menu and then help menu. And now these should be visible. So you can see here, here's our menu bar, and here are the individual tabs or menus. However, if we were to click on these, there's no menu items. So let's add a few items to our file menu. So these are menu items. So let's declare these. Let's say we want a menu for, well, menu item for save, load, and exit. So these are J menu items. And we'll call the first one load item equals new J menu item. And we will set some text either by using the set text method or just pass this into the constructor. So this will be load. Then we'll want a few others for save and exit. So this will be save item, and the text will be save, and exit item, and the text will be exit. So then with these items, we add them to the menu that we want. Let's say we want to add these to the file menu, so we type in the name of our file menu, kind of like what we did with our menu bar. So file menu.add load item. So this is a menu item, and we'll repeat the process for save item and exit item. So save item and exit item. And I'm just going to group these together so it's easier to read. All right, so this is what we got so far. We have our menu bar, we have our menus, they kind of function like tabs. We don't have anything added to help or edit. I don't really think we'll need to, but with file, there's actually a drop-down menu. We can select one of these items to perform some sort of task for us. So let's use our action listener interface to actually have these perform some sort of task for us. So we need to add an action listener to each of these menu items. So let's add them here. So load item dot add action listener. Since we're implementing an action listener interface, we can just pass in this, and we'll repeat this process for the save item and the exit item. So save item and exit item. So now these will respond to clicks if you were to click on them. However, we need to state what we want them to do within the action performed method. So let's just do this with some if statements. So if e.get source is equal to our load item, we will pretend that we're loading a file. So system.out.println I think I mistyped this. There. We'll display a message. Beep, boop, you loaded a file. All right, but within our action performed method, it does not recognize this load item component. So we need to declare these outside of our constructor because right now they are only local. So anything within the constructor, within these sets of curly braces, actually recognize what this is. So let's declare all of these items, all of these components outside of our constructor. So that's J menu bar, and we do not need to declare this twice. I could have done this for the beginning, but I think it's easier to understand if I just declare everything all together, and then we fix this later. So give me one moment to fix these. So that's our edit menu, our help menu, and then we will probably want to declare the items as well outside of the constructor. So we have load item, save item, and exit item. Actually, I think I'm just going to copy all of these and get rid of most of these lines here. There we go. All right, so our action performed method now recognizes this load item component. And let's just create a few other if statements. There's more elegant ways of writing this, but this is something really simple for us beginners. So let's say if e.getSource equals save item, we will display beep boop you saved a file. And then lastly, we have exit item. So it's the same process as before. So exit item. Actually, why don't we have our program actually exit? So in order to do that, it is system.exit, and then you can just pass in 0. All right, so this will now respond to events. So here's our menu bar, each of the menus, and here are the menu items. So if we click load, it's going to pretend that we're loading a file. File, save, you have saved the file, and then exit. Exit will actually work because system.exit will close out of your program. One feature available to us is that we can set keyboard shortcuts for all of the menu items and the menus. So in order to do that, we use the set mnemonic method. So let's add that perhaps here. So let's begin with the different menu items. So we type in the name of the menu item we want to add a mnemonic to. So that is, let's say, load first. So load item dot set mnemonic. It's spelled kind of funky. So set mnemonic, and then we add a key event. So key event dot, and then the key that we want to set for this shortcut. So let's say we want L for load. So that would be VK underscore capital L. So I'll add a comment here. So this is L for load. And let's set a few others for save and exit. So save item, set mnemonic, key event, then S, make sure that's capital S for load. So S for load, and then exit. So that is exit item, key event, how about E? E for exit. Let me fix that. All right, let's try this. So we still need to navigate to the specific menu where these are contained. But if you look at each of these menu items here, they are underlined with their keyboard shortcut. So if I were to type L, it's going to load a file, S to save, and then E to exit. And you can do the same thing for the individual menus as well. So let's set a mnemonic for those. I'm just going to group these together. So we have file menu, edit menu, and then help menu. So let's say FEH to match the file or the different menu names. So that's F, E, and then H. However, for these menus, you need to hold Alt plus whatever key. So that's Alt F for file, and then Alt E for edit, and Alt H for help. Probably change these as well. So Alt F for file, Alt E for edit, and Alt H for help. And let's give this a go. Now I'm not going to use the mouse cursor at all. I'm going to use my mnemonics that I set up. So if I want the help menu, that is Alt H. Edit is Alt E. File is Alt F. And then to select one of the menu items, I don't need to hold Alt. I just select the letter. So you can actually see that they're underlined too. So load is just L. I need to go back to the file if I want to select something else. So that is Alt F. Then S for save. Alt F again to go back to file, and then E for exit. All right, so let's also set some icons for each of these menu items. So I have a few icons that I want to use for load. I just have a folder, save is a floppy disk, and exit is a door because I think that's appropriate. So I'm going to create some image icons, but I'm going to declare these outside of our constructor. So image icon, I will call the first one load icon. And then I want a save icon and exit icon. So this is save icon, and then exit icon. And I'm going to instantiate these within the constructor. So load icon equals new image icon, then the file path or the file name. Since these are within the same project folder, I just have to use the file name. I don't need the full file path. So for load icon, I'm going to use load.png and repeat the process for save and exit. So save icon, save.png, exit icon, and that is exit.png. And then we need to set these icons to the menu items. So let's add them perhaps here. So load item dot set icon. Then we pass in an icon. I'm going to pass in my load icon that I created. And we'll need to repeat the process for the other items. So next we have save item. And this icon is that floppy disk. Save icon. And then exit item dot set icon, exit icon. So now we should have some icons for these menu items. So here we go. We have the 3 icons that I wanted to use. We can load, we can save, and then we can exit. All right, so in the next video, I'm going to show you guys how we can use the jFileChooser class, where we can actually select a file, and you can use this as like a backbone if you want. So that's the basics of, what did we cover again? Menu bars, menus, and menu items. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating a menu bar in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can use the jFileChooser class in Java to select a file someplace within your computer. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright people, let's just get right into this. So we're going to be discussing the jFileChooser class. This is a GUI mechanism that lets a user choose a file. We're only going to be selecting a file today. I have other videos on loading files and saving files. So this is helpful for opening or saving files if you want to look for a file that's someplace within your computer or within your project folder. So let me show you my setup real quick. I have 2 classes, a main class and then a myFrame class. I have a new instance of myFrame within my main class. myFrame extends JFrame, implements the action listener interface. I have a constructor called myFrame. This .set default close operation, JFrame exit on close. I'm using a new flow layout. This .pack and this .set visible to true. Now to launch the jFileChooser, we're probably going to need a button. So let's create a button to do so. So let's say button equals new button. And I'll add some text, maybe select, or better yet, select file. All right. And then I want to add an action listener to this button. So button.add action listener. Since this class is implementing the action listener interface, I can just pass in this, and then we need to add this button to the frame. So this dot add, and we're adding the button. All right. So we need to check if we are clicking this button, then we're going to launch an event. So if e.getSource is equal to our button. However, this action performed method does not recognize this button, so we need to declare this outside of our constructor. So button, and then we do not need to declare this twice. All right, so when we click on our button, and let's just try this real quick. So we have our button and it says select file in the top corner. So we are going to launch a new instance of our jFileChooser class. So in order to do that, we need to first declare it jFileChooser, and we will call this file chooser equals new jFileChooser. All right, so now if we were to run this and we click on select file, it currently doesn't do anything. Well, that's because we didn't set it up to do anything yet. We only declared and created a new instance of file chooser. So the next step is that we are going to either show open dialog or show save dialog. We're not actually going to be opening or saving any files, just getting the location for the file. So let's go with show open dialog, and then I'll show you show save dialog right after. So in order to do that, to open our dialog menu, it is the name of our file chooser right here, dot show either open dialog or save dialog. Let's just go with open. All right. And then if you have a parent component, you place that in here, but we don't have one. So we're just going to put null for now. So what this does is that I'm going to add a comment. This will select file to open. All right. So I currently have a file on my desktop, and this is what this currently looks like. It's going to bring you to your default directory of where you usually open files. And I have a file on my desktop, and it is called Hello World. All right, so you can select a file to open, and there's different files of type where you can search through these, but I'll show you that later. So let's say we want to open this file. Well, where is it? All right, so there's a few other steps. So with FileChooser.showOpenDialog, it's going to return an integer value. Think of it as the response. And I'll actually print this with a println statement. So system.out.println, and I'm going to place this within the println statement. And I just want to show you what this returns exactly. All right, so I'm going to go to my desktop. And then I'm going to attempt to open this file again. So open. Okay, so this returns 0. So that's kind of like the response based on what button we click. If I were to click cancel, it's going to return 1. Or if I click X, it's going to return 1 as well. So we can actually do something with this. Perhaps we can store this within a variable. So I'm going to create an integer variable called response. Int response equals FileChooser.showOpenDialog. And then we can check to see if response is equal to 0. But there's another way of writing this. If response is equal to 0, that's one way. Or what we could do is write jFileChooser.approve option, and that would be better. So if somebody successfully selects a file and does not click cancel or click X button, then we can actually create a new file. We can store that. So let's declare a new file. File equals new file. And the file path for this is going to be file chooser dot get selected file dot get absolute path. All right. And then we'll probably need an import for this file as well. Okay, then let's print the file path for this file. So we can do that with system.out.println, and we're going to place the file name here. So then what happens is that when we select a file, let's say I want to go back to my desktop and select that Hello World file, this is going to get the file path, and currently it's on my desktop. So we don't necessarily need this println statement, but it's just proving that this file actually has a location too. So then I have other videos on loading a file or saving a file using scanners or print writers, but we'll save that for another video. Actually, I think I'm going to keep this println statement just because we have more to do. Okay, now we have show save dialog. Currently with show open dialog, we can select a file to open and we have an open button. Alternatively, we have show save dialog. So that is FileChooser.show save dialog. So I'm going to change open to save, and I'll just turn this first line into a comment because we don't really need it anymore. So this will select file to save. All right, it's the same process as before really, but now we have this save button and we can attempt to save a file, but there's still more steps we have to follow for actually creating a file. I have a separate video on that. So if I wanted to save something to my desktop, this could be test file.txt. Then I'm going to click save. Currently this won't actually create a file, but here it's just printing the file location and it's set to my desktop. All right, so that is show save dialog. Now, one other thing that we could do too is that we can set the current directory, because right now it's just going to the default for my computer, and that is my documents folder, and we can actually change that. So in order to do that, it is FileChooser.set current directory, and we pass in a new file, and we specify the file path within this new file. So one trick, if you want to place this within set the current directory to your project folder, that would be just a dot within quotes. So this is going to go to my project folder. and the project name is GUI swing. So you can see that that changed. Otherwise, I could place a file path here. So if I wanted the current directory by default to be set to my desktop, I would place the file path for my desktop. And for my desktop, this is the address. Now, if I were to run this and select a file, the default directory is now my desktop, and I can attempt to open or save a file here. Well, that's the basics of the jFileChooser class, and in a future video, we're actually going to be creating a text editor app, and we'll need to use the jFileChooser class. So if you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the jFileChooser class in Java. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can use the jColorChooser class in Java to color components, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, let's get started everybody. So we're going to be discussing the jColorChooser class. This is a GUI mechanism that lets a user choose a color. So here's an example of my setup. I have two classes, a class called main that contains my main method, and a new instance of my other class called myFrame. So myFrame extends JFrame and implements the action listener interface. I have a constructor called myFrame. Within the constructor, I have this.setDefaultClose close operation, JFrame exit on close. I'm using a new flow layout, followed by this.pack and this.setVisible to true. I also have an action performed method for when we click on a button, we're going to change either the background color or the font color of a label. So let's declare a button and a label. So let's declare these outside of the constructor so that they're globally available to our action performed method. So we'll create a JButton, let's call this button, as well as a label. So JLabel called label. And then we will finish instantiating these within the constructor. So button equals new JButton, and I'm going to set some text right away just by passing in a string to the constructor of the JButton. I will say pick a color. All right, let's create a label. So that is label equals new JLabel, but this has to be capital. Okay, I'm also going to set the background color. So label.set background, and then we can pick a color, maybe just white. So color.white. So in order to display the background color, we need to set opaque true. So set opaque, and we're going to pass in true. Let's also set some text and the font. So label.set text. This is some text. Good enough. Let's also change the font too, because this is going to be fairly small. So label.set font, and we can pass in a new font. Pick whatever font you want. I will pick one of my favorites, which is MV Bully. You can style this. I'm just going to set this to plain, and then a size. I want something massive like 100. And that's all there is to it. Oh, then we have to add an action listener to this button. So button.add action listener. And I'm going to pass in this because we're implementing the action listener interface. And then we need to add this button and this label to the frame. So this.add, we're going to add the button followed by the label. So this.add label. Then we should be good. All right, so all we have is a button and then some text. This is our label. So when we click on our button, we're going to launch a new instance of our jColorChooser. So if e.getSource is equal to our button, then we're going to declare and instantiate a new color chooser. So in order to do that, we're going to declare jColorChooser, and we will call this instance color chooser, or whatever you want, equals new jColorChooser. So this will create a new instance of our jColorChooser, but we need to create a dialog box. So we can actually assign that to a new color, whatever this returns. So color, we'll call this color, equals jColorChooser dot show dialog. So for the arguments, this takes a parent component, a title, and an initial color. So for the parent component, we're just going to set this to null because we don't have one. We can set a title, so pick a color, I guess. And then an initial color, like what do you want the default to be? So I'll just say color.black. So this will create a dialog for us, and when we run this and click on our button to pick a color, it's going to open this menu, and it has our title, pick a color, I guess. Okay, so we can pick a color, and we can click OK. This has a few other options too. I don't really know what this crap is, but feel free to mess with these settings. So let's say I want this green color, then I click OK. Well, we have this color stored within our color, called color coincidentally. Now, we need to actually change the color of whatever it is we want to color. So let's change the foreground color of our label first. So label.set foreground, that's the font color, and we're going to pass in our color that we select. So now when we run this and we pick a color, let's say I want that green color again, I think it was something like that, and click OK, it's now going to change the foreground color. We can also change the background color too of whatever component that we want. So I'm going to change the background of our label. So label.set background, and we're going to pick that color again. So let's pick, I don't know, pink. And the background is now pink. So you don't necessarily have to do this with labels. You can do this with all sorts of components, but a label is kind of convenient just because you can add text to a label, and you can also change the background color. Well, that's the very basics of the jColorChooser class. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the jColorChooser class in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how the key listener interface works in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay everybody, let's get started. Now within my project folder, I have two classes, one class called main, and it contains an instance of my other class called myFrame. MyFrame extends JFrame, so it behaves exactly like a JFrame. And within the constructor for myFrame, for this class, I have 4 lines of code. This.setDefaultClose close operation, JFrame exit on close. I'm using a size of 500 by 500. This next part's important. I'm using no layout manager. This.setLayout is set to null because we're going to be manually moving components within the frame by using some keystrokes. And lastly, this.setVisible is set to true. One of a few ways in which you can use a key listener interface is just to add that after the class definition. MyFrame extends JFrame, implements the key listener interface. And with interfaces, you need to add any unimplemented methods. And for key listeners, there's currently 3: key typed, key pressed, and key released. And in just a moment, I'll explain the difference between the 3. But we need to add a key listener to this frame. So we can type in the name of the frame, which is just this, add key listener. And since we're implementing a key listener interface, we can simply just pass in this. So this frame will now respond to key events. And we have key typed, key pressed, and key released. And let me explain the difference between these 3. I've added just a few short descriptions underneath each of these methods. Let's begin with key typed. Key typed is invoked when a key is typed. This uses a key char or key character. It gives us a character output depending on the key that is pressed. Key pressed is invoked when a physical key is pressed down. This uses a key code. It gives us an integer number depending on the number of the button that is pressed down. Each button on your keyboard has an associated number, and key code gives us the number of the button. And key released is fairly simple. It's called whenever a button is released. So let's actually display what the difference between a key char and a key code is. So within our key released method, this is going to be called whenever we release a button. So let's actually display some key characters as well as some key codes. So let's begin with some key characters. So let's add a print line that says, you released key character, and we can get the key character of this event by typing e.get key char. And let's try this. So I'm going to press Q, and it says your released key character Q, W-E-R-T-Y, 1, 2, 3, 4, 5. Now you can actually use capital letters, so I'm going to hold down Shift and type in Q, W-E-R-T-Y. So those are key characters. Now key code is the number of the button. You released key code, and this is e.getKeyCode. So each of these buttons has a number. Actually, let me turn this line into a comment for now. So I'm going to type in Q, and the number of the button, of the Q button, is 81. W is 87, E is 69, R is 82, T is 84, and Y is 89. So lowercase q is 81, but uppercase Q is also 81 because I'm holding down the same button. And 16 is Shift, and I just released it, so that's why this was triggered. So let's actually display these together now. So Q, the button that contains the Q symbol, produces a character, a key character of Q, and the button number, the key code, is 81. Now if I were to hold down Shift and then press the same button, this is producing a different key character, capital Q, but the key code is still the same because it's still the same button. So that's the difference between a key character and a key code. And then I'm still holding down Shift. If I were to release it, it's going to give us the key character and the key code. Well, Shift doesn't produce any key characters, that's why it's confused, but it has a certain key code of 16. And what we're going to be doing in this video is creating a simple label, and we'll move the label around the frame by using either key typed or key pressed. So let's declare a label and then define it. So JLabel, and let's call this label. And within the constructor, let's instantiate this label. Label equals new J label. And let's set the bounds for this label. Label.set bounds. We're setting the bounds since we're using no layout manager. Let's say we want this to start in the top left corner of the frame. That is where X is 0, Y is 0. Let's make the width 100 and the height 100. And let's set a background color. Label.set background. Why not red, I guess? And in order to display the background color, we need to label.set opaque and set this to true, because the background color doesn't like to display if you don't set the opacity, set opaque to true. All right, and then we need to add this label to the frame. This.add, we're adding our label. And we should have a simple label in the top left corner. Now this is our label. We're going to move this label around the frame depending on the key that we press or the key that we type. Let's begin by filling in the key typed method. We can evaluate the key character that is being produced, and this would be best by using a switch. You could write this with a bunch of if statements, but it's not as efficient, so let's use a switch. And what we're going to be passing into the switch to examine is e.getKeyCharacter. This will produce a character, and then we can use the switch to determine what character is being used. So let's set different cases. Let's have a case for A to move to the left, W to move up, S to move down, and D to move right. So if the key character that is being produced is A, if somebody types in the character A, we want to move our label to the left. And one way in which we can do that is by using the name of our label, label.setLocation, and we pass in some coordinates, some new coordinates of where we want to place this label. On the y-axis, we want to keep this the same, so we can use label.getY. And we're going to do the same thing for x, but we're going to adjust it slightly. Label.getX. But if we want to move to the left, we want to subtract a number from this. Let's say just 1 pixel, we'll keep this small. And let's try this. So we have our label. If I were to press A, this is slowly moving to the left, but we need to set this for the other directions as well. So I'm going to add a break after this case, and I'm just going to indent this slightly, just so it's easier to read. So let's have a case for W, S, and D. So case W, we want X to stay the same, but we want to move up. So we subtract a number from Y. And then we need S and D. S will move down, so this is +1. And then X stays the same. And lastly, D. X will just add 1, and Y we will keep the same. And now we should be able to move up, down, left, and right. Down, right, up, left. So this is moving fairly slow. We can actually increase the amount of pixels this is moving after each key character. So let's change this from 1 to 10, and this is going to be more drastic. All right, this is moving much faster now. But yeah, you get the idea. Now let's do the same thing, but use the arrow keys on the keyboard. The arrow keys do not produce a key character, but you can use key pressed for these. So let's actually copy this switch that we have and paste it within here. And this time we're going to be using the key code. So let's pass in the key code underneath key pressed. And the case will be, actually we need to see what these buttons are first. Okay, so left is 37, up is 38, down is 40, and right is 39. So we're going to pass in or use these numbers for the cases. So let's begin with left. That is 37. 37, we're going to be moving to the left minus 10 pixels. Case 38, we're going to be moving up by 10 pixels, by 10. 39 is down. Actually, that's right. So we're going to move to the right by 10. And then 40 should be down. And this is, X is going to be the same, and Y is +10. All right, I'm not going to use WASD. I'm using the arrow keys on my keyboard. So down, right, up, and then left. Now I have a special treat to show you guys before you go. Instead of moving our boring red label on the screen, let's move an image. I have an image of a rocket that I want to use in place of this red square. So I'm going to add this icon to the label, but first we need to create an icon. So if you want, feel free to pause the video and download an image that you want to use. So I'm going to create an image icon. We'll call this icon. First, let's declare it, and then within the constructor, we'll instantiate it. Icon equals new image icon, and then I'm going to list either the file path or the file location. Since this is within my project folder, I can just list the file name, and that is rocket.png. And I am not going to use the background color, and I am not going to set this to opaque. I'm going to add this icon to the label, label.setIcon, and then I'm going to pass in my icon that I want to use. And now I have a rocket ship on here. And I'm going to change the background color because why not? So to change the background color of the frame, that is this.getContentPane.setBackground, and we'll just pass in color.black to represent outer space. And now we have the very beginning of a simple game. So maybe you could do like Invaders or something where you can move your character left and right and dodge bullets or something. But yeah, I just wanted to show you guys that before you go. So that's the basics of the key listener interface. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the key listener interface in Java. Hey, how's it going everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how the mouse listener interface works in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, let's get started, people. I have two classes. I have a class called main, and it contains an instance of my other class that is called myFrame. MyFrame extends JFrame, and within the constructor for MyFrame, I have 4 lines of code. This .setDefaultClose operation, JFrame exit on close. I have a size of 500 by 500. I am using no layout manager. This .setLayout is set to null. And lastly, this .setVisible is set to true. One of a few ways in which we can use a mouse listener interface is to have the definition of your class implements the mouse listener interface. So according to the description for the mouse listener interface, this listener interface is used for receiving interesting mouse events such as a press, release, click, enter, and exit on a component. So since we're implementing an interface, we need to add any unimplemented methods. And for mouse listeners, there are 5 methods: mouse clicked, mouse pressed, mouse released, mouse entered, and mouse exited. So let me give you a quick description for each of these. I've added a short description for each of these methods. Let's begin with mouse pressed. Mouse pressed is invoked when a mouse button has been pressed on a component. So if you hold down a mouse button, it's going to execute mouse pressed. Mouse released is invoked when a mouse button has been released over a component. Mouse clicked is invoked when the mouse button has been clicked, pressed, and released on a component. Mouse entered is invoked when the mouse enters the area of a component. And mouse exited is invoked when the mouse exits the area of a component. So let's apply a mouse listener to a label. So we will create a JLabel. JLabel, label, we'll declare it outside of the constructor and instantiate it within the constructor. So let's create a label. Label equals new J label. And since we're using no layout manager, let's set the bounds for the label. Label.setBounds. We'll place this in the top left corner, and we'll make the width 100 and the height 100. And let's color this red. So label.setBackground color.red. And in order for the background to actually appear, we have to label.setOpaque and set this to true. And lastly, we need to add this label to the frame. This.add label. And now we should have a red square at the top left corner of our frame. Now we're going to apply a mouse listener to this component, to our label. So we type in the name of the component that we want to add a mouse listener to, label.add mouse listener. And since we're implementing the mouse listener interface, we can just pass in this. Now, this label can respond to different mouse events. So let's do a simple print line. So let's begin with mouse clicked. System.out.println, you clicked the mouse. Now, I'm clicking within the frame, but we did not apply the mouse listener to the frame. We applied it to the label. If I begin clicking within the label, it invokes our mouse clicked method. Now we have mouse pressed. That is if we hold down one of the mouse buttons. So I'm going to system.out.println, you pressed the mouse. This time I'm going to hold down the left mouse button. You pressed the mouse, and then it doesn't do anything if you release. So this also applies to the right mouse button and to the center mouse button if you have one, the scroll wheel. All right, we're going to print line, you released the mouse. This is only invoked once you release one of the buttons. So I'm going to hold down the left mouse button, then I'm going to release in 3, 2, 1, go. You released the mouse. And then we also have entered and exited. You entered, let's say, the component. So I'm not going to click, I'm just going to enter the component. And then it says you entered the component. And then we have exited. You exited the component. So I'm going to enter and then leave. Enter and then leave again. So you can see that there are different mouse events. Let's make one more change to this label. Let's change the color of the label after we perform one of these methods. So let's begin with mouse pressed. Let's say after you press on this component, you press the mouse over the component, we'll set the background to a different color. And for this color, let's say yellow. Color.yellow. So I'm going to press, and then the background color is now yellow. And let's say when we release, we'll have this become a different color, like green. So I'm going to hold down, it's currently yellow, and then when I release, it's going to be green. And we'll have mouse entered. Let's change this to blue. And then when we exit, we'll change it back to red, I suppose. Color.red. Now I'm going to enter the area, it's blue, and then leave. Enter again, it's blue again, and now it's red again. If I were to click and release, it's green, and then when I exit, it goes back to red. Here's a what-if situation. What if we applied our mouse listener to the frame instead of just the label? So let's replace label with this and see what happens. Now, if we were to enter the area of the frame itself, now this responds to our mouse events that happen, and you can see that the color of the label is changing too. And if I were to click within the frame, it's going to change the color of our label as well. So where you apply or where you add the mouse listener to actually makes a big difference. If you were to apply the mouse listener to the entire frame, then the entire frame is going to respond to these separate mouse events. So that's just something to keep in mind. So here's a small project that I thought we could work on. We're going to apply a label or set the icon of the label to one of a few images depending on which mouse event occurs. I have 4 images. This one is called smile. This one is nervous, pain, and dizzy. The icon is going to change for the label depending on which mouse event occurs, which method is called. So if you need some images, feel free to pause the video to download some. So I have 4 images, smile, nervous, pain, and dizzy. I'm going to declare these outside of the constructor, and within the constructor, I'm going to instantiate these. I made a few changes to our frame that you should be aware of. For the layout, I'm using a new flow layout, followed by this.pack, and this.setLocation relative to null. This will have your frame appear in the middle of your computer screen. It's not crucial, but it's helpful, and I sometimes forget to add this. So we need to instantiate these image icons. So we have smile equals new image icon, and we can list the file path or the file name if it's within your project folder. Since these are within my project folder, I can just list the file name. So for smile, this is smile.png, and then I have nervous, pain, and dizzy. So I'm going to follow the same steps for those as well. So we have nervous equals new image icon nervous.png, followed by pain, and lastly dizzy. Now for our label, I'm going to set the icon to smile right away, so that will be basically the default. Label.set icon, and I'm going to set this to smile. And we need to add this label to the frame. This.add, what are we adding? We're adding our label. But before we compile and run this, I need to instantiate my label because I forgot to do so. Label equals new j label. And then we also need to add a mouse listener. And let's add the mouse listener to the label. Label.add mouse listener. I suppose you could do the frame too, that would work. Label.add mouse listener. And now we should have our smiley face, which we do. Now we're going to change the icon of the label based on which mouse event occurs. So we can actually copy this line of code where we set the icon. And let's say when we enter the area of the label, this is going to change or be set to our nervous image because we're in our face's personal space. He's kind of nervous. And then if we were to exit, he'll go back to smiling. So let's try it. So he's fine right now, but if we enter his personal space, he's getting really nervous and cautious of us. But if we were to leave and move the cursor outside of the label, he's just fine. Now let's do pressed and released. So if we were to click on him, he's going to be in pain, kind of like we hurt him. And if we release the mouse, we'll say he's dizzy, because he doesn't know what just happened. All right, we're going to enter the area. He's nervous. Now he's smiling. Now he's nervous again. We're going to click and hold down the mouse, and he's in pain because we're hurting him. And then if we were to release, he's just dizzy. But if we were to leave this area, he goes back to smiling. All right, everybody. Well, that's the basics of the mouse listener interface in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how the mouse listener interface works in Java. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can drag and drop images in Java. So let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Now, before you begin this project, I would recommend that you download or create some sort of image or icon that you can use that you can drag and drop. So what you can do is actually take your image and then add it to your project folder. So for me, I'm actually using a smiley face that I actually made using Microsoft Paint. So that's what I'm going to use for this project. Hey everyone, so this project's going to be a little complex, but I'm going to try my best to walk you guys through this. So let's begin by creating a new project. So File, New, Java Project, and let's call this maybe Drag and Drop. Click Finish, and then if it prompts for a new module, we're going to click Don't Create. So then go to your project folder, go to the source folder, and we're going to create 3 different classes. The first is going to be a main class, so we'll call this main. Check this public static void main checkbox and click Finish. Okay, let's create a JFrame class. So go back to your source folder, go to File, New, Class, and let's call this maybe MyFrame. It's going to extend JFrame. Click Finish. So MyFrame extends JFrame. And then we'll need an import. So import javax.swing.jframe. Let's create the last class. So go back to the source folder, File, New, Class, and then we will call this perhaps Drag Panel. And this will hold an image that we will drag around on the screen. And this is going to extend JPanel. Click Finish. So Drag Panel extends JPanel. And then get this import as well, javax.swing.jpanel. Okay, so these are the 3 classes that we'll need. Let's go back to our main class, and there's just one line we need to type within here. We're going to create an instance of MyFrame. So we'll type that in, MyFrame, and we'll call this MyFrame with a lowercase m, doesn't matter, equals new MyFrame. All right, and that's all we need to do for this class. Let's go to MyFrame, and we're going to create an instance of our JFrame, which is called MyFrame basically. So let's create a constructor for MyFrame. And we have a few things to fill within here. Let's add a title. So this dot set title, and we'll call this frame drag and drop demo. This step really isn't necessary, but if you want to add a title, this is how to do it. All right, then let's set the size. So this dot set size, and we'll make this 600 by 600. That's a decent size. And this dot set default close operation, then jframe dot exit on close. Okay, now we'll take this and set the visibility. So set visible true. Okay, so we should have a JFrame that's 600 by 600, and the title is drag and drop demo. So let's create an instance of our drag panel, which functions much like a JPanel basically. So we're going to create an instance of this, but we're going to do this, I would say, outside of our constructor. So drag panel, and we'll call this drag panel with a lowercase d, equals new drag panel. Now we need to add drag panel to our frame. So this dot add drag panel. And that's it for this class. So nothing will appear yet besides this frame. We're going to work on our drag panel next. Okay, so go to your drag panel class, and we're going to create a constructor for drag panel. So drag panel, parentheses, curly braces. So if you have an image picked out that you want to use, what you're going to do is actually add it to your project folder. So I'm just going to drag and drop it within the project folder, and then click OK because I already have a picture. So the picture that I used is a smiley face, and it's within the project folder, the Java project folder, drag and drop. So I'm actually going to use this picture. So I'm going to create an instance of an image icon. So image icon, we'll call this image, equals new image icon. And then within parentheses, type in the file name or the file path. And this is called smile.png. And then we'll need to import something. Okay, so we have a picture now that we can use. All right, so there's a few other things that we're going to add to this class. So we're going to create a paint component method. So we're going to do this after the constructor. So this is a public method that's void, doesn't return anything. And it's called paint component. And then as a parameter, it needs graphics G. Then a set of curly braces here. And then we need to import graphics. Okay. And then we're going to create two inner classes now. Now this first inner class, let's call it click listener. And with the video on inner classes, we can make this private. So private class, and we'll call this click listener. It waits until we click the mouse. So this will extends mouse adapter, then a set of curly braces, and then we'll have to import this as well. java.awt.event.mouseAdapter, and we're going to create another inner class, and this is going to be private class, and we'll call this drag listener, and this will extends mouse motion adapter. And the point of this class is that it's going to actually move our image as we move our mouse around. Then we'll need to import this as well. java.awt.event.mouseMotionAdapter. All right, let's start filling some things in, but this is the basic framework that we need. So let's begin before our constructor. So after our image, this is what we're going to type. We're going to create a width variable. So let's call this width equals image dot get icon width. And you know what? Let's make this final, because we don't plan on this image changing size anytime soon. We're going to do the same thing for the height. Final int height equals image dot get icon height. Just like that. We're going to create a point. So use the point class. So point image corner. That's a good name for this. Then we'll need to import this. And we're going to create another point. And we'll call this previous, but we can type in prev for short, pt for point. And that's everything that we need before our constructor. So what we're going to do with inside our constructor here is we're going to set the image corner point to equal new point 0, 0. So this is in the very top corner of the image. Okay, we're going to create an instance of our click listener class. So type in the name of the class, click listener, and we'll call this click listener with a lowercase c equals new click listener. It's really hard to get the spelling right on these. We're going to do the same thing for our drag listener class, but I'm just going to copy this and make a few changes. So I'm going to change click to drag for the second line. All right, now what we need to do after this is that we're going to take this JPanel, so this dot add mouse listener, and we're going to add our click listener. Then we're going to take this again and add a mouse motion listener and add our drag listener. Okay, that's everything we need to do within our constructor. We're going to go to our paint component method. Now, what this paint component method is going to do is that it's going to repaint our image after we update the new positioning of it. So the first line is that we're going to use the superclass's paint component method. And we're just going to send in our graphics G within here. Then what we're also going to do is take our image.paint icon, and there's a few fields to fill in with these parentheses here. The first is this, and this is our JPanel basically. G is going to be our graphic, so we'll keep that as G. We need a X position, so image corner dot get X method. We're going to do the same thing for Y. So this will get the new position for our image. Then we'll probably want to cast these as an integer. So we're going to use the cast int for X and Y. Okay, that looks good then. That's all we need for this paint component method. Next, let's go to our click listener. So what we're going to do within here is create a method, public void. We're going to call this mouse pressed, and there's one parameter, mouse event E. And then we'll need to import something. Then what we're going to do within here is we're going to take prev point, our previous point, equals E dot get point. So all this is doing is updating the previous point to wherever we click. And that's it for our click listener. So the last step is to fill in this drag listener class, and then we're done. Let's check to see what we have so far. So when we run this, here's our image, well, at least the one that I picked. It's in the top left corner, but we cannot yet drag it and move it. So that's what we're going to work on next then. So within our drag listener class, we're going to use the mouse dragged method. So type in public void mouse dragged. And then the parameter is mouse event E. Then add a set of curly braces. So the first line within here is we're going to create point. We'll call this current point, current PT for short, equals E dot get point, wherever our mouse event currently is. Now what we're going to do is take our image corner, and we're going to use the translate function. So this takes an X dimension and a Y dimension. So I'm actually going to expand these parentheses to give us some room. So the first thing we're going to type between the parentheses of the translate function is we're going to take our current point and use the get X function minus previous point dot get X function. Then let's put these all within parentheses, and we're going to cast this as an integer. All right, so then add a comma afterwards. We're going to copy this and do the same thing for the Y position. So int current point dot get Y, and then previous point dot get Y. So this is going to translate our image corner to the new position, wherever our current point currently is after dragging our mouse. Now we're going to take previous point equals wherever our current point currently is. And then lastly, we just need to repaint this image. And that's it. Let's run this. So here's our image, and we can now drag it and drop it somewhere else. So that's it for this drag and drop project. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how you can make a drag and drop project in Java. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, we're going to be discussing key bindings in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, we're going to be discussing key bindings. What this does is that this binds an action to a certain keystroke. So for example, let's say that within certain games, you might be able to move your character forward by clicking the W button, or A for left, S for down, or D for right. So this is very similar to key listeners, but there's a few subtle differences. So with key bindings, they actually don't require you to click a component to give it focus. And all Swing components, at least all Swing components that I know of, actually are capable of using key bindings. And the reason that you might want to use key bindings over key listeners is that they give you more flexibility, and you can actually assign different keystrokes to individual Swing components. So let's say that you have player 1 and player 2. You could have player 1 have a certain set of keys on the keyboard, and player 2 could have a different set. Although one downside to using key bindings over key listeners is that they tend to be more difficult to utilize and set up, but I'll give you guys just a quick demonstration of how these could be useful. So if you're ready, let's begin. I'm going to create a new class within my project folder, so File, New Class. I'll call this maybe just Game. Not any specific game, just a game. And then let's create an instance of this class. So game equals new game. Then let's create the constructor for this game. Okay, so we can actually bind actions to keystrokes. So if we want to create an action, we can actually create an inner class for a specific action. So we're going to create an action for an up action, down action, left action, and right action. So I'll make this public. This will be a class, not a method, and we'll call this up action. And it's going to extends abstract action. So we need an action performed method within here. So add unimplemented methods. And then we're going to create a separate class for down, left, and right. So we have left action. Let's add up, down action as well. Maybe right here. So up, down, left, as well as right. So let's head back to the top before our constructor. We can actually create an action object. So it's going to look like this. Action is the data type, and we can list a specific action like up action. This is an instance. And then action, down action, action, left, action, and action, right, action. So there'll be more on this in just a moment. Let's just create the frame. So let's declare a JFrame called frame, as well as a label. We'll be able to control the movement of this label. So JLabel, and we'll call this label. Then we'll need to import this. And I'm just going to import everything related to javax.swing and awt.event. So we don't have to worry about those. Okay, let's begin by setting up the frame. So frame equals new J frame. Let's call this key binding demo, although it's not necessary. And then frame dot set default close operation J frame dot exit on close. Let's set a size. So frame dot set size 420 by 420 is a decent size. And then I do not want to use a layout manager, so set layout null. And then at the end, let's set the visibility for this frame to true. Set visible true. Then let's create our JLabel. So let's instantiate this instance, label equals new JLabel. Let's set a background color, label.set background. How about red? Color.red. Let's set the bounds, label.set bounds. These are the coordinates. Let's place this where x is 100, y is 100, the width will be 100, and the height will be 100. So it's going to be a square, and we need to set opaque true. And then add this label to our frame. Frame.add label. Let's run this and take a look. Okay, here is our label. What we're going to be doing is actually binding some keystrokes to these specific actions, and we'll have this label either move up, down, left, or right. What we've done previously is that we declared these actions, but we need to finish instantiating them. So let's do that within our constructor, and I'll just do this after our label. So we need to instantiate the up action, down action, left action, as well as right action. So up action equals new up action. Then let's do the same thing for down, left, and right. So down action equals new down action. Left action equals new left action. And then right action equals new right action. Now let's head back to each of these inner classes, and let's begin with the action performed method within each of these inner classes. Let's begin with up action. So when the up action occurs, what we'll do is set a new location for our label, so it's going to appear to move. So one easy way to do that is to take our label and use the set location method, and we can give a pair of coordinates as arguments. So we can actually get the current location, get x, and then label dot get y. And if we want to move up, we can just say label dot get y minus 10. So that will move this label up by 10 pixels. Let's do the same thing for down, left, and right. So this will stay the same. Label.setLocation will keep x the same as it is. However, label.getY will want to increase by maybe 10 pixels to keep it consistent. And let's repeat the process for left action as well as right action. So we're actually going to keep y the same for this, but we're going to either increase or decrease our x coordinate. So if we're moving left, let's decrease x by 10. And then for right action, we will increase x by 10. And that is it for all of these inner classes. Let's head back to our constructor. Now with swing components in Java, each component is able to have its own unique mapping of key events to actions. So let's take our label, for example. This is a swing component, so it's a candidate. So if we want to associate some keystrokes with events, these are the steps. Type in the name of the component that you want to use. So in our example, it's label. And first we're going to use the get input map method. And then after, we're going to method chain. So dot put, and put has two arguments within here, a keystroke as well as an action map key. So let's associate the up keystroke with moving our character up. So within this argument, we're going to type keystroke dot get keystroke, and then a key character. So let's say up. And these are the arrows on your keyboard, not WSAD, but we'll try that next. And now we need an action map key name. And honestly, it doesn't really matter what you call this. Just name it something memorable, because we're only going to use this once in the next line of code. So I'll call this up action. And that's it for this line. Now, step 2 is we're going to get action map. So type in the name of the component. So label dot get action map. and then method chain by adding dot put, and this has a key as well as an action. So this key is going to be whatever this is in the first line, our up action. And then we need an action, so one of these. So let's take our up action. And that's it. So when we click up on our pad, on our arrows, on our keyboard, it's going to trigger this action performed method. It's going to move our label up by 10 pixels on the y-axis. So let's do the same thing for down, left, and right. So we just need to change up to down. And let's change this here as well. Changing these are easy to forget about. So down, 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 then two more. So this is going to be left. And then right. And that's it. Let's run this. Okay, so using the arrow keys, I'm clicking up, down, left, right. Although you can't really see it, but I guess you'll just have to believe me. Now let's change these to different keys. Let's associate the up action with the W key. So since this is a single character, make sure that these are within single quotes. So W for up, S for down, left will be A, and right will be D. And let's try this again. So W, S, A, D. We are good. Alright, so that's the basics of key bindings. There's still a lot more you can do with key bindings, so I might make a second video in the future. No promises though. But yeah, if you want a copy of all this code, I'll post all of this in the comments down below. And that's the basics of key bindings in Java. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can paint some simple 2D graphics in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay everybody, let's create some 2D graphics, but before we begin, here's my setup that I have so far. I have two classes, a class called main that just contains my main method, and an instance of my other class called myFrame. And this class, myFrame, extends JFrame, so it behaves exactly like a JFrame. Within the constructor for myFrame, I have this.setDefault close operation, JFrame exit on close. I'm using a size of 500 by 500. This.setLocation relative to null. This allows the frame to appear in the middle of the computer screen and not just the top left corner. And lastly, this.setVisible is set to true. Now, I'm on Oracle's website looking up some Java documentation, and for the component class is a parent class to many of the Java GUI components that we work with. There is a paint method underneath the component class, and this has a parameter of graphics G. It takes a graphics object, and what this paint method does is that this method is called when the contents of the component should be painted, such as when the component is first being shown. So most, if not all, GUI components actually have component somewhere as a parent class somewhere down the line, and with our myFrame class, we're going to be overriding this paint method and be drawing some stuff. So within this myFrame class, let's define and declare what we want this paint method to do. So we'll say public void paint, and this has a parameter of graphics, a graphics object, and we'll just call this graphics G. So G is going to be our graphics object, and this paint method is actually called behind the scenes. It's invoked automatically when we instantiate a component, such as a JFrame. So we do not need to explicitly invoke this paint method. It'll do so for us behind the scenes. Now, with graphics, it's somewhat outdated. We're actually better off using something called Graphics 2D, which is an updated version. Graphics 2D is a child class or subclass of the graphics class. And what we're going to be doing is casting our graphics G as a 2D graphic. So for the very first line after we call the paint method, we're going to cast this graphics G object as a graphics 2D object. So let's say graphics 2D, and let's call this instance G2D equals G. And then we need to cast this. So within parentheses, we're going to add the cast, graphics 2D. Now, this graphics 2D object has more options available to us as to what we can draw and do compared to a graphics G object. Now, let's attempt to draw a few things. So there's a few methods available to us to do that. So let's say G2D dot, and there are all sorts of things that we can draw. Let's begin by drawing a simple line. So that's dot draw line. And there are a few parameters, a starting point, X and Y, well, I guess starting coordinates, and then ending coordinates of where you want this line to end. So if our frame is 500 by 500, let's draw a line from the top left corner to the bottom right. And the coordinates for the top left corner of the frame would be where X is 0 and Y is 0, and since the size of the frame is 500 by 500, the bottom right corner would be where X is 500 and Y is 500. So there's just going to be one problem with this. This will draw a line, however, it's not necessarily in the starting position that we thought it would be. So here's the issue. With our frame, the size of the frame also includes this window bar at the top. So with the starting coordinate, it's actually starting in the top left of the window, and this window bar is somewhat overlapping our graphics area in which we can display. So it may be better for us if we were to create a panel, draw on the panel, and then add the panel to the frame. So let's actually create a class called myPanel, which will extend jPanel. So let's create one more class, and then we're going to draw on this panel. So file, new class, we'll call this myPanel, and then click finish. MyPanel extends jPanel, so it will behave exactly like a jPanel. And then we'll need to import something as well. And then we'll need a constructor for myPanel. Okay, now going back to myFrame, we're going to change a few things. We're going to get rid of this paint method. And since a panel, a jPanel, is considered a component, we can actually call the paint method. So take the paint method from myFrame and paste it within myPanel. And then we'll want to create an instance of myPanel. So let's declare this outside of the constructor, myPanel, and we'll call this panel, and then instantiate it within the constructor. Panel equals new myPanel. And we'll need to add this panel to the frame. So let's do that right about here. This dot add, we're adding our panel. And we no longer need a size, and we should probably pack this. So after you add all the components that you want, follow this with this dot pack. So this should fit nicely. Now what's going to happen is that this is going to create a panel for us, and then we should probably set a size for this panel too before I forget. This dot set preferred size, new dimension, and we'll make this 500 by 500. What ends up happening now is that this panel is fully visible before we were drawing directly on the frame, and this window bar at the top is part of the frame, so it was overlapping a portion of the visible area. So now this entire panel is fully visible to us. Let's head back to our myPanel class and draw a few things within the paint method. So we drew one line. Let's change the width of the line. This is kind of like the stroke, the brush size that we're using. So we can actually change that. G2D dot set. There's actually all sorts of things that you can set, but we're looking for set stroke. And we can pass in a new basic stroke. And then we set the size of the stroke. So if we want this to be 5 pixels, we'll pass in 5. And what we get is an extra thick line, and it's not just a 1 pixel brush stroke. You can also change the color too. So G2D, and this would be dot set paint, and you pass in a color. So let's say we want this line to be blue. Color dot blue. You can also pass in some hex values or some RGB values too, but we'll just stick with simple colors. So now we have a blue line going across the screen. Let's draw a few other shapes. For now, I'm just going to comment out this line where we draw a line. Let's draw a rectangle. We type in the name of our 2D graphic, which is G2D dot draw, and there's all sorts of things that we can draw. Let's draw a rectangle, and this is draw rect, like get rect. So we place starting coordinates as arguments, as well as a width and height for this rectangle. Let's say we want this to begin in the top left corner of the panel. So that would be where x is 0, y is 0, and let's make this 100 by 200. If you want this to be a square, you could make this 100 by 100. So now we have a rectangle on our panel, and it retains that blue color that we set, as well as the stroke size. That's kind of like the line thickness. So if you need to draw another graphic, you can actually set the paint color to something else before you actually draw this. Let's set this to pink. I don't know why, I just picked a random color. And now we have a pink rectangle, and if you need to fill this, that's actually a different method. That would be fill rect. So that would be G2D dot fill, and you can fill all sorts of shapes here. We're looking for fill rect, and we'll keep the same coordinates. So 0, 0, then 100 and 200 for the height. And here's our rectangle in the top left corner of the screen, and it is completely filled. One important thing that you should keep in mind and know is that as you're drawing graphics, any more recently created graphics are going to overlap any previously created ones. So if we were to draw this line and then draw a rectangle, the rectangle is going to overlap this line, kind of like there's a z-axis. So anything that is more recently created is going to overlap any previous items or graphics. Let's draw a circle next, and I'll get rid of our rectangle that we have, as well as this line. We'll just turn these into comments. If you need to draw a circle, you use either draw or fill oval. G2D dot, let's draw an oval first. So this will be just an outline. Draw oval. Now the coordinates are the top left of the drawable area for this oval. So if we want this to start in the top left corner of the panel, that would be where x is 0, y is 0, and let's make the width 100 and the height 100, I suppose. And we should have a, actually let's change the color too. G2D, set paint. Let's make this, I guess, orange. Kind of like it's the sun. I suppose yellow would work too. We'll keep the same stroke size of 5. And we have a orange outline of a circle or oval. And if you need to fill this in, you would instead use fill oval, which we'll do. G2D dot fill, and we're looking for oval. And we'll place this at the same coordinates. Same width and height too. And we have an orange circle or oval in the top left corner of our panel. Okay, this next one is a little tricky. This is draw arc. And let's set a color. So we're actually going to use draw arc to draw a Pokeball for practice. G2D dot, let's draw arc first, then fill arc. Draw arc, and there's a few more arguments. Starting coordinates, a width and a height, a starting angle, and an arc angle. So we'll place this in the top left corner just to keep things simple. For the width, let's make this 100, and the height 100. So for the starting angle, let's set this to 0, and the arc angle will make this 180. So this will be a half circle because it's 180 degrees. Now, if we were to change the starting angle, let's say 180, it's going to flip counterclockwise. Let's practice drawing a Pokeball. So let's set the paint to red for the top, I would say, hemisphere. and set this to 0, and we're going to use fill arc. And we'll get rid of draw arc. Actually, we should get rid of the stroke size too. Alright, so we should have a red half circle. And the bottom's going to be white, but I'm not sure how well this is going to display. So let's set the paint after we fill the first arc. And color this white. Color.white. And we'll have the starting angle be 180, but we'll keep the full extent of the arc at 180, so it's another half circle. And we should have a Pokeball, or at least something that slightly resembles a Pokeball. I would say that's close enough since we're just beginners at this. Alright, we can also draw a triangle, and for that we'll actually use a method called draw or fill polygon, and we actually have to pass in an array of coordinates, or integers. So this would be G2D dot, and let's begin with draw. Draw polygon. Okay, so this takes an array of integers and a number of points. A triangle would be 3 points, so let's just pass in 3 points. But we'll need to pass in an array of integers, so let's declare these right before we actually draw this polygon. So we'll say int x points, and we'll pass in some x coordinates. Let's say 150, 250, and 350. We'll pass in some y coordinates as well. So this has to be another array of integers, and this will be y points. Let's set this to 300, 150, and 300. And we should have the outline of a triangle. Let's set this to yellow. So that would be g2d.setPaint, and we'll pass in color.yellow. Now we'll fill the polygon. It's the same process as before, but replace draw with fill. And we have a yellow triangle. It's kind of like a piece of the Triforce from the Legend of Zelda series. Well, one of them at least. We also have the capability of drawing a string of text on our graphic. G2D.drawString. We pass in a string as an argument, as well as coordinates. For the string, let's say, you are a winner. So for now, let's set the x-coordinate to 0 and the y-coordinate to 0. But when we compile and run this, we actually cannot see the string. That's because it's hidden right now. Let's change this to 50 by 50, and you'll see why. So now the string is visible. That's because when we display the string, the starting position of our string of text is the bottom left corner. Since we set this to 0, 0, well, that's going to be the very top left corner of our panel. So it's actually not being displayed because it's kind of off screen. Now let's change the font and the font color of the string. G2D.setFont, and you can pass in a new font and pass whatever font you want. I will pick Ink Free because I like that font. That's a font family. Then we can pick a font style. Let's say bold. And a size. I will make this 50, I suppose. You are a winner. And changing the font color is the same process as before. We just set paint to whatever color we want. What color do we not pick yet? Let's pick, why not magenta? And the font color is now magenta. Let's say that you want to add your own image to this graphic. I have this PNG file, and it's called Sky, and I just created this myself. So I want to add this image to my graphic, my 2D graphic. So there is a method to do that. G2D dot, and that is draw image. And there's a few to pick from. So let's begin with something simple here. So this takes an image, coordinates, and then an image observer. We have not covered image observer, so we're just going to set this to null for now. So we need an image and coordinates. We want this to begin in the top left corner. Now we need to create an image out of this file that we have within our project folder. Let's call this image, and we're going to declare and instantiate this. So let's say image, image, and then within the constructor we'll instantiate this. Image equals, and this is a little bit different. We're going to create image equals new image icon and list the file name or the file path. Sky.png is my file name. Follow this with .get image. This will create an image out of the image icon. And then we follow this with draw image and then add your image here. And we should have our image added to our graphic. And then you can draw on top of this image. This could be a background image, let's say. So I'm going to move this and place this near the top. And let's draw, I don't know, maybe the Triforce that we have. So I'm going to re-enable all of these. Why not the Pokeball too? Well, yeah, that image that we created is kind of serving as a background for us. So that's how you can include your own image into a graphic to display. Well, everybody, that's the basics of creating 2D graphics. This video is getting kind of long, so I think I'll cut it off here. I was hoping to walk you guys through some practice with drawing a simple landscape, kind of like what Bob Ross does with his paintings, but I might have to wrap it up here. So if you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating 2D graphics in Java. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create some very simple 2D animations in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Let's get started, people. So with this video, we're only going to be moving an image around on the x-axis and the y-axis. We're just going to be covering some very simple animations by use of a timer, so it's not going to be anything that sophisticated. Now, before we begin, here's my setup that I have. I have 3 classes, a class called main, a class called myFrame that extends JFrame, and a class called myPanel, which extends JPanel. Within the main class, I have an instance of myFrame. Within myFrame, I have an instance of myPanel called panel, and within the constructor for myFrame, I instantiated this panel. For this myFrame, I have this .setDefaultClose operation, jFrame exit on close. We're going to add this panel to the frame, and we're going to be painting on the panel itself, followed by this .pack, this .setLocation relative to null. This will allow the frame to appear in the middle of your computer screen. And lastly, this .setVisible is set to true. We're going to be finishing everything else within this myPanel class. So we have a constructor for myPanel. We're going to declare a few things outside of this constructor. So let's begin with the panel width and the panel height, because we'll want to know what the limitations are of the image that we're moving. We'll want to know the bounds that we have. So I'm actually going to make this a final integer for the width and the height. So let's say final int panel underscore width, and let's set this to 500. And we'll do the same thing for height. Panel height, and we'll make this 500 as well, so this will be a square. So we're going to need an image. Image, we'll call this image. Actually, better yet, let's call this enemy, because I'm going to be moving this enemy icon around within the panel. So let's call this enemy instead, just so it's easier to differentiate. I'm also going to use the space background as my background. So I'm going to make an image called image background image, and we'll do this last. That's all one word though. We're going to need a timer, so timer int x velocity, so we can adjust how far or how many pixels this image is moving on the x-axis. Let's set this to 1 to begin with, and we'll do the same thing for y velocity. And we'll have a starting x position, and we'll set this to 0. And the same thing with y. Int y. And that should be it for now. Now within the constructor, we're going to finish instantiating a few things. Let's begin by setting the size of this panel. Since we're using the pack function, we'll want to set preferred size. So this dot set preferred size, and we pass in a new dimension. And we can use panel width and panel height for that. So let's pass in panel width and panel height. And this should appear. Yep, here's our panel that's added to our frame. And we're going to be drawing on this panel. So the next thing that we should do, let's set the background color just because we can. This dot set background color. Eventually, if you have an image, we'll replace the background color with the image that you have, if you have one. Let's set this to color.black. And let's finish instantiating this image, and it's called enemy. Enemy equals new image icon. And then we list the file path or the file name, and this is enemy.png. And then to create an image, we're going to method chain this by adding .getImage. This will make an image out of our image icon. Now we need to create a timer. We haven't done that for a while, so we'll finish instantiating this timer. Timer equals new timer. And there are 2 arguments to pass in for a timer. So we need an integer for the delay of how often this timer fires and does something, as well as an action listener. So let's say we want this to perform an action every 1 second. So this is in milliseconds, the delay. So we'll perform an action every 1000 milliseconds, 1 second. We also need an action listener. So we'll have this JPanel implements action listener. There are better ways of doing this, but since we're beginners right now, that will be in future videos. So we'll need to add any unimplemented methods. And we have an action performed method. We'll return to our action performed method later. We need to define our paint method, and the paint method is called behind the scenes when we instantiate our panel, because our JPanel is a subclass of the component class. So let's say public void paint, and this has one parameter of graphics, graphics G. And the first thing we're going to do within this paint method is cast our graphics G object as a 2D graphic, because there's more options available to us with graphics 2D objects. So graphics 2D, we'll call this G2D equals G, and then we need to cast this graphics 2D. And if we want to draw any graphics, we type in G2D dot and then draw, fill, whatever you want. We want draw image because we want to draw our enemy image. And there are a few different images that take various amounts of arguments. So let's stick with this one for now. This takes an image, some coordinates, and then an observer. So with the observer, we have not covered those yet, so we're going to set this to null, and we have to set an X and Y position. Luckily, we already declared what we want these to be. X is 0 and Y is 0, so we can keep these the same. And this image is called enemy. So this will draw our enemy on our panel. And right now it's in the top left corner. So notice that with this background, we set this to black. Now to actually paint the background, we need to use the paint method of the parent class, also known as the superclass. So before we actually cast this graphic, we're going to call super.paint, and we pass in our graphics G. So this will paint the background for us. and you can see that it's black. So this will paint background. Well, we have our image drawn, but how do we get this image to move? Let's say we want to move this image on the x-axis across the screen. Well, we can use our timer to help us do that. So after every 1000 milliseconds, 1 second, it's going to perform our action performed method. Now, with our timer, when we instantiate it, we need a delay, which we have, and an action listener. Since we're implementing the action listener interface, we can pass in this. And then we need to start this timer by saying timer.start. So this will start our timer right when we instantiate this panel. So after every 1 second, we can perform some sort of action. Anything within the action performed method will occur. So let's move the coordinates of our enemy that we have. So we have x equals 0 and y equals 0. Let's say we want to move our image on the x-axis. So we'll say within the action performed method, x equals x plus our x velocity for our enemy. Now, when we run this, pay attention. It doesn't appear to move, but it actually is behind the scenes. I'm going to resize this window slightly, and you'll see that our image just jumped. That's because we are not currently repainting our window that we have, our panel. So we need to actually call this paint method again every time we update the position of our enemy or any components that it contains. And let's look at this paint method. According to the description, it says that applications should not invoke paint directly, but should instead use the repaint method to schedule the component for redrawing. What we're trying to do is that after we update the position of our enemy, we're attempting to call paint again to redraw the enemy in its new position. However, we instead need to use repaint according to the description. Repaint in a roundabout, indirect way will call paint for us to redraw all of the graphics that we have. So now this will actually repaint our enemy without us having to resize the window, because when you resize the window, it will repaint everything. But now it just does it for us. Okay, now this enemy is moving very slowly. So let's have our action performed method be called every 100 milliseconds instead of every 1000 milliseconds. So the position of our enemy is updating every 100 milliseconds. But why stop there? Let's set this to maybe 10. That should be a decent speed. So after every 10 milliseconds, this enemy is moving on the x-axis by 1 pixel. However, it's not going to stop. It'll just keep on going into the void. So we'll want to set some bounds. Let's say that when this enemy touches the right border, we want it to go left instead of continuing right. So we'll write an if statement within the action performed method to check to see if x is greater than or equal to our panel width. So we'll write that first. If x is greater than or equal to our panel width, and we declared that up here, and it's 500. If it is, we want to change direction, and one way in which we can do that is to flip the x velocity. So currently it's a positive number, but if we were to set this to a negative number, it's going to go in the opposite direction. So we can say x velocity equals x velocity times -1. So when we want this to change direction, it's going to multiply whatever x velocity is times -1. So 1 times -1 equals -1. And then when we run this, we'll have to give it a second to reach the border. It's going to eventually go to the left. However, it measures where this enemy is located in the top left corner. So we'll want to take that into account. We're going to add one thing after panel width. Panel width minus enemy dot get width. And then if we have an image observer, we pass that in, but we don't have one, so we're going to set this to null. So we're checking to see if x is greater than or equal to panel width minus the width of the enemy image that we have. And now, once this enemy touches the right border, it's going to flip direction, which it just did. However, now it's going to continue into the void on the left-hand side. So we'll also need to check to see if our enemy is going to touch the left border, and we can do that using an OR operator. So if x is greater than or equal to panel_width minus enemy.getWidth, or x is less than 0, then we're going to flip our velocity. And now it should just go back and forth forever. And let's test it. Man, I hate awkward silences. All right, so yeah, it's just going back and forth forever. So when it reaches one of the borders, it's going to flip the velocity to either a positive number or a negative number. Now let's do the same thing with the y-axis, so this will go up and down. It's kind of the same process that we have before. I'm just going to turn all of this into a comment, and then copy and paste it. So make sure to write this before the repaint method that we have. Replace all instances of x with y. Make sure to do the same for the y velocity as well, x velocity and y velocity, and y equals y plus y velocity. Replace width with height. Do the same thing for get width as well. Okay, that should be good. And this will just go up and down forever, but let's check just to be sure. All right, we're good. And then if you were to mix these two, this will now go diagonal right across the screen, and when it hits the corner, it's going to bounce back. And you always have the option of messing with the x velocity and the y velocity. Let's set x velocity to 2. And this will now travel in a different direction and bounce off the borders. Let's finish this video by adding a background image, because right now it's just a plain black background. So I'm going to use this image that I downloaded of space, but feel free to use any image that you want to use. So this is within my project folder, and it is called space.png. I have already declared an image that I'm calling background image, and I'm going to finish instantiating this within the constructor. Background image equals new image icon. And within the constructor for the image icon, we list the file path or the file name. Since this file is within my project folder, I can list just the file name, space.png. I want to create an image out of this. I'm going to method chain by adding .getImage to the end of this. And now I can use my background image as an actual image and not just an image icon. I want to draw this image before I draw the enemy. And I'm going to copy this line and make a few changes. I'm going to draw the background image, and I'm going to place the coordinates for this image in the top left corner. So that is where x is 0 and y is 0, and we do not have an image observer, so we're going to leave this as null. And now for the moment of truth. The background image that I have is now applied to the background of my graphic. So that's the basics of creating some very simple animations in Java. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of simple animations in Java. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to be discussing with you guys generic methods and generic classes in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys, let's talk about generics. So the definition for this is that generics enable types, which are classes and interfaces, to be parameters when defining classes, interfaces, and methods. So a benefit of this is that it eliminates the need to create multiple versions of methods or classes for various data types. So basically we can use one version of a method or a class for all reference data types. So let me give you an example. So here's an example for you guys. I have 4 different arrays here. They all have different data types, and please note that these are reference data types. So we have an array of integers, doubles, characters, and strings. So we're using the wrapper class for some of these primitive values, such as like integer, double, and character. So what if we wanted to display all of the elements in each of these arrays? So normally what we would have to do is to create a method that can handle all of these individual different data types. So let's say, for example, we have a method called display array, and this accepts an integer array. So this is only compatible with our array of integers that, for our example, we just called int array. Now, if we wanted a similar method for doubles, characters, and strings, we would have to create another method that can handle each of these different data types that we have. So we'll create another array. This one will accept doubles. So replace integer with double. And let's do the same thing for character and string. So character, character, and then string. And then let's just test this. So we're going to call the display array method, and let's send in our integer array. Then we're going to do the same thing for double array, character array, and string. And let's run this. So yes, this does work, but it's kind of inconvenient to have 4 separate methods when they basically do the same thing. So here's a crazy idea. How about we don't? Let's create one version of this method that can handle all reference data types. So let's delete 3 out of these 4 methods that we painstakingly created, because we only are going to need one, really. So in order to use generics, we're going to be discussing both generic methods and then generic classes. So in order to use a generic method, right before the return type, we're going to add a set of angle brackets. And then typically, if people want to use generics, the common thing to do is just to place the letter T within here. That's just common practice, but I like to type in thing just because it helps me remember that this is a generic. So this is now a generic method. However, we can still only pass in an array of integers. So with the data type, we're going to replace that with whatever value or text is within these angle brackets. So we're going to accept an array of things, and then we're going to replace integer here as well with thing, or whatever value you placed here. And remember, it's usually T that people write here. That's just my quirk where I like to write thing, just because it helps me remember this. And if we were to run this, this does the exact same process as what we had previously before we used the generic method. So this is I would say, a shorthand or more efficient way to write your code, because you don't necessarily need an individual method for each individual data type that you have. You can just have one version that will accept all reference data types. Although you do have the capability of limiting the data types that are entering into a generic method or class by a concept called bounded parameters, but we'll discuss that later on in this video. So let's create another generic method, but this time it's also going to return something that's generic. So it's going to be a similar process to what we have set up previously with this generic method. So we're going to type in public, static, and then this is going to be a generic method. So we're going to type in a set of angle brackets, and then people usually write T here, but I like to write thing, but you do you, I guess. And then with the return type, this cannot be void because we're returning something. So we're going to be returning a thing, or whatever text you have within these angle brackets. And then let's name this method. Let's return the first element within each of these arrays. So let's call this get first, for get first element, I guess. And then we're going to pass in an array of things. So what we're going to be returning is return our array that we receive with this parameter at index 0, so it's the first element. And then let's run this. So I'm going to turn these into a comment for now. So we will system.out.println for each of these. And then we're going to call the get first method within the println statement. So get first, and we're going to pass in our different arrays that we have. So get first int array, double array, character array, and string array. And as you can see, this works just fine. Here's a more practical scenario. So figuratively speaking, let's say that we're creating a video game and we have various game sprites that we want to draw on the screen. We have a player, an enemy, an item, and a tree, and we want to display or draw these all within our game. So this really isn't set up. You can see that I've yet to create these classes, but this will work just for our scenario. So instead of creating a draw method that can only draw players, another draw method that can only draw enemies, another for items and trees, so on and so forth, what we would like is just a generic method. It will accept a reference data type or a thing and just draw it. So you could just have one method that will accept all data types, because we really don't want to have an individual method for all of these separate data types. We want just one method that will take care of everything for us. So that's the real benefit of generic methods. Let's move on to generic classes. Okay guys, let's discuss generic classes. So for this example, I have a few instances of some classes that we're going to create in just a moment. And each of these classes is going to store a different value, and these all have different data types. So my int will store an integer, and we're just going to pass in 1 to the constructor. My double will pass in maybe 3.14, character, the @ symbol, and then my string will just pass in the word hello. So let's create these actual classes, and then we're going to create a generic class just to compare and contrast the differences between them. So let's create my integer class first. So file, new class. We'll call this my integer class. And all this is going to do is store a single integer value, and we'll call it x. And let's create the constructor for this class. So my integer class, and we're going to receive one argument, and that is going to be the value integer x. And we're going to assign this x equals whatever x that we receive. And then let's create a getter method. So public, and we're not going to type in void, we're going to return an integer. Public integer get value. And we're going to return x. Then let's do the same thing for double, character, and string. So I'm just going to fast forward the video at this point. Alright, well, welcome back. So we have 4 different classes, one for my integer class, my double class, my character class, and my string class, and they all will hold one value of each of their respective types. Now let's say that we want to display all of these values, so we're going to use the first myInt.getValue function, and then let's put this within a println statement, so system.out.println, and then within the parentheses of this println statement, myInt.getValue, and let's do the same thing for my double, my character, and my string. So my double, my character, and my string. So this will display all of the values that we have that we sent to the constructor for each of their respective classes. Now let's do the same thing again, but this time instead of creating 4 different classes, we're going to create one generic class that can hold all of these different data types. So I'm actually going to delete all of these. I know it was a lot of work to actually build these, but hey, it's for the video. So let's get rid of these. And this time we're going to create a generic class that will function much the same. So file, new class. We'll call this my generic class. Finish. So to make a class generic, after the class name, we're going to add the angle brackets, and then people usually write T within here, but I like to write thing like I've mentioned before. So now this is a generic class. So now instead of specifying a specific data type that we want to store, we're going to store a thing. So we have a variable that has a thing data type. And then let's create the constructor for this class. So my generic class, and the parameter is that it's going to accept a thing called x. And this x equals x. Then let's work on the getter method for this, and this was public thing, because we're returning a thing, and it is called, I already forgot, get value. Get value. Return x. And now what we're going to need to do is change integer, double, character, and string all to generic to match my generic class. So let's just fast forward through this. So these should all say my generic class now. And you can see that these are all underlined, and let's take a look. So it says that there's a warning here that the constructor my generic class belongs to raw type my generic class. References to generic type my generic class, then it has the angle brackets with our thing, should be parameterized. So what this is telling us is that after these class definitions, we should add the angle brackets and then list the data type of what we're sending to my generic class. So with this number, this integer 1, we should list that we're sending this class, my generic class, an integer. And we're going to do the same thing with double, character, and string. So double, character, and string. And then just to get rid of this warning, we're going to add a empty set of angle brackets after this part of the definition. All right, so this will work the same as it has before, where all of these values are displaying, and we only had to do this with one class, one generic class. So with these instances of our generic class, you may have noticed that these are very similar to what we do to declare and instantiate an array list. So just as a refresher, we create an array list by typing in array list, then a set of angle brackets, and the data type of what we're storing within this array list, and this has to be a reference data type. So let's store an array list of strings, and this will be called my friends, and this will currently be empty. So my friends equals new array list angle brackets parentheses, and then we just need to import this. So you can see that the way that we instantiated this array list is very similar to what we did to create instances of our generic class. We list the class name, the data type within angle brackets of what we're storing. We need a name equals new, then the data type again. And then let's take a look at array list. So here's the class definition for our array list, and after the class name, you can see that we have the parameter for our generic class, the angle brackets, and for this one it just says E, but it really doesn't matter what you type within the angle brackets. So that's why with array lists, they're using a generic class, so we can store different reference data types. So we can store strings, integers, or even objects. It really doesn't matter. Since this is a generic class, we don't need to find a specific array list that can hold a singular data type. Like for example, we don't need to find a particular array list that holds integers. Then if we want to store doubles, we don't need a different array list. This array list is a generic class, so we can store whatever reference data type that we want within it. We just have to declare what we're going to store within it. So one thing you should be aware of is that sometimes with generic classes, there can be multiple parameters. So for example, between the angle brackets, you might see each value separated with a comma, and the second value is usually named V as a common convention, but I'll just name this thing 2 just for learning purposes. So my generic class now has 2 generic parameters, and we can no longer create instances of this class only by passing in a single value. So we also need to list the second value or the second reference data type that we're sending to these instances when we construct them. So let's say that to create this instance of my generic class, we're going to pass in an integer as well as another integer. And let's pass in maybe 2 doubles, 2 characters, and then let's mix up the next one. Let's say we're going to pass in a string as well as a character. So we're going to set up the constructor to accept a thing2 value or reference data type. So thing2, and we'll call this y, and let's set up the constructor. So thing2 will be y. So this y equals y. And let's return y this time. And we're going to change thing to thing2. So now we also need to send in another value of the matching reference data type that we have. So maybe I'll also send in 9, 1.01, maybe the money sign for the character. So for this one, this requires a string and a character. So I need to send in a character this time. So maybe the exclamation point. And then let's run this. So it looks like this worked just fine. We only wanted to return whatever our y value was, and that is the second value that we passed into our constructors for my generic class. So with our generic classes that have 2 parameters, this is very similar to our lesson on hash maps. So a hash map is a collection of key value pairs, and these accept reference data types. So let's say, for example, we have a hash map of different users for our website. So we can store maybe an integer, this could be the user ID, and their string, which could be their username. So this is very similar to how we created our generic classes that have 2 generic parameters this time. And let's take a look at our hash map class. So this is going to be very similar to our array list, except here that it has 2 parameters, k for probably key, and then v for value. But like I said before, it really doesn't matter what you type in here. Like array list had e, and I think that's for elements. But yeah, you can see that hash maps also have 2 generic parameters. Same thing with how we set up our my generic class. So one last thing I'm going to introduce for this video is the concept of bounded types, and that allows us to limit the scope of reference data types that we can send to a generic class. So my last topic for this video is to discuss bounded types. So this allows you to create objects of a generic class to have data of specified derived types. So for example, let's take numbers. So with my generic class, let's say that we only want to pass in numbers. Integers and doubles are fine, but we don't want to send in any characters, strings, or anything else like that. So what we're going to do after, let's say thing, we're going to have this extends the number class. So we can send in any reference data types, but it has to be a subclass of the number class. So here's a list for you. So here's some documentation for the number class. We have thing extends the number class, so we can pass in any reference data type as long as it's one of these subclasses. And many of these you probably won't recognize, like what the hell is an atomic long? But you can see here that we have the double class as well as integer, and you probably know of float and long as well, even though we really don't use them too often. Since thing extends number, you can say that the scope of the reference data types that we can pass in are limited to just this list. Any class that is a subclass of the number class, if we had thing extends a different parent class, we would be limited in our scope to a possible different set of subclasses. So that's why with our program, we are limited right now to sending in integers, doubles, and a few other things from that list. Like you can see, we can no longer send in characters and strings for the first value. So if we had thing2 also extends the number class, we need to send in 2 reference data types that have number as a parent class. So these first 2 lines would work just fine, but we can no longer send in 2 characters or a string and a character value. So let's just get rid of these for our example. And then let's get rid of these as well. And then if we were to run this, this will return the second value for our instances of our generic class. So that's pretty much it for this lesson. Hopefully your brain didn't explode from all of the information, and be sure to hit that like button before your brain does explode. So yeah, if you'd like a copy of everything that we've done, I'll post everything in the comments down below. But yeah, that's the basics of generics in Java. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys the basics of serialization in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's talk about serialization. So what this is that it's the process of converting an object into a byte stream. So the benefit of this is that an object persists. It saves the state of the object after the program exits. And the reverse process of serialization is deserialization. That's kind of a tongue twister to say. So deserialization is the reverse process of converting a byte stream back into an object. So think of serialization as you're saving a file with the object's information, and deserialization is as if you're loading a saved file. So serialization is taking an object and saving it to a byte stream. Deserialization is taking a byte stream and loading it back into an object. So this byte stream can be saved as a file or sent over a network, and it can even be sent to a different machine. So this byte stream can be saved as a file, and it usually ends with a .ser file extension, which is platform independent. So this is some very basic info on serialization. Let's do some practice on this. So let's create a new project, file, new Java project. I will call this serializer, and finish. Don't create. Go to your project folder, create a new class, file, new class, name this whatever you want. I'll name this main, check public static void main. And then let's create another class, maybe a class based on users. So file, new class, and I will call this user. So what I would like to do is to save the state of a user that we create. So what should all users have? Let's just have maybe two variables, a name and a password. Let's create a method too, but this has to be uppercase. There. All right, so let's create a method as well, public void. We'll call this say hello. All this will do is system.out.println hello name. Then let's go back to our main class and create an instance of this class. So user, we'll call this user equals new user. And then let's assign these variables. So we need a name and a password. So user.name, and these are public, so we can actually access these from our main class. So username equals bro. And then user.password equals I heart pizza. And then at the end, let's just call the say hello method. So user.say hello. All right, simple enough. We have an instance of the user class called user. So now I would like to save the state of this object. So I've listed the steps to serialize an object. So step 1, your object class should implement the serializable interface. So let's go to our user class, and we're going to implements serializable. Step 2, add this import, java.io.serializable. And we can simply just hover over this and add this import. So I'm also going to add this to our main class because we'll probably need it here as well eventually. So step 3 is that we need to add this line of code. So file output stream, we need a name for this, file outworks equals new file output stream, and then the file name or the file path. So let's add that. I'm actually going to get rid of this say hello method because we won't really need it. So step 3 is right here. We're going to add file output stream, file out equals new file output stream. And then let's add a name or a file path here. So I will name this file maybe user info.ser. So we'll also need to add this import. Actually, I'll just import everything related to java.io. So then we have our bases covered. All right, so we will eventually need to surround this with a try and catch block or add a throws declaration, but we'll do that later. So step 4, add object output stream. We'll name this out equals new object output stream and the name of our file output stream. So object output stream. We'll name this out equals new object output stream. Then within parentheses, we're going to place our file output stream instance within the parentheses. All right, so then we're going to write out.write object and then the object name. So out.write object and our object name is user. And then lastly, we're going to close everything that we've opened. So we're going to take out.close as well as file out.close. So most of this is underlined red, so we either need to surround everything with a try and catch block or add throws declaration, but just for simplicity, I'm going to add throws declaration just to keep things kind of simple. All right, and then let's display a message at the end. So we'll say something such as object info saved. And then let's run this. So object info saved. So if you go to your project folder, it really depends on where you place the file path. So this is going to end up within my project folder. You could place the file path for your desktop or something too if you want. So I'm going to refresh my project folder, and here is that file, userinfo.ser. And let's open this and take a look at it. So this is all Java bytecode. So this file saves the state of this object. You can see here that it says I love pizza and a few other things that might be recognizable, but it's all in bytecode though. So we can actually send this byte stream over a network or save it as a file and send it to a different machine. So what we're going to do in this project is that we're going to create another project folder called deserialize, and we're going to open this file and deserialize it and turn it back into an object. So let's do that. So I'm going to create a new project folder, so new Java project, and we'll call this deserializer. Finish, don't create. Then let's go to this project folder and let's create another main class. So name main or whatever else you want to call this, check public static void main, click finish. And then we're going to create an identical copy of this user class within our serializer folder. So I'm going to copy this, and then let's go back to our deserializer project folder, and I'm going to file, new class, and I will call this user as well so it matches. And then I'm going to copy everything within the user class from the serializer project folder. So these should match then, which they do. Okay, so I'm going to close out of everything related to the serializer project folder. And then we are now within our deserializer project. So here's the steps to deserialize a byte stream back into an object. It's really the reverse process of serialization, but there's one extra step though. So step 1 is that we're going to declare our object but not instantiate it. So we're going to say user equals, and instead of saying something such as new user, this creates a new user. So we're instead just going to say null for now. All right, so step 2, your class should implement the serializable interface. And we just copied this over from our serializer project folder. So make sure you have implements serializable, then make sure you have this import, but I'm also going to import this here as well for our main class. And I'll just import everything related to java.io. All right, step 4, we need to add this line of code. So when we serialized our object, we had file output stream, but this time it's file input stream because we're importing something. So file input stream file in equals new file input stream. And then we need the file name if it's local or the file path. So let's actually take a look to see where this is located. So this is within my serializer project folder. I'm just going to look at the properties of it. And this is the location. So I'm just going to copy this file path and then paste it within the parentheses. And then I need to surround this with a set of double quotes. And then all of these backslashes need to be double because that's the escape character. Step 5, object input stream in equals new object input stream and then the file in instance. So let's add that. Object input stream, we'll call this in, equals new object input. I really cannot spell today, I'm sorry. New object input stream file in. Okay, so that should be good. Then object name equals in.readObject, and then we're going to cast this as the data type of our class. So object name, that is actually user. So make sure it's whatever this object name is. So user equals, then we're going to cast this as our user data type in.readObject. And then we just need to close everything. So in.close, file in.close. Then we need to surround everything with either a try and catch block or add throws declaration. Then let's display some of the values from our user object that we're going to deserialize. So we'll system.out.println the user's name, as well as the password. User.password. And then let's also call the user.sayHello method. And then let's run this. So remember, for this class, I did not actually assign any of these values. We're actually going to be converting that byte stream back into an object, and that's how we get these values. So let's run this. Boom, there we go. Bro is the name. The password is I heart pizza, and it calls the hello method. So now if we went back to our serializer class, our main class, where we assign these values, and we were to actually change these and run the program again. So let's say we're going to update the name to bro code and the password to something secure such as password123. Compile and run this. So this will overwrite our ser file. We go back to our deserializer class, run this, and we have some new values for this object. So when you serialize, it saves the state of the object as a byte stream, and deserialize is to take that byte stream and rebuild it as an object. Next, here's some important notes related to serialization that we should be aware of. So number 1 is that any children classes of a parent class that implements the serializable interface will do so as well. Number 2, any static fields are not serialized. That's because they belong to the class itself and not any one individual object. And when we use serialization, we're really just taking the values of that object and we're saving them. We're having them persist so we can load it later. So any static field is really the property of the class and not any one object. So number 3, the class's definition is not recorded when we deserialize. So we need to cast it as the specific data type of that object. So you can see that in this line. So we're taking our user and we need to cast it as of this data type when we read this object. And if I were to remove this cast, it will cause a problem. And it says type mismatch cannot convert from object to user. So that's why we cast in this line of code back into our data type of our object. So number 4 is that any fields declared as transient aren't serialized, they're ignored. So let's actually practice this. So let's go back to our serializer class, the user class for this, and we're going to use this transient keyword for the password. Let's say that we don't want to send the password over. So we're going to type in transient, and then let's go back to the deserializer user class, and we're going to make sure this is transient as well because we want to make sure that these two classes match exactly. So let's take the serializer main class, run this. So object info saved. Let's go back to the main class for our deserializer, run this. You can see here that we have the name, but we have null for the password. That's because we marked this property, this value as transient. So this value is ignored. Anything that has the transient keyword is not serialized, it's ignored. Number 5, so this one's kind of a big one. So there's this value called the serial version UID, and it's a unique version ID for a class that is serializable. So let's dive more into this. So here's what I found on the serial version UID. It's a unique ID that functions much like a version number, and it verifies that the sender and the receiver of a serialized object have loaded classes for that object that match exactly, and it ensures that the object will be compatible between machines. It ensures that these two classes match exactly. It's like a secret code. It functions much like a hash where it's calculated based on the class's properties, members, and a few other things. We can actually take a look to see what this serial version UID value is going to be. So here I am within the main class of my serializer project folder. So we can actually declare and assign this serial version UID, and it's of the long data type. A long is really just a 64-bit integer, so it can hold a very, very large number. So it's of the long data type, serial version, I misspelled that, serial version UID equals, and these are the steps to actually retrieve what the current version is going to be. So we're going to type object stream class dot look up, and then within the parentheses we're going to type user dot get class. And then at the end of this, dot get serial version UID. And then we can simply just display this. Let's take a look to see what this is going to be. So this long number here is our serial version UID. It is actually calculated for us based on certain aspects of this class, much like a hash. So this example just so happens to begin with -764. And I'm actually going to copy this and paste this within the main class of our deserializer class. And then we can take a look at what this number is going to be. So since these two user classes match for our serializer and deserializer, these both have the same exact number for the serial version UID. So right now I'm actually going to go to the user class of our serializer class, and let's just change one aspect of this class. Let's say that we're going to rename say hello as instead greeting, and then we're going to run and compile this. Now for our serial version UID, a completely different number is calculated. So now this is technically a different version of our user class compared to our deserializer. So what happens if we were to actually attempt to deserialize this new byte stream that has a different serial version UID? So now we get this thing called a invalid class exception. And this is what happens when you attempt to deserialize a byte stream that has a different serial version UID. So you need to make sure that these serial version UIDs in fact match. and you can actually explicitly state what you want these numbers to be. I'm going to head back to the user class of our serializer class, and I'm going to change this back to say hello instead of greeting. So if you were to take a look at the class name, there's actually a warning, and it says the serializable class user does not declare a static final serial version UID field of type long. So we can actually, and it's actually recommended to do this, add a default or a generated serial version ID. So let's add a default one, and we can actually assign this as something. So let's say that we're working on version 1 of this class, and then if we want to update this to version 2, we can just simply change this number. So I'm going to assign this user a serial version UID of 1, and then let's run this. So now when it prints the serial version UID, this is now 1. Well, that's the basics of serialization. If you'd like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of serialization in Java. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys all about timer tasks in Java. And at the end of this video, we're going to work on a project where we can have a countdown timer that will display Happy New Year on New Year's Eve. So let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, I have two definitions here for you. The first is timer, and this is a facility for threads to schedule tasks for future execution in a background thread. And basically what this means is that it keeps track of the time in a background thread. And then we have timer task, and this is a task that can be scheduled for one time or repeated execution by a timer. So this is a class that contains an abstract method called run, and when our timer reaches a certain point, a certain time, it will execute a task either once or repeatedly, and we can have that task be whatever we want. So we're going to have a timer task that is linked to a specific timer. So let's begin by creating an instance of a timer. So we're going to type in timer, and let's just call this timer with a lowercase t equals new timer. And this will just keep track of the time, but we'll need an import, so let's add that now. So import java.util.timer. Now we're going to create a timer task. So let's add that to the next line. So timer task, and let's call this task equals new timer task, then a set of parentheses. Then we'll need an import for this as well. So make sure that you have these two imports. Now, an easy implementation of the timer task is to add an anonymous inner class. So with this timer task, we're just going to add a set of curly braces after this, and then we need to add unimplemented methods, and it's just the run method. So this timer task is going to be linked to this timer. So when time is up, it's going to execute this run function here. So when our timer reaches a certain point, it's going to execute this run function of our timer task instance. So you can do whatever you want within this run function, but let's just start with something simple for this demonstration. So I'm just going to create a simple print line statement that says task is complete. Now what we'll want to do is link this task to this timer, so we can use the schedule function of this timer instance. So I'm going to add that after our timer task. So type in the name of the timer, dot, and we can use the schedule function. And there's a few options here if you have IntelliSense. There's a few variations and different ways to do this, but we're going to start with something simple. So this schedule function has two arguments, a task and a time, and you can see that it filled in the tasks that we're going to use within this first argument, and the second is a time. So this is normally in milliseconds. So if you were to set this to 0 and we ran our program, this run function is going to execute immediately. So let's try it. And our task is complete. Now this is a delay, the second argument. So if we were to set this to 3000 milliseconds, there would be a 3-second delay. So you can see that it's not doing anything right now because it's waiting, and once that delay is over, then it executes our task. So for our next example, I just turned this line into a comment. So you don't have to necessarily just pass in only a numeric value. We can pass in a date here if we want this task to be completed at a certain date in the future. So we can actually do that utilizing the calendar class. So let's create an instance of the calendar class and set the date. So we're going to type in calendar, and let's call this date, equals calendar.get instance. And then we're going to set things such as the year, the month, the day, the hour, so on and so forth. So we're going to type in the name of this instance, dot set, and then within parentheses, we're going to type in calendar dot, and there's a few recommendations here if you have the IntelliSense set up. So let's set the year, and this is all in caps. And then we're going to add a comma, then we'll set this for 2020. And then we're going to do the same thing for like the month, the day of the month, the hour, so on and so forth. But I'm also going to change the clock on my computer just to demonstrate this. So let's have this task perform at like midnight this day, basically. So we're going to do the same thing here. And let's set the month. So month, and let's set this to June. So that would be calendar.June. And let's set the day of the month. So day of month. And we'll set this to June 20th. And then we'll do hour of day. So this is in military time. So if you want midnight, that's going to be 0. So it's 0 through 24, basically. And let's set the minutes. So calendar.minute. And we'll set this to 0. Then you can do seconds as well. So second. We'll set that to 0. And then milliseconds. Okay, so this task is going to execute at midnight, June 20th of the year 2020. So I'm actually going to fast forward the clock on my computer to demonstrate this. But first we actually need to add this task. So we'll add that after here. So timer.schedule task. And then for the time, what we're going to write is date.get time. And that's it. So let's run this. Okay, so here I changed the clock on my computer to just a minute before midnight. So once it hits midnight, it's going to execute this task. So we got 3 seconds, 2, 1, 0. Task is complete. Now for our third example, we're going to use a different method of the timer class, and that is the schedule at fixed rate method. And what this allows us to do is to repeat a task every so often. And I think this would be good for some sort of like countdown timer. So let's create something like that. So timer.schedule at fixed rate. So this will take a task, the time or delay of the first instance, or when you want this to be executed. And we're going to set this to 0 for now. And this third value is how often do you want this repeated? Let's say that we want this to repeat every 1 second. So we'll put 1000 here for 1000 milliseconds. So this run method is going to execute every second. So let's create a countdown timer. So we'll create a variable within here and let's call it counter and set this equal to 10. And within this function, let's create an if statement in place of this. So if counter is greater than 0, what we'll do is that we will just display whatever our counter is, and then maybe add seconds. And then we want to decrement our counter by 1. So counter minus minus. All right, so this is just going to keep on running. So we'll want some way to cancel our timer. So we'll add an else statement. And then within here, why don't we display something such as Happy New Year? So we'll system that out down print line, Happy New Year. And then in order for our timer to stop, we type in the name of our timer, dot cancel. All right, so since there's no delay on this, this is going to begin immediately when we run this. So let's try it. So it began at 10 seconds, and it's going to keep on going down until it reaches 0, and then display Happy New Year. So 2, 1, Happy New Year. Now let's take this a step even further. So let's have this task begin right before New Year's Day, like 10 seconds before New Year's Day on New Year's Eve, and then we'll have a countdown timer, and then once it hits 0, midnight of New Year's Day, it's going to display Happy New Year. So we can use schedule at fixed rate, and for the delay, we're going to use date.getTime. So I'm just going to copy this, paste it underneath for our next example, and we're going to use date.getTime in place of our delay here. And then we're going to set the day that we want this to begin. So let's set this to, let's set it to 2020, calendar.December, day of the month, the 31st, hour of the day. So this is in military time, so 23, minutes, 59, and then seconds, let's put 50 here. Okay, so I'm going to move the clock on my computer ahead to just before this time. Hey, you know what? Why don't I show you guys how to change the time on your computer? So I'm currently doing this with Windows. So I'm going to hover over the time, right click, adjust time. And I'm going to set the date and time manually. And let's change this to December 31st of the year 2020, 11:59 p.m. And let's change it and run this. Okay, so let's see the time right now. Okay, so we have about a minute. I'm just going to fast forward this video. All right, everybody, our task is about to begin right about now. So 10 seconds, 9 seconds, 8 seconds. I'll shut up now. So 4, 3, 2, 1, Happy New Year. All right, everybody, well, that's the basics of timer tasks. So you can execute some block of code either once at a specific time or immediately, or repeatedly, either immediately or at a set date in the future. So if you want a copy of all this code, I'll post this in the comments down below. And yeah, that's the basics of timer tasks in Java. How's it going, everybody? It's your bro here, hope you're doing well. And in this video, I'm going to be teaching you guys about threads in Java. So let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everyone, so for this video we're going to be discussing threads. This is going to be part 1 of 2, where this video is going to be focusing on explaining what threads are, and part 2 will be multi-threading. So a thread is defined as a thread of execution in a program. I know that kind of sounds redundant. It's kind of like a virtual CPU. And the JVM, the Java Virtual Machine, allows an application to have multiple threads running concurrently. So each thread can execute parts of your code in parallel with the main thread, and each thread has its own priority. Threads with higher priority are executed in preference compared to threads with a lower priority. So with the Java Virtual Machine, it will continue to execute threads until either one of the following occurs. The exit method of class runtime has been called, or all user threads have died. Then the program stops, basically. So when the JVM starts up, there is a thread which calls the main method, this right here. And this thread is called main. So it's kind of like the thread that starts or begins your program. So let's do some practice with the main thread. So with threads, we can check to see how many are active with a certain method. So we're going to type in the name of the thread class, dot, and use the active count method, and this returns how many threads are currently active. However, we need to put this within a print line statement so we can actually see it. So I'm just going to system.out.println and place thread.activeCount within here. And let's see how many threads are running. And it says one thread is currently running, and that is our main thread, basically. And we can also check to see the name of this specific thread. So we can use thread.current thread .get name. So this is going to return the name of the main thread, basically. And then we'll also need to put this within a print line statement. So let's just copy this and paste it within here. And I'll probably just turn this into a comment for now. All right, so the name of the thread that is currently running is named main, just like we had in that description just previously. We can also change the name of this thread too. So we can use the set name method of the thread class. So we're going to type in thread, and then we want the current thread, which is main. So thread dot current thread, and then what we're going to type is dot set name, and we can name this whatever we want. So how about main for no good reason? So when we display the name of the current thread, it's going to be main with a bunch of n's. It's probably not a practical name, I was just being silly. So all threads have a priority, and we can check to see what a thread's priority is. So if we want to check the priority of our main thread, what we're going to type is thread.current thread, which is referring to the main thread, dot get priority. And then, of course, we need to put this within a println statement. So system.out.println. Then I'm just going to place this within here. And the priority of our main thread is 5. So this is on a scale between 1 and 10. The higher the number, the higher priority for this thread. So we can actually change the priority for a thread. So let's change the priority for our main thread. So I'm just going to type in thread.current thread, which is referring to the main thread, and we're going to use the dot set priority method. So this is on a scale between 1 and 10. 10 being the highest priority, and 1 being the lowest. So if we changed this thread's priority to 10, and then we get the priority, it's going to display 10. So this main thread now has the highest priority, and if we changed it to 1, it now will have the lowest priority possible then. And one other useful method with threads is that we can check to see if a thread is currently alive. So what we can do is use the isAlive method. So if we want to check to see if our main thread is alive, we're going to type in thread.currentThread.isAlive, and then put this within a println statement. So system.out.println, and then we are going to type in thread.currentThread is alive, and it's going to check to see if our main thread is alive, and it says it is true. All right, so one other thing that you can do with threads is that you can have a thread sleep. So it's kind of like your program is paused. So why don't we make some sort of counter, and this will count down by seconds. So what I'm going to do is create a for loop, and we'll say int I, and we'll start at 3. We'll count down from 3. And then we'll continue this for loop as long as I is greater than 0. And then let's decrement I by 1 each time. And then what we're going to do within this for loop is just display whatever I is. And then we're going to type in thread.sleep. And then we can type in how many milliseconds we want this thread to sleep after each iteration of this for loop. So let's have this pause for 1 second, so it's kind of like we're counting down. Now you'll notice that this is underlined red. It says unhandled exception type interrupted exception, so you can surround this with a try and catch block or add throws declaration at the top here, and that error should go away. And then once we exit this loop, we'll just display a message such as you are done. Okay, let's try this. So normally when we have a for loop like this, it iterates through these almost instantaneously, but now if we had thread.sleep for 1 second, it's kind of like we're counting down by 1 second at a time then in 1 second intervals. So that's how you can use the thread.sleep method to have your thread or program sleep for a given amount of time. So now what we're going to do is actually create a second thread along with our main thread, and there's one of 2 ways that we can create another thread. I'll show you guys one way in this video, and in the next video on multi-threading, I'll show you guys another way. So one way is that we can create a child class of the thread class. So let's go to our project folder, go to File, New, Class, and let's call this My Thread. And this My Thread class will extend the thread class. So my thread is going to inherit everything from the thread class. there's actually this method called run within the thread class, and we're going to override that so my thread will do something else. So it's going to be a public method that is void, and it's called run. And since we're overriding this, we should probably add a note for good practice that says override, because we're overriding this method. So when run is executed, let's just display that this thread is running. Okay, so this is everything we need to do within our myThread class. So let's create an instance of myThread. So it's kind of like we're creating an object basically. So we're going to type in the name of the class, myThread, and let's call this thread2 equals new myThread. And this will create a second thread along with our main thread that is currently running. Now with the second thread, we can use some of these methods that we used for the first thread. So let's check to see if this thread is currently alive. So what we're going to type is the name of our thread. So thread2.isAlive. And we're going to put this within a println statement. So system.out.println. We're going to check to see if thread2 is alive. And this returns false. And this is the reason why. When you start a new thread or create a new thread, you need to start it so that it begins basically. So we're going to type in thread2.start. And this will start our thread. So this will display that this thread is currently alive. And also notice that it executed our run function, which just displays this thread is running. So it can be tempting to put run here in place of start. But if you were to check to see its status here, it's going to say that this thread is currently not alive, but it does execute our run function. So if you want this thread to start, you'll want to be sure to use the start function and not just the run function. So that's how you can check to see if a thread is currently alive. Let's go over a few others. Let's check to see what this thread's name is. So we're going to type in the name of our thread. So thread2.getName. And then put this within a println statement. So system.out.println thread2getName. And the name of this thread is thread-0. And remember with our main thread, that was just named main. So we can also change the name of this thread. So I'm just going to copy this. And before the println statement, we'll just type in thread2.setName. And let's change this to maybe second thread or whatever you want. So if we were to display the name of our second thread, thread2, it's now named second thread. Now let's check thread2's priority. So we'll type the name of this thread, thread2.getPriority, and then place this within a println statement again, system.out.println thread2.getPriority. And this has a priority of 5, which is the default basically. Now, if you have one thread that creates another thread, it's going to inherit the priority of the thread that created it. So if we went back to our main thread and we set the priority to, let's say, 10, the highest priority. So this priority of thread 2 is now going to be 10, since it inherits the priority of the thread that created it, which in this case would be main. So we can also set the priority like we did here. So that is the set priority method. So we're going to type in thread2.setPriority, and let's set this to 1. So thread 2 now has a priority of 1. Then compared to our main thread, this by default has a priority of 5. So the main thread has a higher priority than our thread 2 thread basically. So one other thing we can do is that we can check to see how many threads are currently active, kind of like what we did with our first example. So we're going to use the thread.activeCount, and I'm going to copy this and paste it, and it's going to display how many threads are currently active, and it says 1. That's because we need to start thread 2. And now the amount of threads that are currently active is 2, because we needed to start thread 2. Now, we have one last thing to discuss. There's two different kinds of threads. They are user threads and daemon threads. That sounds kind of cool, right? So a daemon thread is a low priority thread that runs in the background to perform tasks such as garbage collection, and the Java virtual machine terminates itself when all user threads, which are non-daemon threads, finish their execution. So if we were to create another thread, this would normally by default be a user thread, a non-daemon thread, but we can actually change it so it is a daemon thread. First, let's check to see if it is a daemon thread. So there's actually a method for this. We type the name of the thread, so thread2 dot, and we'll use the isDaemon method, and then we need to put this within a println statement. So system.out.println thread2.isDaemon, and then we'll display this and run it. So it says false. So this thread is not a daemon thread, but we can actually set it so it is. So we're going to type in thread2.setDaemon.true and run this again. And it says true, so this is a daemon thread, and it runs the program. Now we can actually change the myThread class, and we can check to see if this is a daemon thread. So if this dot is daemon will display this is a daemon thread that is running. Otherwise, else will just display system.out.println this is a user thread that is running. All right, so if we were to revert this back to false, it displays this is a user thread that is running, and if we change this to a daemon thread, it's going to display this is a daemon thread that is running. So like we said with daemon threads, they are low priority threads that run in the background to perform tasks such as garbage collection, and the Java virtual machine will terminate when all user threads, which are non-daemon threads, finish their execution. So it's kind of like the Java virtual machine doesn't care if there's daemon threads running in the background. It'll exit regardless, as long as all user threads finish their execution. So it's kind of like daemon threads are low priority, kind of like what we did with setting the priority for threads. So that's the basics of threads. It's kind of like a virtual CPU that has its own set of instructions, and we can have multiple threads running concurrently at the same time. And another definition for this is multi-threading, and that's something we'll cover in the next lesson. So that's the basics of threads. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of threads in Java. How's it going, everybody? It's your bro here, hope you're doing well, and in this video we're going to be discussing multi-threading in Java. We're going to be counting up and counting down at the same time. How about that? Let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's discuss the definition of multi-threading real quick. So this is the process of executing multiple threads simultaneously, and it helps maximize the utilization of your CPU. And with threads, they are independent, so they do not affect the execution of other threads, and an exception in one thread will not interrupt other threads since they run independently. And this is useful for serving multiple clients, multiplayer games, or other mutually independent tasks. So let's do some multi-threading right now. So what we're going to be doing for this example is that we're going to create two separate threads, and each of these is going to have basically a sub-program. In the first thread, we'll create a simple counter that will start at 10 and count down to 0. And in the other thread, we'll do the same thing. We'll have a counter, but let's start at 0 and then count up to 10. And both of these threads are going to run at the same time and display the results as they continue. So there's two different ways of creating a thread. The first is that we can create a subclass of the thread class. So let's try that. So within your project folder, go to File, New, Class, and let's call this maybe myThread. It doesn't really matter, just make sure that this subclass extends the thread class. And then we're going to need to override the run method of the thread class. So we're going to type in public void run, parentheses, curly braces. And since we're overriding a method, it's good practice to add at override, although it's not necessary. So when we start the instance of this thread class, it's going to execute this run method. So let's create an instance of myThread within our main class. So we're going to type in myThread or whatever else you named this. Let's call this first thread thread1 equals new myThread. All right, so when we eventually start this thread, it's going to execute this run function. So what do we want this to do? Well, this is a great time for us to place our counter program within here. So we can do this with a simple for loop. So we'll start at 10 and then count down to 0. So we'll put for int I, set this equal to 10. We'll continue I as long as I is greater than 0. And then we'll decrement I by 1 after each iteration of this for loop. So within this for loop, let's just system.out.println, maybe thread number 1, and then we'll display whatever the current value of I is. So we don't want this to run like instantaneously. Maybe we would like some sort of like pause for like 1000 milliseconds between each of these iterations to simulate like a countdown. So what we can do is just type in thread.sleep. Then within here, we want this to sleep for 1000 milliseconds after each iteration. And then since we're using this method, we have to surround this with a try and catch block. So make sure you put that in as well. All right, so then once we exit this for loop, let's just display a message such as thread number 1 is finished. All right, and that's all there is to it. So there's another way that we can create a thread. So the other way is that we can create an instance of a class that's implementing the runnable interface, and then we can pass this instance within the constructor of a thread object. But I'll show you how to do this. So within your project folder, go to File, New, Class, and we're going to be implementing the runnable interface. So let's call this class maybe myRunnable, and click Finish. So we're going to have myRunnable implements runnable, and then we need to add unimplemented methods. So since we're using an interface, we need to use all methods that runnable have within its interface, and that is the run method within here. So going back to our main class, what we're going to do is create an instance of myRunnable. So myRunnable, and let's call this runnable1 equals new myRunnable. Now the second step is that we're going to take runnable and send this within the constructor as an argument within the thread class when we create an object. So we'll type in thread not myThread, and let's call this thread2 equals new thread. And then within the parentheses of thread, just place your runnable instance within here. So this is the other way of creating a thread. Use a subclass or a class that's implementing the runnable interface, create an instance of it, and then pass it as an argument to the thread class. So there's two ways in which you can create a thread. The first way is that you can create a subclass of the thread class. So you just create a class name and make sure it extends the thread class, and then you have access to a run method. And the other way is that you create a class that implements the runnable interface, and then you take this instance and pass it as an argument to the constructor of the thread class, and then that's how you get your other thread. So you can do it either way. It depends on how you want to write your program. Like for this example, we could have done like thread 1 and thread 2 by using the myThread class. Otherwise, we could have done like myRunnable2 and thread 2 the other way. But for this example, I wanted to show you guys both ways. But yeah, you basically have two different ways of creating threads. Personally, I tend to prefer to use the runnable class or the runnable interface and then pass this instance as a constructor to the thread class, because with this class, you can still use inheritance, like we can extend another class. But if you use this class as a subclass of the thread class, well, in Java, you can only have one parent, so we can't like have another class as a parent. We're limited to just one, the thread class. However, we can implement another interface. So just from my own experience, people tend to use the runnable interface more compared to extending the thread class. But do what works for you, though. But I'm getting off track again, so we should probably finish this program. So we need to fill in the run method of the myRunnable class. So what we can do, actually, is go to the myThread class and copy everything here and make a few changes. So I'm going to copy this, and then paste it within the run method of the myRunnable class. So instead of counting down from 10, let's count to 10 starting from 0. So we'll set I equal to 0. We'll continue this as long as I is less than 10. And then we're going to increment I by 1 each time. And then let's change system.out.println thread number 1 to thread number 2. And then down here, after we exit this for loop, we'll display thread number 2 is finished. Alright, so that should be everything. So let's go to our main class. We're going to start thread 1 and thread 2. So we'll type in thread1.start, as well as thread2.start. And that's it. Let's run this. So thread 1 starts at 10, thread 2 starts at 0, and you can see that they're both either counting up or counting down, depending on, which one is running. But you can see that they're both running at the same time, and they finished at the same time. So that's one of the great benefits of multi-threading, because it's kind of like you can make your own subprogram that runs independently. So, ladies and gentlemen, we have successfully multi-threaded. And one of the great things about multi-threading is that if one of these threads encounters an exception and gets interrupted, the other threads will still continue. So let's actually intentionally cause an exception. So within the run method of the myThread class, let's divide a number by 0, which we can't mathematically do. So I'm actually going to fit this maybe within the for loop. So what I'm going to do is just within a println statement, I'm going to divide number 1 by 0. So this will throw an arithmetic exception. And let's see what happens now. So you can see right off the bat, thread 1 encountered an exception. The technical name of the first thread is thread-0, but that is thread 1 for all intents and purposes. But you can see that even if our thread 1 stopped, thread 2 still continued along with our main thread. So let's actually take this and then move it within our main class. So how about after these threads start, thread 1 and thread 2, we'll divide by 0 right after these threads start. So it says exception in thread main, but these threads are still continuing. So that's proof that threads can run independently, and if one thread encounters an exception, the other threads will continue still. Now, there's one method I want to talk to you guys about, and that is the join method. So the calling thread that calls this join method will actually wait for a specified thread to die until it resumes. So let's say that we want thread 2 to start right after thread 1. So what we'll do is type in the thread that we're waiting to die, or finish, basically. Let's say thread 1. So what ends up happening is that if we type in thread1.join, we're going to pause our main thread until thread 1 is completely done. And then we'll need to either surround this with a try and catch block or add throws declaration, which I did at the top. So if we type in thread1.join, the main thread is going to wait until thread 1 is finished, and then it's going to continue on with the rest of the program. So let's try it. So thread 1 is running right now, but thread 2 doesn't appear to start. And then once thread 1 is done, thread 2 will start because our main thread resumes with the rest of the program. So it says thread 1 is finished, and then thread 2 started right after that. So you can also put an amount of milliseconds in here, and that allows for like a delay. So for example, if we put 3000 milliseconds in here, the main thread is going to be paused for 3000 milliseconds before the main thread will continue. So let's try it again, but place 3000 within here. So it's going to wait 3 seconds before thread 2 begins, and that seems about right. So then thread 1 is about to finish, and then thread 2 is going to finish a little bit later, right about now. With the join method, the calling thread, and for this example, it's the main thread, will wait until the specified thread dies or for X amount of milliseconds. Hey, you know what? I forgot to talk about daemon threads in this video, so I should probably do so before we wrap things up. So a daemon thread is a background thread. It is a non-user thread. So user threads and daemon threads are kind of like opposites. So the Java virtual machine will not wait for any daemon threads before exiting, but as long as there's one user thread, the Java virtual machine is going to wait to exit until all user threads are finished. So let's take our previous example where we divided a number by 0 within our main class. So what we did for this example is that the main thread encountered an exception, but these other 2 user threads are still running. So since there's at least one user thread that is still running, the Java virtual machine will not exit until all user threads are complete. But if we were to set these as daemon threads, well, the Java virtual machine is going to exit then as soon as all user threads are finished. So let's change these to daemon threads. So we'll take thread1 dot set daemon and set this to true. And we'll do the same thing for thread 2. So thread 1 and thread 2 will no longer be user threads. They are the opposite, basically. They are daemon threads. And when we run this program, well, we don't get that countdown anymore. We have an exception in thread main, and the Java virtual machine actually terminated because there were no more user threads. We had some daemon threads running in the background, but they terminated because the Java virtual machine doesn't care if they're running. It'll exit regardless. So that's the basics of multi-threading, and just as a reminder before you go, there are 2 different ways of creating threads. I just so happen to use both of these ways for this example. You can either create a subclass of the thread parent class, or you can implement the runnable interface and pass that instance as an argument to the thread constructor. So you can do it either way. You might have a preference for one or the other, but for this example, I just did one of each. You don't have to do it exactly the way that I did. So yeah, if you want a copy of all this code, I'll post this in the comments down below. And, well, that's the basics of multi-threading in Java. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys about packages in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Have you ever wondered what we're doing exactly whenever we add an import to the top of our program? Well, today's your lucky day because we're going to uncover this mystery. So a package is a bundle of related files that we can use in our programs. So with our main class, I have this class within our default package. Now we can create another package within our project folder. So let's create a package, let's say tools. So we're going to right click and we are going to create new package. And I'm going to call this tools. Maybe it contains some useful tools that we can use, and click finish. So now within my source folder, I have a package called tools. And what we can do with this package is that we can actually add some classes or other files to this package. So I'm going to create a new class, and I'll call this class maybe toolbox, and click finish. All right, so we have this class called toolbox, and notice that at the top of this program, it says package tools. So if I actually were to take this out, it's actually going to yell at us and we'll have an error basically because there's an expected package. So if you have some class or files in another package that's not your default package, you'll probably need to specify what package it's in at the top. However, if you're working within the default package, you actually don't need to do this. Now that we have our tools package created, let's create an instance of this toolbox class. So within my main class, I'm going to type in the name of the class. So that's toolbox, and let's call this toolbox with a lowercase t equals new toolbox. Okay, so you can see that we have a problem, and it says that toolbox cannot be resolved to a type. That's because we need to import this package tools. So it's kind of like what we do with any other import. So we type in import, then the name of the package, which is tools. Then we can import either everything or something specific. So let's import this toolbox class. So toolbox semicolon. And you can see that that error went away, and we can now create an instance of this toolbox class that's located within our tools package. Now, in past lessons, whenever we imported a package, for example, icons related to JavaX's graphical user interface of Swing, what we've been doing is importing a package within our JRE system library, and this is something that we had downloaded during lesson 1 when we installed the JDK, the Java Development Kit. So let's actually explore this JRE system library and see if we can find this file related to icons. So it was import javax.swing.icons. So that's located within our JRE system library, and it's within this jar file called java.desktop, and there should be a package for javax.swing located right here. So here are all the related files for javax.swing, and icons should be right here. So let's actually take a look at this. This is more specifically an interface. So this is everything that is written for the icon class, the icon interface. So there's not really much here. There's a few methods and a bunch of notes by the developers. So whenever we import something, at least in past lessons, we've been importing these packages from the JRE system library located within our project folder. So that's the basics of packages in Java if you want a copy of this code. Well, really, there's not much here, but I'll post this in the comments anyways. But yeah, that's the basics of packages in Java. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can compile and run Java programs using command prompt. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everybody, so we're going to compile and run a Java file with command prompt, and I made this cheat sheet here, and I'll keep this up as we're going through the steps, and I'll also post this in the comments down below if you'd like a copy of all the steps. So let's begin with step number 1. We have to make sure we have a Java JDK, a Java Development Kit installed, and we did this in lesson 1. So let's just be sure that we have it. This is how to find your JDK. So I'm going to go to my C drive that is located right here. It's within program files, the Java folder, and here are the JDKs. So I actually downloaded the most recent version that came out recently, so that's why I have two. So if you're missing the JDK, just go to any web browser and look up Java JDK download. It's going to be this first link, and then go to JDK download and select the appropriate file for your operating system, and that is step 1. Now with step number 2, this is completely optional, but we don't always necessarily need to rely on an IDE like Eclipse or IntelliJ IDEA to create a Java file for us. We can write Java code using a text editor such as Notepad. So let's actually do this for practice. Let's create a simple Hello World program. So I'm just going to open up Notepad, and then we're going to type in public class and the name of a class. So let's call this class Hello World. Then we need a set of curly braces, and then we need to create a main method within this class. And this is the starting point of the program. So that's public static void main parentheses. Within the parentheses, we type in string straight braces args. I think I'm going to zoom in a little bit. So I'm just holding Control+ to zoom in. And then we need to add a set of curly braces for this main method. Okay, and then let's create a print line statement. So system.out.println parentheses semicolon at the end. And let's display a message within double quotes. So maybe bro says to subscribe or else. And now once you finish your code, what we're going to do is save this to a convenient place. So I'm just going to save this to my desktop. And what we're going to type for the file name is the name of the class. Match this exactly. It is case sensitive as well, so that's hello world. And the important part is to type in .java, so we're using the Java file extension, and we'll click save. All right, and here is my Java file. I'm just going to open this up, and here it is. All right, let's move on to step 3. We're going to open command prompt, or if you're using Mac, I believe that is terminal on your computer. So I'm going to look up command prompt. Okay, now the first thing that we're going to do is we're going to set the path to where our Java development kit is. So we can actually look this up. So I'm going to go to my C drive. That is here. It's within program files, within the Java folder. Then click the latest JDK that you have. And then we're going to go to the bin folder. Then we want to copy this address. So I'm just going to right click, copy address. And then we're going to set the path to this address. So set path equals the path to your JDK, the bin folder, and hit enter. All right, so that is step 4. Now step 5 is that we're going to change the directory so it's pointing to your location for your Java file. So cd, and then let's get the address for this file. So properties, and I'm going to copy this location. So cd and the address. So the directory changed to my desktop here. Now we can compile this Java code to bytecode, which is actually portable. So on step 6, we're going to type in Java C for Java compile, and we're going to compile our hello world.java file. So make sure you get the capitalization right, and make sure that this ends with .java, and hit enter. So nothing appears to happen, but that's okay though. So now we have this class file, and this is actually bytecode, so it looks like it's in an alien language. So this is Java bytecode. If you remember from the very first lesson, we take a Java file and compile it to bytecode, and bytecode is actually portable between different operating systems and machines. So if I wrote this with a Windows computer, this file is portable to, let's say, a Mac, but that Mac would need a JRE, a Java runtime environment, but that usually comes with the JDK that we installed. So let's actually run this now. So this is a .class file, and let's take a look at that. And our Java file was a .java file. So if we want to run this .class file, what we type in is Java and the name of the file. So that's hello world, and hit enter. And it runs our program, and here it says, bro says to subscribe or else. Now here's another thing that you can try. Let's take a Java project that we've made in the past. I'll take this stopwatch program that I made, and there's actually a GUI component with this. So this contains at least 2 different files. So I'm going to copy this and place this on my desktop. All right, and then we can actually run this using command prompt. So what we actually need to find is the class file that contains the main method. So that is located within the bin folder of this project, and that is right here for main. All right, so here's that class file, and actually if you look in the source folder, these are the Java files that we compile. So we need to run this main file within this folder. So let's go through the steps. We have a JDK installed. We're going to open command prompt, which we have. We'll need to set the path, so let's do that real quick. So we'll make sure we set the path. Okay, we're good. And then we're going to change the directory of where this file is located. So let's find the address for this. So that is within here. So I'm just going to copy this address, and we're going to type cd and the address of this file. All right, and then this is already compiled, so we can skip this step because it's a class file already, so there's no need to compile. All we need to do is type in Java and the name of the file that contains the main method. So that is, for my project folder, main. And when I hit enter, it's going to run my stopwatch program. So that's the basics. I'll post these steps in the description and in the comments down below if you would like a copy for yourself. But yeah, that's how to compile and run a Java program with command prompt. How's it going, everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can turn our Java programs into an executable application. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, so I'm going to be splitting up this video into different sections because it seems like you guys for the most part are either using the Eclipse IDE or IntelliJ IDEA, so I'm going to teach you guys how to create executable jar files using each of these. So I'll be splitting up this video into sections and I'll include some timestamps in the description. I also have all of these steps written out if you would like a physical copy of these. I'll copy and paste this and post this in the comments down below if you'd like to follow along step by step. So let's begin by creating an executable jar file with the Eclipse IDE. So here I am within the Eclipse IDE. Now within your Package Explorer, select a project that you want to create an executable of. So select one that has a GUI component so you can actually see it. So let's say that I want to create an executable of the stopwatch program. So what I'm going to do is right-click this project folder, go to Export, go to the Java folder. Let's pretend that that wasn't open. And then you can either make a jar file or a runnable jar file. So I'm going to select runnable jar file and click next. And then for the launch configuration, make sure that this is set to the main class of your project. So one mistake that I made, I actually have two stopwatch programs. I have one that's spelled slightly differently, so that was giving me some problems. So make sure you select the right project. It also doesn't help that I have like a billion projects within here. Now, for the export destination, you can choose where you want this to be exported to. So I'm just going to save this to my desktop. So this is going to be named stopwatch, and it's a jar file. Click Save, and then we are going to click Finish. And then it's okay if we have some warnings, so I'm just going to click OK. Let's go to my desktop, and here is the executable jar file, so let's take a look at it. It's an executable jar file. The file extension is .jar. And when you click on this, it runs my stopwatch program. So now let's do this with IntelliJ IDEA. So here I am within IntelliJ IDEA. So if you're using this IDE, this is how to make an executable jar file. So I have this very same stopwatch program from the demonstration using the Eclipse IDE. So I want to create an executable of this project. So what I'm going to do is go to File, Project Structure, and then I'm going to go to Artifacts, click this plus button, jar, and then from modules with dependencies. So make sure this module is selected for your project. Then we need to find the class that contains the main method, and this is usually main. And then click OK. Extract to the target jar, that's fine. And then click OK. Now within this project structure window, if you want, you can change the output directory. So I'm actually going to change this to my desktop for convenience. So let's click on my desktop and click OK. Then apply, and then OK. And the last step, go to the top of this window for your IDE, go to Build, Build Artifacts, and then Build. So this jar file is going to be sent to my desktop momentarily. There it is. And let's run this. And here is my stopwatch program. Now, one question that you might be wondering is how can we change the icon for this executable jar? Well, we normally can't change the icons for a jar file. It's more of an operating system sort of deal. So one thing that we can do is use an executable wrapper with the help of some third-party software. But the first thing that we're going to need is an ICO file. So you can actually take any image, well, most images, and we can actually use some third-party software to convert this to an ICO file. So let's say that I want to use this stopwatch image that I made here. Well, it's really just an emoji that I expanded, but it's a PNG file. So I'm going to want to convert this to an ICO file. So one website I recommend that's been pretty good to me is icoconvert.com. So let's head there. Or you can just do a Google search. I don't care. Do whatever you want. So I'm just going to click this first link, and this is icoconvert.com. All right, so we're going to choose a file. I'm going to select this stopwatch. And here it is. So I'm going to open this and upload. So this website has a few limitations. It has to be PNG, JPG, or BMP. And then there's some other things you can do if you want to format this. All we need to do is click Convert ICO at the bottom and download your icons. Alright, so I moved that file from my downloads folder to my desktop, and I just got rid of the old PNG file. So let's right click on this just to be sure it's an ICO file for icon. So that's everything that we need. Now, there's another third-party software that's pretty helpful. We're going to use launch4j to create an exe with this custom icon. So this is the URL. I'll also post this in the description. So here's the website, launch4j.sourceforge.net. And then if you need to download this, there's a download tab on the left-hand side, and you can select the appropriate download for your operating system. So once that's downloaded, open it up. So here's the launch4j program. So there's a few things that we need to do. First, we need to select the output destination for this exe file so we can browse for a location here. I'm just going to set this to my desktop. And I am going to name this stopwatch.exe. The .exe is important. Click Save. And next we need to select the appropriate jar file. So this is also on my desktop, so I'm going to select this. And it is stopwatch.jar. And open. And then if you have an icon that you want to use, remember this has to be an ICO file. And that is this one. And click Open. And lastly, we need to set the bundled JRE path. So we need to place the path of where our JDK is located. So we can actually find that within our C drive. So my JDK is located within the C drive, program files, the Java folder, and then select the most recent JDK that you're using. And then I'm just going to copy this address by right-clicking, copy address, and then I'm going to paste this within bundled JRE path. And lastly, we just need to click on this gear icon, and this is to build wrapper. And then this is going to create a launch4j config file. You can name this whatever you want. We're just going to delete this right away afterwards and click Save. All right, here is our stopwatch executable program, and it has the icon that we used. So we actually no longer need these three things. This is the jar file, the ICO file, and that test config file that we just made. So I'm just going to get rid of these. And here is the file that we wanted. So this is an exe file. It's an application. And if we were to click on this, it's going to run our designated Java program. So hopefully this walkthrough worked for you. I'll post all of the steps that I have written here in the comments and in the description down below. But yeah, that's how you can turn your Java program into an executable application. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.